Hello, my dear student friends. Welcome to the marathon classes conducting by Masterminds, which is a prestigious educational institution in giving CF coaching at all cadres like CA Foundation, CA Inter, and CA Final. So, the main aim of these marathon classes is to have a quick revision about the syllabus of CA Foundation course. In this regards, myself, V. Ravishankar, a statistics faculty, is here to give you a quick revision in the subject statistics as a part of the marathon classes. I hope all of you are very enthusiastic and very eager to have a quick revision in the subject statistics. So let us start today's class with our first chapter called Statistical Description of Data Part 1. Since these are the marathon classes, these are the classes aimed to have a quick revision, so it is not possible to cover each and every point in the syllabus. That's why here we are going to cover the most important aspects in each chapter, as well as the most important problems of models, to get a quick revision in the subject. So first, let us start our first chapter, Statistical Description of Data Part 1. So in this chapter, first of all, we need to know the definition of statistics. First of all, we need to know the definition of statistics. So the word statistics can be expressed in singular sense as well as plural sense. In a singular sense, it may be defined as a scientific method. The statistics is defined as a scientific method or the scientific techniques that is employed for collecting the data, presenting the data, and analyzing the data. So in singular sense, statistics means it is a scientific technique for collection of the data. There are so many kinds of methods are there in collecting the data and presenting the data. After collection of data and after classifying the data, we need to present that data in a proper format. So what are the different kinds of presentation techniques are there can be explained using the statistics definition. All those techniques, all those scientific techniques comes under this definition. Similarly, analyzing the data after presenting in a proper format like as a tabulation format or a diagrammatic format, after presenting the data, we need to analyze the data. In analyzation, we need to study about the inherent patterns existed in the data. So, what are the different techniques of analyzing the data? Those different techniques comes under the subject of statistics. Finally, after analyzing the data, finally we are leading to drawing statistical conclusions about some particular important characteristics of the data. After analyzation of the data, the results obtained from the analysis can be concluded in a proper way, in a simple way and in a proper way. So all these techniques, all the scientific techniques for collecting, presenting, analyzation of data is the definition of singular sense of subject statistics. Similarly, in plural sense, it may be defined as either a qualitative data or quantitative data that are usually collected with a view of having statistical analysis. So qualitative data means the data which cannot be measurable by using some kind of instrument is known as qualitative data, like gender, marital status, qualification, religion, caste category, occupation, etc. are all the examples of qualitative data which are non-measurable. Whereas the quantitative data is the data which can be measurable by using some kind of instrument. Measurable means, like for example, measurable data example is either height, weight, length, circumference, age, marks, etc. So either a qualitative data or a quantitative data with a view of having some kind of analysis is known as statistics in plural sense. And also then several authors gave several definitions also. And next one, in the next question, there are some commonly used terms which are very helpful in this chapter as well as for the further chapters also. Among all these definitions, mostly we need to have an idea about characteristic, data, and attribute, variable. We need to know about all these definitions, most importantly. So first, what do you mean by characteristic? Characteristic is a quality possessed by an individual person. For every individual person or any individual object, there are certain qualities are there, like height of a person, age of a person, color of a person, weight of a person. Similarly, for any kind of objects also, color of an object, weight of an object, height of an object, and life of an object, like that. So there are several qualities for each and every individual person and each and every individual object. Those qualities are known as characteristics. For example, height of a person, age, nationality, etc. Data means a well-known information about a particular characteristic which can be expressed in numerical figures. Data is a well-known information about some particular characteristic which can be expressed in numerical figures obtained by measuring or counting. So data, the word data is a plural word, whereas the datum is a singular word. And after having an idea about the data, then there are some classifications of data. In the data, we are having two parts. One is called a variable and second one is called attribute. Attribute means non-measurable information is called an attribute. Either non-measurable information or qualitative data. The qualitative data itself known as non-measurable information. For example, gender of a baby, religion, nationality of a person, color of a flower, occupation, etc. Similarly, variable means a measurable information is called a variable. And also it is known as quantitative data. The quantitative data is also known as variable. So a measurable quantity means that can be measured by using some kind of instruments. By measuring or by counting also. Marks can be countable. And number of students in a class can be countable. Age can be measured in terms of years and months. Height can be measured in terms of centimeters or inches or feet. So that all these examples comes under the list of variables. Next one, in this variable can also be furtherly classified into two types. one is called a discrete variable and second one is called continuous variable. So most of the students are getting confusing with this discrete variable and continuous variable. A variable assumes a finite or countably infinite number of isolated values is known as discrete variable. What do you mean by a finite or countably infinite number of values? What do you mean by a finite or countably infinite number of values? Finite number of values means limited number of values. Finite means limited number of values. Limited number of values. Then what do you mean by countably infinite number of values? What do you mean by countably infinite number of values? Countably infinite number of values means the values which are able to count. The values which are able to count. Whenever we are able to tell the value of any position of that particular series, then those values are said to be countable. For example, number of accidents in a particular locality. Number of accidents in a particular locality. All these values of number of accidents may have the values like 0 or 1 or 2 or 3 and so on. Any number of accidents may occur in that particular locality. Right? Here in this series, whenever we are able to tell the value of any position, then those values are said to be countable. For a values to be countable, first those values should be infinite. So in this series, the first value of number of accidents is 0, second value is 1, third value is 2. Similarly, nth value of number of accidents is n minus 1. By using that relation, we can count the value of any position. We are able to tell the value of any position in that series. Such kind of values are known as countably infinite number of values. If a variable assumes finite or countably infinite number of values, then that variable is said to be discrete variable. For example, number of petals in a flower, number of misprints a book contains, number of road accidents in a particular locality, number of workers in a factory, etc. Similarly, continuous variable means a variable known as continuous if it can assume any value from a given interval. In discrete variable, we cannot assume the decimal values in between the different mass points of the variable. In this example, in the example of number of accidents, there will not be considered 1.5 accidents, 2.2 accidents like that. We cannot assume the values between these two unequal values. We cannot assume the values between any two unequal values in discrete variable. If we are going to assume any value from a specific interval, then that variable is known as continuous variable. For example, temperature, time, size of agricultural holding, etc. And nextly, most importantly, describe the different types of data. In this question, most importantly, you need to know about the individual series as well as the frequency distribution. This frequency distribution is further classified into two types. One is simple frequency distribution and second one is grouped frequency distribution. So there are totally two types of frequency distributions are there. Simple frequency distribution as well as grouped frequency distribution. So now, what do you mean by individual series? Under this method, the values of all units of a particular characteristic are shown separately, either in ascending order or in descending order. Then those values are known as individual series. Like the marks obtained by 10 students in a class, or the number of defects in a batch of 10 items, like that. So if you write all the values of that particular characteristic separately, then that series is known as individual series. Similarly, next one is to know about the frequency distribution. First, we need to understand the word frequency. What do you mean by frequency? Frequency means the number of times that particular value repeated. I think this definition has been studied from our lower classes itself. Frequency means the number of times that particular value repeated. And discrete series or simple frequency distribution. This discrete series is also known as simple frequency distribution. The frequency distribution of discrete variables is known as simple frequency distribution. The frequency distribution of discrete variable is known as simple frequency distribution or discrete series or discrete frequency distribution. So what do you mean by a frequency distribution first? The frequency distribution means the values of a variable along with their corresponding frequencies is known as frequency distribution. The values of a variable along with their corresponding frequencies is known as frequency distribution. If that variable is a discrete variable, then that distribution is known as simple frequency distribution or discrete series. Here in this example, number of workers is my variable and number of factories is my frequency. So this variable assumes only 5 values, 100, 90, 70, 60 and 30. This variable assumes only 5 values. That means a finite number of values are there. So that variable is known as discrete variable. The discrete variable along with their corresponding frequencies is known as discrete series. And the next one, continuous series. The series dealing with the continuous variable is called continuous series, or this continuous series is also known as grouped frequency distribution. Grouped frequency distribution. The values of a continuous variable along with their corresponding frequencies is known as grouped frequency distribution or continuous series. In this example, here the daily income is my variable. The values of these variable may assume any value between 0 to 100 or any value between 100 to 200, any value between 0 to 500 totally. So here the values of daily income may assumes any value in a specific interval. So that's why here daily income is a continuous variable. So the values of continuous variable along with their corresponding frequencies is known as continuous series. In this continuous series, each interval is known as class. Each interval is known as class. Each stated interval is known as class. And so next one, class frequency. Class frequency means the number of observations belongs to that particular class is known as class frequency. And total frequency means the sum of all the class frequencies is known as total frequency. Here the class frequency for 0 to 100 is 15. class frequency for 100 to 200 is 7, class frequency for 200 to 300 is 25, class frequency for 300 to 400 is 10, and so on. And the total frequency is 40, 50, 63. And the total frequency is sum of all the class frequencies, that is 63. And this total frequency is always denoted by the letter capital N. And now, after having an idea about the individual series, discrete series, and continuous series, we need to know about the types of continuous series. There are several types of continuous series. The first one is inclusive series. Inclusive series means this type of classification is meant for discrete variable. That means if we construct the continuous series for a discrete variable, then we do not have any kind of loss of information. If we construct the inclusive series of intervals for a discrete variable, then do not have any kind of loss of information. That's why this type of classification is meant for discrete variables. Under this method, in discrete variable inclusive series, the upper limit of a class is not equal to the lower limit of the next higher class. The upper limit of a one class is not equal to the lower limit of the next higher class. Such kind of series is known as inclusive series. In this series, both lower limit and upper limit are included in the particular class interval. If any variable value is having the value 19, then that 19 is countable under the interval of 10 to 19. So, in this series, the upper limit and lower limit, both upper limits and lower limit are included in the class interval. And the upper limit of one class is not coincided with the lower limit of the immediate next class. Not coincided means not equal. So, another name for inclusive series is also known as the non-overlapping series. So, in inclusive series, the upper limit of one class is always less than the lower limit of the next class. So, for the classes 10 to 19 and 20 to 29, the upper limit of 10 to 19 is 19 and the lower limit of 20 to 29 is 20. Upper limit of one class is always less than the lower limit of the next class. That kind of series is known as inclusive series. If the upper limit of one class is same as the lower limit of the next class, then such kind of series is known as exclusive series. Another name for exclusive series is overlapping series. Here overlapping of the series is being done. Suppose if any value is equal to 20, then where we need to count that particular 20? In 10 to 20 or 20 to 30? We need to count that particular 20 as a lower limit of the class. That means we need to count that 20 in 20 to 30 class. So, in exclusive series, lower limits are included, but upper limits are excluded. In exclusive series, upper limit of a class is excluded and the lower limit is included. So, upper limit of a class is excluded from that class, but the same upper limit is included in the next class as lower limit. Next one, in this series, upper limit of a class is coincided with the lower limit of the next class. So, it is called overlapping series. And this kind of series is generally suitable for continuous variables. Another most important point in these types of continuous series is to have the idea about the class limits as well as class boundaries. So many students are confusing at this point, class limits as well as class boundaries. Simply, class limits are the minimum value and maximum value of a class interval is known as class limits. The minimum value is known as lower class limit and maximum value is known as upper class limit. Whereas the class boundaries may be defined as the actual class limit of a class interval. The actual class limit of a class interval. Now, what is the difference between the limits and actual class limits? What is the difference between class limits and actual class limits? I'm taking two examples here. First one, for the intervals, like class intervals, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. Suppose if my intervals are like this, here the upper limit of one class is not same as the lower limit of the next class. So this is a type of inclusive series. This is a type of inclusive series. In this inclusive series, the class limits, lower class limit is the lower limit. The minimum value of the class interval is known as lower class limit. So here the lower class limit for 10 to 19 is 10. The lower class limit for 20 to 29 is 20. The lower class limit for 30 to 39 is 30. The lower class limit for 40 to 49 is 40. And the lower class limit for 50 to 59 is 50. Similarly, upper class limits are the maximum values of the class intervals. 19, 29, 39, 49 and 59. Right. Now, from this point, we need to find out the class boundaries. The class boundaries. The lower class boundary can be obtained by the formula LCL minus D by 2. LCL minus D by 2, where D is the difference between the lower limit of the next class and the upper limit of that class. What is the difference between these two? 1. D is the difference between the lower limit of one next class and the upper limit of that class. So here the difference is 1. So 1 by 2 is 0.5. If we are subtracting that 0.5 from all the lower class limits, then we will get the limits as 9.5, 19.5, 29.5, 39.5 and 49.5. Similarly, UCB is UCL plus D by 2. Here D is 1, 1 by 2 is 0.5. Add that 0.5 to all the upper class limits. Then we will get 19.5, 29.5, 39.5, 49.5 and 59.5. So both LCB and UCB are together called as class boundaries. So these are the actual class limits of this particular class interval. For the class interval 10 to 19, if we are drawing that class interval on a real line, the given class interval is 10 to 19. And actual class limits are 9.5 to 19.5. Actual class limits are 9.5 to 19.5. So these are the class limits. 10 to 19 are the class limits. And the limits of 9.5 to 19.5 are the class boundaries. So the most extreme values which would ever be included in the class interval are known as class boundaries. And here LCB value is always less than the LCL value, so that we can consider the LCB as the lower limit to LCL. Similarly, the UCB value is always greater than the UCL value, so that UCB is an upper limit to the UCL. And similarly, for another kind of intervals, suppose for my intervals are like this: 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. For these kind of intervals, LCL values are 10, 20, 30, 40, 50. And UCL values are 20, 30, 40, 50, 60. And the LCB values, the formula for LCB is LCL minus D by 2. D is the difference between the lower limit of next class and upper limit of that class. But here the difference is 0. So that here LCB is always equals to LCL. And similarly UCB is always equals to UCL. So that for inclusive series only, class boundaries are different from class limits, as well as for exclusive series, class boundaries are equal to the class limits. So it is always advisable to convert inclusive series into exclusive series. So this is the procedure for converting the inclusive series into exclusive series. Already we discussed that. And the second one is class width or class length or magnitude or size of a class interval. This is just denoted by C or I or H, which is defined as the difference between UCB and LCB. Class width or class length can be obtained by subtracting the LCB from UCB. Next, see here. See this problem. CRD problem number 3. Convert the following inclusive series into exclusive series. How to convert this? First, we need to understand about the difference between this upper limit of one class to the lower limit of the next class. All these differences are equal to 1. Half of that difference is 0.5. If you subtract that 0.5 to the lower from the lower limits, you will get 0.5, 10.5, 20.5, 30.5, 40.5, 50.5. And if we add that same 0.5 to all the upper limits of a class interval, we will get 10.5, 20.5, 30.5, 40.5, 50.5, and 60.5. Now, these intervals became the exclusive series because there is no difference between the lower limit of next class and the upper limit of that class. So to convert the inclusive series into exclusive series, just observe the difference between lower limit of the next class and the upper limit of that class. So many students are fixing that the common value which is subtracted to the lower limits and added to the upper limits as 0.5. It is not always 0.5. You have to observe the difference between these limits and half of that difference. That half of the difference can be subtracted from all the lower limits and add the same half of the difference to the upper limits. Similarly, next problem also. Next, how to describe the construction of frequency distribution. How to construct it. We'll discuss this point at the time of MCQs. Next one, mid value or midpoint or class mark. Mid value or midpoint or class mark. All these three terms are same. This can be obtained by the formula, the arithmetic mean of the class limits or the arithmetic mean of the class boundaries. LCL plus UCL by 2 or LCB plus UCB by 2. So when such mid values are given, then it is called as mid value series. The values of a variable along with the mid values and frequencies, then that series is known as mid value series. And next one, equal class interval series and unequal class interval series. If the length of all the classes are equal, if the length of all the classes are equal, then it is said to be equal class interval series. If the length of all the class intervals are not same, then that series is known as unequal class interval series, simply. And the next one is open-end series. Whenever the lower limit of one class or the upper limit of the last class are not specified, or both are not specified, then that series is known as open-end series. That means when one end of a class, either lower end or the upper end or both, when one end of a class is not specified, then that series is known as open-end series. And the next one is cumulative frequency distribution. Less than type cumulative. Here there are two types of cumulative frequency distributions. First one is less than type cumulative frequency and second one is more than type cumulative frequency. The less than type cumulative frequency represents the total frequency of all values less than the class value. Less than the class value, that is upper class limit. That means the total number of observations which are less than the upper class boundaries of the class interval is known as less than type cumulative frequency. Here, in this example, the frequency of the intervals are given as 8, 22, 45, 18 and 7. Here the LCF values are 8, 30, 75, 93, 100. This 8 is the total number of observations of the workers who are earning the wage less than 10. Similarly, the total number of workers who are earning the wage less than 20 is 8 plus 22, which is equal to 30. So these are the values which describes the total number of observations which are less than the upper class boundaries of the class interval. Similarly, more than type cumulative frequency. More than type cumulative frequency or greater than type cumulative frequency. Greater than type cumulative frequencies are the total number of observations which are greater than the lower class boundaries of a class interval. Now, it is very important to convert the following less than type cumulative frequency distribution into ordinary frequency distribution. What do you mean by ordinary frequency distribution? That means we need to obtain the class intervals. We need to obtain the class intervals for this series, for this cumulative frequency distribution. Since these are the number of students, total number of students which are less than the upper class boundaries. So all these values are the upper class boundaries of the class intervals. Then the upper class boundaries are 10, 20, 30, 40, 50, 60. And the lower class limits, what are the lower class limits of these intervals? The upper class limit of first class is same as the lower limit of the next class. The upper limit of the second class is same as the lower limit of the next class. The upper limit of the third class is same as the lower limit of the next class, like that. And what about the upper limit of the first class? Since all the remaining classes are having the length of 10, so that we can assume the length of the first class interval is also as 10, so that the lower limit becomes 0. Now, how to obtain the frequencies for these intervals? Here, there are totally 5 number of students are there who scored less than 10 marks. So 0 to 10 means also the same value. 0 to 10 is also the number of students who are scored less than 10 marks only. Now, here we need to obtain the number of students from 10 to 20 only. But here it is given that the total number of students which are less than 20. Less than 20 means including the number of students from 0 to 10 also. So we need to subtract these two cumulative frequencies, that is 16 minus 5, which is equal to 11. Similarly, for the 20 to 30, the frequency is 35 minus 16, that is 19. Similarly, 66 minus 35, 31. Similarly, 89 minus 66, that is 23. Similarly, 100 minus 89, which is equal to 11. So it is also very important to convert in a reverse manner from the less than type cumulative frequency to ordinary frequency distribution. In the same manner, we can convert the more than type cumulative frequency into ordinary frequency distribution. And finally, we are having 3 important terms here. One is called relative frequency, and second one is called percentage frequency, and the third one is called frequency density. Relative frequency is defined as the ratio between the class frequency to the total frequency. It gives us the proportion of all the observations, the proportion of that particular class frequency from the total frequency, so that its value always lies in between 0 and 1 strictly. So for this example, for this problem, the relative frequency for each class interval, what is the total frequency of all the classes? That is 17, 40, 20, 60. So the relative frequencies are 5 by 60 class frequency divided by total frequency. That is 5 by 60, 12 by 60, 23 by 60, 12 by 60, and 8 by 60. Right. Next one, percentage frequency. If we express the relative frequency in terms of percentages, then it is known as percentage frequency. That means how much percentage of class frequency is there out of total frequency. Next one, frequency density. Frequency density is the ratio between the class frequency of that class interval and the corresponding class length. The ratio between class frequency to class length. It gives us how much frequency is distributing to each and every mass point of that particular class interval. How much frequency is distributing to each and every mass point of the class interval. In the class interval 0 to 10, there are 10 mass points. The length itself gives us number of mass points in the interval. So there are 10 mass points like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Since 10 is not included in this interval, so from 0 to 9 there are 10 mass points. So how much frequency is distributed to each and every mass point in that particular interval can be described by frequency density. So the length of this class frequency is 10. The frequency divided by class length, that is 3 by 10, which is equal to 0.3. Among the class frequency of 3, 0.3 frequency is distributing to each and every mass point of the class interval. Similarly for the remaining classes also, 0.7, 1.9, 2.7, 2.1, 1.5 respectively. Right. Now, let us discuss about some important models of problems in this chapter. First one, we are going to discuss about the third problem. The following data relates to the marks of 48 students in statistics. What are the frequency densities? What are the frequency densities for the class intervals 30 to 39, 40 to 49, and 50 to 59? We need to find out the class intervals for only these three classes. How to find it? How to find it? MCQs problem number 3. So we need to find out the class frequency densities for the classes 30 to 39, 40 to 49, 50 to 59. So to find the frequency densities, first we need to find out the frequencies. Now, the frequencies can be obtained from the given data by using tally mark method. By using tally mark method. What do you mean by a tally mark method? Tally mark is a vertical stroke. Tally mark is a vertical stroke. So we need to find out the frequencies by using tally marks method. So first check each and every observation in the given data. So in the given data, first observation is 56. 56 comes into the interval of 50 to 59. So mark a vertical stroke against to the 50 to 59 like this. Next observation is 10. 10 is not there in these three intervals. So we can ignore it. Next one 54. Next one 38. Next one 21. 43. 12. 12 is not there. 22 is not there. 48. 51. 39. 26 is not there. 12 is not there. 17 is not there. 36. 19 is not there. 48. 36. 15. 33. Once 4 tally marks are been completed, for the fifth tally mark, we need to cross out like this. 30. 62 is not there. 57. 17 is not there. 5 is not there. Again 17 is not there. 45. 46. 43. 55. 57. 38. 43. 28 is not there. 32. 35. 54. 27 is not there. 17 is not there. 16 not there. 11 not there. 43. 45. 2. 2 is not there. 16 is not there. 46. 28. 45. So count the number of tally marks and place that count under the column of frequency. So 9, 11, 7. Now we need to find out the frequency density. The frequency density can be obtained by using the formula class frequency divided by class length. To determine the class length, we need to find out the difference between the class boundaries. But here all these three intervals are in the format of inclusive series. From the inclusive series, we cannot obtain the length. So first convert this inclusive series into exclusive series to obtain the class boundaries. So the difference between the lower limit of the next class and the upper limit of that class is 1. Half of that difference is 0.5, and subtract that 0.5 from the lower limits and add the same 0.5 to the upper limits. Then your class boundaries are 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5. So these are the class boundaries, and the difference between the class boundaries is 10. So that the frequency densities are 9 by 10, 11 by 10 and 7 by 10, which is equal to 0.9, 1.1, 0.7. So your answer is option D. Your answer is option D. Next, similarly, see here, for the non-overlapping classes 0 to 19, 20 to 39, 40 to 59, the class mark of the class 0 to 19 is, class mark means midpoint. Midpoint can be obtained by the formula UCL plus LCL by 2. For this class interval 0 to 9, LCL is 0 and UCL is 19, so that 0 plus 19 by 2, which is equal to 9.5. So the option is C. Similarly, next one, if the midpoints of the classes are 8, 12, 16, 20, 24, then the last class limits are. So whenever we have been given the midpoints, from these midpoints, how to obtain the class limits? The midpoints are given as 8, 12, 16, 20, 24. From these midpoints, how to determine the class limits? So the formula for obtaining the class limits here is LCB is equal to midpoint minus D by 2, and UCB is equal to midpoint plus D by 2, where M is the midpoint here, and D is the common difference between the midpoints. Whenever there is the equal difference between all the midpoints, then only we can obtain the class limits or class boundaries from those midpoints. Here, the common difference between all the midpoints is 4. So here, in this case, D value is equal to 4. Then make half of D value. That is, D by 2 is 2. Subtract this 2 from all the midpoints to get the LCB values. Add the same D by 2 value to all the midpoints to get the UCB values. So that your limits becomes 6 to 10, 10 to 14, 14 to 18, 18 to 22, 22 to 26. Now what are the last class limits? 20 to 26. So the answer is option D. Next one. See the ninth problem. For a data on frequency distribution of weights, there are some values have been given as weights. If we assume a class length as 5, we assume a class length as 5, and the number of class intervals will be. Here, there is a small relation between the number of class intervals, class length, and range. There is a small relation between number of class intervals, class length, and range. The relation is number of class intervals into class length is always equals to range. Number of class intervals into class length is always equals to range. In the problem, in the given problem, we have been given the class length. We have been given the class length, and the range is the difference between the highest value and the least value. Highest value and the least value. So in the given problem, we have been given the class length. We need to determine the number of class intervals. So the formula becomes, for the number of class intervals is range divided by class length. So here the range, to obtain the range, the highest value is 73 and the least value is 44. And the range is nothing but 73 minus 44 gives us 29. And the number of class intervals is range divided by 29 divided by class length 5. The value for 29 by 5 is 5.8. 5.8. Whenever we cross the value, integer value of 5, we need to round this value to the next nearest integer. So the answer is 6. And here, 12th problem. Here, number of accidents and frequency. Here the variable is number of accidents is the variable and the frequency. So since the variable takes only 8 values are there, variable assumes only 8 values, so that this is a discrete variable. For this kind of data, in how many cases 4 or more accidents occur? 4 or more accidents occur. In the number of accidents, what are the values which are 4 or more? That is 4, 5, 6, 7. Just add the corresponding frequencies to get the number of cases where 4 or more accidents occur. So here answer is 78. Next, here for 14th problem, the frequency of class 20 to 30 in the following data. So since all the classes have been started from 0, that means all these values are less than the upper boundaries. So that this is the data of less than cumulative frequency distribution. This is the data of less than cumulative frequency distribution. So from this data, we need to find out the class frequency from 20 to 30 only. So to obtain the class frequency from 20 to 30, just subtract the cumulative frequency from 0 to 30. Subtract 0 to 20, cumulative frequency from 0 to 20 from the cumulative frequency of 0 to 30. Just that is 28 minus 13, which is equal to 15. Next one. Next one, 17th one. Find the number of observations between 250 and 300. Similarly, here also we need to subtract the cumulative frequency which is more than 300 from the cumulative frequency more than 250. That is 38 minus 15, which is equal to 23. And finally, And finally, see the 19th problem. The following data relate to the incomes of 86 persons. All these intervals are inclusive type of intervals. Now the question is, what is the percentage of persons earning more than 1500 rupees? How many persons are there who are earning more than 1500 rupees? More than 1500 rupees means these two class interval comes under the more than 1500 rupees. So the corresponding total number of persons is 36 plus 7, which is equal to 43. Now we need to find out the percentage of persons. That means out of total, how much percentage of persons are there? So more than 1500, there are totally 43 persons are there, and total frequency is 86. So the percentage is 43 divided by 86 into 100, which gives us 50%. Like that, we can solve and very easily with these concepts in this chapter. We are going to discuss about measures of central tendency, part 1. Why we are divided this one chapter into two parts. For the sake of easiness and for the sake of convenience to the students, we divided the large chapter into two parts. So, first, this is the measures of central tendency, part 1. So, first of all, what do you mean by a measure of central tendency? Before discussing about the measure of central tendency, what do you mean by a tendency? Tendency means nothing but reaching towards a particular value. Tendency means reaching towards a particular value is nothing but tendency. And central tendency means reaching towards the central value. Central tendency means reaching towards a central value. So, if we are concentrating on the central value of a given set of observations, then that is called as central tendency. So, a single central value which represents entire set of observations is known as measure of central tendency. A single central value which represents entire set of observations or entire data is known as measure of central tendency. So this measure of central tendency is also known as average. Measure of central tendency is also known as average or measure of location. Measure of location, because in any given data we are going to locate a single central value of the given set of observations. So that measures of central tendency is also known as average or measures of location. So what is the use or advantage of these measures of central tendency in our day-to-day life? Generally, in any firm or any organization can be identified or can be recognized because of its high average profit. Any company or any organization or any industry, any firm can be recognized because of its high average profit. Similarly, any educational institution can be recognized by the average mark obtained by the students of that particular institute. So that in day-to-day life, average plays a very important role in any kind of data analysis. Even though average can be useful for the comparison of two different distributions. Average can act as a basis for the comparison of two different distributions. For example, suppose if myself, I got some marks in 10th in class 10 like this. In subject 1, I got the marks as 70. In subject 2, I got the marks as 75. And in subject 3, I got 100. In subject 4, I got some 50. And in subject 5, I got some 45. This is my mark, myself, that is Ravi Shankar's mark in 5 subjects. As well as one of my friends known as Naveen, he scored in all these subjects like this: 85, 90, 100, 92, and 88. So my marks are like this and Naveen marks are like this. Now we need to compare the performance of both of us. The student who is having the highest average mark is performed better than the student who got least average mark. So obviously myself got least average mark and Naveen got highest average mark. Naveen got highest average mark. So obviously Naveen performed very well than me. So that average acts as a basis for the comparison of two different distributions. Here my marks are one distribution and Naveen's marks are another distribution. So basically averages acts as a basis for the comparison of two different distributions. And also for any kind of data analysis, for any kind of statistical data analysis, the first and foremost criteria is to determine the measure of central tendency values, so that we can call it measures of central tendency as the averages of first order. So here we are having majorly measures of central tendency. There are different methods are there to obtain the single central value of a given data. So majorly these measures of central tendency are divided into 3 types. One is mean, and second one is median, and third one is mode. Again, mean is divided into 3 types. Again, mean is divided into 3 types. One is arithmetic mean, second one is geometric mean, and third one is harmonic mean. And arithmetic mean, geometric mean, and harmonic mean are known as mathematical averages. Whereas mean, median, and mode are known as positional averages. Mean and mode are known as positional averages. In this class, we are going to discuss about this particular arithmetic mean. And in this part of measure of central tendency, we are going to discuss about arithmetic mean and median. In the next part, we are going to discuss about the mode, geometric mean and harmonic mean. So in this part, in today's class, we are going to discuss about this arithmetic mean. So firstly, we will see some important problems, how to solve those important problems in arithmetic mean. After that, we will discuss about some theoretical concepts of this arithmetic mean. So to start the problems, first we need to know the definition of arithmetic mean. We need to know the definition of arithmetic mean. So the arithmetic mean is defined as, see here, the arithmetic mean is the most widely used measure. The arithmetic mean is most widely used measure to represent the entire data. It is the most widely used measure, most stable measure, most reliable measure of central tendency. So to a common man, to a layman, it is just an average, but for a statistician, it is just arithmetic mean. And the arithmetic mean is defined as like this. For a given set of observations, arithmetic mean is defined as the sum of all the observations divided by number of observations. The sum of all the observations divided by number of observations. Based on this definition, first let us compute some important problems on this arithmetic mean. Afterwards, we will see these merits and demerits in detail. So to solve the problems, here I selected some important problems and also the formulae related to those problems for the maintenance of the time constraint. So first we'll see the formulae for arithmetic mean. Here there are different kinds of formulas are there, but first for individual series. Individual series means if we write all the values of a particular characteristic separately, then that series is known as individual series. In case of individual series, arithmetic mean can be computed by any of these two methods. Arithmetic mean can be computed by any of these two methods. One is direct method and second one is assumed mean method. According to the direct method, it is the direct definition of the arithmetic mean, that is x bar is equal to summation x divided by n, which is same as sum of all the observations divided by number of observations. And second method to calculate arithmetic mean in case of individual series is assumed mean method. The formula is given as x bar is equal to a plus summation d by n, where a is equal to assumed mean, d is equal to x minus a. These are nothing but deviations. X minus a are the differences. Differences are also known as deviations of given set of observations from arithmetic mean, assumed mean. Deviations from assumed mean denoted by D. Now the next question come to your mind is what is assumed mean? What is assumed mean? Assumed mean is a constant value which is subtracted from all the observations of a set. Why we need to subtract a constant value from all the observations of a set? If our set of observations contains a very large values, then for the sake of convenience for the calculation, we have to reduce those large values into the simple values. So to reduce those large values into the simple values, first we need to subtract the same constant value from each and every observation of a set. So that constant value is known as assumed mean. This assumed mean can be any value we like. Assumed mean can be any value we like. It need not be in the given data. We'll see about this assumed mean in detail when the problem comes. First we are going to discuss about this problem. The mean of 30 observations is 21. Then find the sum of these observations. So here in the problem, there are number of observations. Number of observations are given as 30 and the mean of these 30 observations is given as 21. If we write these values into the notations, given that number of observations is denoted by n, which is given as 30, and the arithmetic mean is generally denoted by x bar, which is given as 21. Now, what we need to find out in the problem? We need to find the sum of all these 30 observations. That means to find the summation x value, we need to find the summation x value. But as per the formula of individual series using direct method, the formula is x bar is equal to summation x by n. From this formula, we can write summation x is equal to n into x bar, which is equal to 30 into 21, which is same as 630. Which is option C in your problems, in your material. Next question. Expenditure of a company in million rupees per item in various years. There are 5 years of data is there: 1998, 1999, 2000, 2001, 2002. There are different items of expenditures are there, like salary expenditure, fuel and transport expenditure, bonus expenditure, interest on loans expenditure, as well as taxes expenditure. But what is the question? What is the average amount of interest per year which the company had to pay during this period? Since we need to calculate the average amount of interest, so that our variable of interest in this particular problem is interest. Now, in the given data, what is the expenditure related to this interest? What is the item of the expenditure related to this interest? That is just interest on loans. We need not bother about the remaining items. We need not bother about the remaining items. Just we need to calculate the average amount of interest. So, according to that, we have to calculate the average of these observations. So, that average. So here our variable of interest is interest on loans, and number of observations of interest on loans is 5. So average amount of interest is given as summation x by n. By adding all these 5 values, we'll get 183.3 divided by number of observations 5 gives us 36.66. Next one. Now, the next question. Mean of 7, 9, 12, x, 4, 11, 5 is 9. Find the missing observation. That means we need to find out this x value. Given that mean of all these observations as 9. So, given that x bar is equal to 9. The formula for x bar is summation x by n, which is given as 9. Summation x means we need to add all these observations. That is 7 plus 9 plus 12 plus x plus 4 plus 11 plus 5 divided by number of observations are 1, 2, 3, 4, 5, 6, 7. 7 observations are there is equal to 9. On cross multiplication, we'll get by adding 7, 9, 12, 4, 11 and 5, we'll get 16 plus 12, 28 plus 4, 32 plus 11, 43 plus 5, 48 plus x is equal to 63. Now, that implies x is equal to 63 minus 48, then we'll get just 15. The missing observation here is 15. Next one, assumed mean method. This is a problem based on assumed mean method. It is a problem based on assumed mean method. If for an individual series, assumed mean A value is given as 25 and summation D value is given as minus 21, where D is nothing but x minus A, as we saw at the formula, and N value is given as 7. Now we need to find out the mean of the series. Mean of the series based on all these values A, summation D and N is given by the formula A plus summation D by N, which is equal to A plus A value is 25 and summation D is minus 21 divided by number of observations 7, which is equal to 25 minus 3, that is equal to 22. Here, from this formula, we can say that arithmetic mean is equal to AM is equal to A means assumed mean plus, again this formula summation D by N is in the form of sum of the observations divided by number of observations. Sum of observations divided by number of observations gives us arithmetic mean. So, arithmetic mean of what values? Arithmetic mean of deviations. D is nothing but the deviations from arithmetic mean, assumed mean. So, this is arithmetic mean of deviations of the observations from assumed mean. Next one. See here, there are n numbers. We don't know what are those numbers. There are n numbers. When 50 is subtracted from each of these numbers, that means a constant value 50 is subtracted from each and every value of those n numbers. So a constant value which is subtracted from each observation of a given set is known as assumed mean. So that here there are two different cases are there. In case 1, our assumed mean is given as 50 because this 50 constant value is subtracted from each and every observation. So here A value is equal to 50 and sum of these deviations, sum of these differences, the sum of the numbers after subtracting 50 from each and every observation is given as minus 10. So that here it is given that summation D value is equal to minus 10. Summation D value is equal to minus 10. Now, from these two values, the corresponding arithmetic mean in this case is equal to a plus summation d by n, which is equal to 50 minus 10 by n. This is one case. And there is a second alternative case also. When 46 is subtracted from each of the original n numbers, in this case, our assumed mean will be treated as 46, because in this case 46 is a constant value which is subtracted from each and every observation. So that in case 2, assumed mean is 46 and sum of the numbers so obtained, that means sum of the numbers after subtracting 46 from each and every observation, that is nothing but summation d is given as 70. From this case, the corresponding arithmetic mean is equal to a plus summation d by n, which is equal to 46 plus 70 by n. But in both the cases, the arithmetic mean was computed for the same set of n observations, for the same set of n numbers. So that from these two equations, we have to equate the right hand side part of the equations. We have to equate the right hand side part of the equations. So from 1 and 2, if we equate the right hand side part of the equations, 50 minus 10 by n is equal to 46 plus 70 by n. 50 minus 46 becomes 4 is equal to 70 by n plus 10 by n becomes 80 by n. Then that implies n is equal to 20. N is equal to 20. On substituting this n value in any of these two equations, then we will get the mean of the series. That is, x bar is equal to 50 minus 10 by 20. That is equal to 50 minus 0.5, which is equal to 49.5. So the mean of the original n numbers is x bar, which is equal to 49.5. Next submodel of arithmetic mean is mean if all the observations are in arithmetic progression. AP stands for arithmetic progression. Arithmetic progression means if the difference between any two successive terms is equal, then those values are said to be in arithmetic progression. If all the observations are in arithmetic progression, then the formula for calculating the arithmetic mean is x bar is equal to a plus L by 2, where a is equal to the first term of the series and L is equal to last term of the series. Similarly, here there are three more formulas to remember, that is mean of first 10 natural numbers. The first 10 natural numbers are always in arithmetic progression. So the mean of the first 10 natural numbers is equal to just n plus 1 by 2. Similarly, mean of squares of first 10 natural numbers. Even though the squares of first 10 natural numbers are not in arithmetic progression, by applying the definition, that is sum of the observations divided by the number of observations, we will get the formula for mean of squares of n natural numbers as n plus 1 into 2n plus 1 by 6. Similarly, mean of cubes of first 10 natural numbers is equal to n into n plus 1 whole square by 4. Now, the next problem. The arithmetic mean of cubes of 5 natural numbers. So here n value is equal to 5. N value is equal to 5. Now the required arithmetic mean can be given by the formula cubes of arithmetic mean of cubes of first 5 natural numbers. First 10 natural numbers is n into n plus 1 whole square divided by 4. That is equal to 5 into 5 plus 1 whole square divided by 4, which is equal to 5 into 5 plus 1 is 6, 6 square is 36 divided by 4. 4 9s 36, so 9 into 5 gives us 45. Next, similarly, find the average of first 25 multiples of 5. Find the average of first 25 multiples of 5. So first 25 multiples of 5 means 5 into 1 5, 5 into 2 10, 5 into 3 15, 5 into 4 20, and so on. 5 into 25 is 125. Now all these observations, all these values are in arithmetic progression with the common difference of 5. With the common difference of 5. So that all these values are in arithmetic progression. So the formula for calculating the mean, if all the observations are in arithmetic progression, is x bar is equal to a plus l by 2, which is equal to a means the first term of the series, that is 5, plus l means the last term of the series, that is 125 divided by 2, which is equal to 130 by 2, that is equal to 65. Next one. Before proceeding to the next problem, let us discuss some important properties of arithmetic mean. Some important properties of arithmetic mean. The first property is if all the observations assumed by a variable are constant, that is k, then their arithmetic mean is also equals to k. Suppose if any variable assuming the values of 20, 20, 20, 20, 20, if all the observations of a variable are equal, then the corresponding arithmetic mean is also equals to 20. Now, the second property. See the properties here. The first property is if all the observations assumed by a variable are constant, say k, then arithmetic mean is also k. For example, if the height of every student in a group of 10 students is 170 centimeters, then arithmetic mean of average height of those 10 students will also be equals to 170 centimeters. Second one, the choice of assumed mean does not affect the original mean. The choice of assumed mean does not affect the original mean. What do you mean by that? Suppose if my variable values are like this, x values are like this, 152, 158, 160, 154, and 156. X values are 152, 158, 160, 154, 156. The original mean of these numbers is 152 plus 158 is 310, 310 plus 160 is 470, 470 plus again 310, that is 780, 780 divided by 5 is, I think, 156. that is 156. Now, if I am going to use assumed mean to calculate the arithmetic mean, I am using assumed mean method to calculate the arithmetic mean. Assumed mean is a constant value which is subtracting from each observation of a given set. So for the first case, I am choosing assumed mean as, for the first case I am choosing assumed mean as 158, which is one of the given observations. I am choosing assumed mean as 158. This is my A value. Now obtain the deviations from assumed mean value. That is 152 minus 158 gives us minus 6. 158 minus 158 gives us 0. 160 minus 158 gives us 2. 154 minus 158 gives us minus 4. And 156 minus 158 gives us minus 2. So the total of these numbers, these deviation values, is minus 10. Now, according to the assumed mean method formula, x bar is a plus summation d by n, which is equal to my assumed mean in this case is 158 minus 10 divided by number of observations 5. That is 158 minus 2 gives us 156, which is same as the original mean. In the second case, I am choosing one more case. In this case, I am choosing my assumed mean as 150, which is not there in the given series. Assumed mean can be any value which we like. So, after obtaining the deviations from assumed mean, I will get the values. 152 minus 150 gives us 2. 158 minus 158 gives us 8. 160 minus 150 gives us 10. 154 minus 150 gives us 4 and 6. The sum of these values is 30. Now, according to the assumed mean method formula, my assumed mean is 150 plus sum of deviations is 30 divided by number of observations 5, which also gives us 156. So whatever the assumed mean it is, it does not affecting the original mean. In all the cases we are getting the same original mean value, whatever the assumed mean it is. So the choice of assumed mean does not affect the original mean. And third one is a very most important and fundamental property. The algebraic sum of a set of observations from their arithmetic mean is 0. Here deviations means differences between set of observations from their arithmetic mean, that is x minus x bar. Sum of those deviations, that is summation of x minus x bar, is always equals to 0. This is for individual series, and for grouped series, for discrete series or continuous series, it is summation f into x minus x bar is equal to 0. Whatever the observations are there, the sum of deviations of a set of observations from their arithmetic mean is always equals to 0. For example, for the same data, for the same example, x values are 152, 158, 160, 154 and 156. For these numbers, x bar value is equal to 156. Now calculate the deviations from arithmetic mean, that is x minus x bar. That is 152 minus 156 gives us minus 4. 158 minus 156 gives us 2. 160 minus 156 gives us 4. 154 minus 156 gives us minus 2. And 156 minus 156 is 0. And sum of all these values gives us 0. Minus 4 plus 2, minus 2 plus 4, minus 2, minus 4 plus 4, 2 minus 2, 0. So the sum of deviations of a given set of observations from their arithmetic mean is always equals to 0. And the next one, fourth one, sum of squared deviations. Sum of squared deviations of the items will be minimum when such deviations are taken from arithmetic mean. When such deviations are taken from arithmetic mean. In other words, sum of squared deviations of all the items taken from arithmetic mean will be less than the sum of squared deviations of all the items taken from any other value, not only median or not only mode, any other value. Say for example, this time we will take smaller values for the sake of convenience as an example. So if my x values are 5, 10, 8, 7, 15. 5, 10, 8, 7, 15. Now, my x bar value for these observations is equal to, what is my x bar for these observations is equal to 5 plus 10, 15, 15 plus 15, 30, 30 plus 15, 45 divided by 5 gives us 9. Now, I am calculating the squared deviations from arithmetic mean. I am calculating the values of squared deviations from arithmetic mean. That is x minus x bar whole square. 5 minus 9 gives me minus 4 whole square 16. 10 minus 9 is 1, 1 square is 1. 8 minus 9 is minus 1 whole square is 1. 7 minus 9 minus 2 whole square is 4. 15 minus 9, 6, 6 square is 36. And the sum of squared deviations is equal to 20, 22, 58. This time I am taking the sum of squared deviations value from 10. Apart from arithmetic mean, other than arithmetic mean, now I am taking the squared deviations from the value 10. Now 5 minus 10 whole square gives us 25. 10 minus 10 whole square gives us 0. 8 minus 10 whole square gives us 4. 7 minus 10 whole square gives us 9. 15 minus 10 whole square gives us 25. Now, the sum of all these observations is 25 plus 25, 50 plus 13, 63. Again, I am taking the sum of squared deviations from 8. Squared deviations from 8. So 5 minus 8 whole square gives us 9. 10 minus 8 whole square gives us 4. 8 minus 8 whole square gives us 0. 7 minus 8 whole square gives us 1. 15 minus 8 whole square gives us 49. And the total again is 63. So the sum of squared deviations taken from arithmetic mean is always minimum when compared to any other value. That is the meaning of this property. Next, fifth one. Arithmetic mean is affected due to change of origin and or scale. What do you mean by change of origin and scale? Suppose if my x values are 5, 10, 8, 7, 15, my corresponding arithmetic mean value is equals to 9. Now, if I am adding a constant value from each observation, I am adding a constant value 5 to each and every observation, any constant value. For example, 5. Then the observations becomes 10, 15, 13, 12, 20. And the arithmetic mean of the new observations is 10 plus 15, 25, 25 plus 25, 50, 50 plus 20, 70, 70 by 5, 14. That means the original arithmetic mean is also increased by the same constant value. If a constant 5 is added to each and every observation of the given set, then its corresponding arithmetic mean is also increased by the same constant value. If we are adding or subtracting a constant value from any set, from the given set, it is called adding or subtracting. Now I am subtracting 2 from each and every observation of the original set. That is, 5 minus 2 gives us 3, 10 minus 2 gives us 8, 8 minus 2 gives us 6, 7 minus 2 gives us 5, 15 minus 2 gives us 13. Now the arithmetic mean of these new observations is 3 plus 8, 11, 11 plus 6, 17, 17 plus 5, 22, 22 plus 13, 35, divided by 5 gives us 7. So the original mean minus 2. So adding or subtracting a constant value to each and every observation is called change of origin technique. Change of origin technique. Similarly, when we are multiplying or dividing with a constant value, then it is called change of scale technique. Similarly, if I am multiplying with 5, if I am multiplying each observation with 5, then the new observations becomes 25, 50, 40, 35 and 75. The mean of new observations is 25 plus 35, 60, 60 plus 40, 100, 150 plus 75, 225 divided by 5 gives us 45, which is same as the original mean into the same constant value. Similarly, if I am dividing each and every observation with a value 2, a constant value 2, then the new observations becomes 5 by 2 is 2.5, 10 by 2 is 5, 8 by 2 is 4, 7 by 2 is 3.5, 15 by 2 is 7.5. Now the mean of new observations is 2.5 plus 3.5 is 6, 6 plus 9 15, 15 plus 7.5 22.5 divided by 5 gives us 4.5. That is original mean divided by the same constant value. So if I am multiplying or dividing the given set of observations with a constant value is nothing but the change of scale technique. So arithmetic mean is affected due to both change of origin as well as change of scale. The same thing can be obtained by equation model. The same thing can be obtained by equation model. So if the original variable x is changed to another variable y by affecting a change of origin, say A, and change of scale, say B, that means the original variable x is multiplied with a constant value B. That means it is a change of scale technique. And again we are added with some constant value A. That is nothing but change of origin technique. So the new variable becomes y. Then the arithmetic mean of y is given as y bar is equal to a plus bx bar. Y bar is equal to a plus bx bar. That is called equation model. If y is equal to a plus bx, then y bar is equal to a plus bx bar. And the last property, if there are two groups or more than two groups containing n1 and n2 number of observations with x1 bar and x2 bar as the respective arithmetic means, then the combined arithmetic mean. This combined arithmetic mean is also known as pooled arithmetic mean, pooled mean or grouped mean. So whenever we know the information about the number of observations of two or more groups along with their respective means, then to obtain the arithmetic mean of all those groups together is known as combined arithmetic mean or pooled arithmetic mean or grouped arithmetic mean, and it is given by the formula x bar 1 2 is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. These are some important properties of arithmetic mean. Now, coming to our problems, come back to our problems. Our next problem is mean of n observations is x bar. I don't know whatever the observations are. So I am assuming that my observations as x1, x2, x3 and so on xn. And the mean of these n observations is given as x bar. Now, if first observation is increased by 1, that means x1 is increased by 1, that is x1 plus 1. Second observation is increased by 2, that means x2 plus 2, and so on. That means and so on means third observation is increased by 3, and so on. Nth observation is also increased by n. Now, what is the mean of the new observations or the new mean? How to find out? A simple technique for obtaining the new mean in this case is each and every observation contains two terms. One term is before the plus symbol and another term is after the plus symbol. So the first term of each and every observations are x1, x2, x3 and so on xn. x1, x2, x3 and so on xn. The mean of x1, x2, x3 and so on xn is given as x bar plus, and the second term of each observations are 1, 2, 3 and so on n. 1, 2, 3 and so on n are the natural numbers, first n natural numbers. So the arithmetic mean of first n natural numbers is given by the formula n plus 1 by 2. So the mean of new observations is x bar plus n plus 1 by 2. Next one. This is called equation model. This is the problem based on the equation model. If the relation between two variables u and v is given by 2u plus v plus 7 is equal to 0. If the arithmetic mean of u is 10, the relationship between two variables 2u plus v plus 7 is equal to 0. And also given that arithmetic mean of u, that is u bar, is given as 10. Since the arithmetic mean is affected due to both the change of origin and scale, hence from this equation we can write 2u bar plus v bar plus 7 is equal to 0. Now we need to find out the arithmetic mean of v, that means v bar. So substitute this u bar value in this equation and simplify it. We'll get v bar is equal to minus 27. 2 into 10 20 plus 7 27, so that v bar is equal to minus 27. This is a simple equation model problem. Next one. Now corrected arithmetic mean. Corrected arithmetic mean. When to use this corrected arithmetic mean? So we have certain number of observations, certain values. We calculated the arithmetic mean for those values. Later on, if we are going to verify the observations one by one, if we are verifying the observations one by one, we found that one observation was one or two or any number of observations were taken as wrong values. So instead of the correct values. So now we have to recalculate the arithmetic mean, revise the arithmetic mean by replacing the wrong values with the correct values. Then that concept is known as corrected arithmetic mean. Discuss about the remaining part of the chapter of measures of central tendency part 1. So first let us start with this corrected arithmetic mean. The corrected arithmetic mean can be used when we compute the arithmetic mean of certain number of observations, when we compute the arithmetic mean of certain number of observations, which is denoted by x bar. Later on, after the computation of this arithmetic mean of certain number of observations, if we are checking the observations one by one, in the verification part, we found that one or two observations were taken as wrongly. So in order to replace those wrong observations with the correct observations and to recalculate the mean is nothing but corrected arithmetic mean. So the formula for corrected arithmetic mean, for the correction of one observation, the formula for corrected arithmetic mean for the correction of one observation, x bar is equal to x bar c. Corrected arithmetic mean is denoted by x bar c, which is equal to x bar plus c minus w by n. X bar plus c minus w by n, where x bar is equal to mean of wrong observations, and c is equal to correct observation, and w is equal to wrong observation, wrong value, and n is the number of observations. Similarly, for the correction of two observations, the formula for corrected arithmetic mean is x bar c is equal to x bar plus c1 plus c2 minus of w1 plus w2 divided by n, where c1 and c2 are the two corrected values and w1, w2 are the two wrong values, and x bar is the mean of the wrong observations itself. Now see this question, see this problem, 28th problem. Now the average weight of 10 persons, increases by 2 kg. The average weight of 10 persons increases by 2 kg. If a person weighing 60 kg is replaced by a new person, then what would be the weight of a new person? So here in this problem, the total number of persons we have is 10 persons. 10 is the value of n. And we need to replace a person whose weight is 60 kg with a new person. So the weight of the new person is the correct value and the weight of the old person is the wrong value. So W value is 60 and weight of the new person, let us treat it as some x. So the average weight of a person increases by 2 kg. That means here the corrected arithmetic mean is equal to x bar plus this average weight is increased by 2 kg. Average weight is increased by 2 kg. So the corrected arithmetic mean is equal to this. But as per the formula, the corrected arithmetic mean is given by x bar plus c minus w by n, which is equal to x bar plus 2. So x bar, both sides x bar will get cancelled, and the c is the weight of the new person, and w is the weight of the old person, which is 60, and n is the number of students, that is 10, number of persons 10, which is equal to 2. That means c minus 60 is equal to 10 into 2, 20. That implies c is equal to 80. The same problem can be done with some other formula. A simple formula is simply, we can say that the weight of new person is equal to weight of old person plus total increment. Here the weight of old person is 60 plus total increment means the average weight of 10 persons is increases by 2. When the average weight increases by 2, whenever each person's weight is increased by 2. Whenever each person's weight is increased by 2. So the total increment for all the 10 persons is nothing but 10 into 20, which gives us 10 into 2, that is 60 plus 20, that is equal to 80. Next one. The mean of 100 observations is 50. And if one of the observations which was 50 is replaced by 40. That means here correct value is 40, wrong value is 50, and number of observations is 100, x bar value is 50. So in this case, we can apply the formula directly. We can apply the formula very directly. X bar c is equal to x bar plus c minus w by n. That is equal to 50 plus the c value is 40 minus w value is 50 divided by n value is 100. That is 50 minus 10 divided by 100, which is 0.1, that is equal to 49.9. Next, similar, the average marks scored by 50 students in a class were calculated to be 38. Later it was found that the marks of 2 students were wrongly copied as 34 and 23 instead of 43 and 32. So the correct values are 43 and 32, wrong values are 34 and 23. Here there are 2 corrected values are there, so that we have to apply the formula of x bar c is equal to x bar plus c1 plus c2 minus of w1 plus w2 divided by n. Now, similarly, we can calculate the remaining problems also. See the 32nd problem now. See the 32nd problem. A company's past 10 years average earnings was 40 crores. For obtaining the same average earning for 11 years, including these 10 years, how much earning must be made by the company in the 11th year? See, there are 10 years earnings are there. Those 10 years earnings are denoted by x1, x2 and so on x10. So there are totally number of observations are 10. Number of observations are 10. Average earning of these 10 years is given as 40 crores. So that the total earning of all the 10 years is nothing but number of observations into average, which is equal to 400 crores. 400 crores. Now, one more year is added to all these 10 years. One more year is added to all these 10 years. Then the number of observations becomes 11. So the question is, for obtaining the same average earning for 11 years, so that the average earning for 11 years are also is equal to 40 crores. Then the total earning of these 40 crores is 440 crores. Now the difference of 40 crores is the earning in the 11th year. The difference of 40 crores is the earning in the 11th year. So the answer is 40 crores. Next concept is combined mean. Combined mean can be used when we have two or more groups with the information of number of observations and the corresponding arithmetic means. Then to compute the arithmetic mean of all those groups together, then we have to use this combined arithmetic mean concept. So the combined arithmetic mean for two groups is given by the formula. The combined arithmetic mean for two groups is given by the formula x bar 1 2 is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2, where n1 is the number of observations in group 1, x1 bar is the arithmetic mean of group 1, n2 is the number of observations in group 2, and x2 bar is the arithmetic mean of group 2. If we are having more than two groups, we can extend the same formula. If we are having three groups like this, then the combined arithmetic mean is given by x bar 1 2 3 is equal to n1 x1 bar plus n2 x2 bar plus n3 x3 bar divided by n1 plus n2. So now how to use this formula? There are two special cases. There are two special cases in this formula. The case one is if n1 equal to n2. If n1 equal to n2, if both the groups are having same number of observations, then the combined arithmetic mean is just the arithmetic mean of the means of two groups, that is x1 bar plus x2 bar by 2. And case 2 is if x1 bar is equal to x2 bar, that means both the groups are having equal means, then combined arithmetic mean is also same as either x1 bar or x2 bar Now see the problems. First one, a school has 4 sections of class 10 having 40, 35, 45, 42 students. 40, 35, 45 and 42 students. That means here given that n1 is equal to 40, n2 is equal to 35, n2 is equal to 35, n3 is equal to 45 and n4 is equal to 42. And the mean marks obtained in mathematics test are 50, 45, 40 and 30 respectively. 50, 45, 40 and 30 respectively. That means x1 bar is given as 50, x2 bar is given as 45, and x3 bar is given as 40 and x4 bar is given as 30. Now what is the combined arithmetic mean? What is the combined arithmetic mean? That is X bar 1, 2, 3, 4. Since here we are having 4 sections, 4 groups. So here X bar 1, 2, 3, 4 can be obtained by the formula N1 X1 bar plus N2 X2 bar plus N3 X3 bar plus N4 X4 bar divided by N1 plus N2 plus N3 plus N4. So which is equal to 40 into 50 plus 35 into 45 plus 45 into 40 plus 42 into 30 divided by 40 plus 35 plus 45 plus 42. On simplification, you'll get the answer 40.96. Next, similarly, you can do the next problem. And the next problem, coming to the problem number 36. Here the combined mean of 3 groups is given as 12. And the combined mean of first 2 groups is given as 3. If the first, second and third groups have 2, 3 and 5 items respectively, then the mean of the third group is. So in this question, it was given that the combined mean of 3 groups is 12. And the combined mean of first 2 groups is, the combined mean of first 2 groups is 3. And all the 3 groups are having 2, 3 and 5 number of items. That means N1 is equal to 2, N2 is equal to 3 and N3 is equal to 5. Then we need to find out the mean of the third group. That means we need to find out the X3 bar value. So for that, first consider X bar 12. First consider X bar 12 is equal to 3. By the formula, X bar 12 is N1 X1 bar plus N2 X2 bar divided by N1 plus N2, which is equal to 3. That means N1 is 2 and N2 is 3. So 2x1 bar plus 3x2 bar divided by 2 plus 3, 5. On cross multiplication, 5 into 3 gives us 15. So 2x1 bar plus 3x2 bar is equal to 15. Keep it aside. Now, consider the combined mean of the 3 groups. X bar 1, 2, 3 is equal to 12. According to the formula, N1 X1 bar, that is 2x1 bar, plus N2 X2 bar, that is 3x2 bar, plus N3 X3 bar, that is 5x3 bar, divided by N1 plus N2 plus N3, which is equal to 10, is equal to 12. That implies from equation 1, 2x1 bar plus 3x2 bar is equal to 15 plus 5x3 bar is equal to, on cross multiplication, we will get 120. That implies 5x3 bar is equal to 105. That implies x3 bar is equal to 21. 105 divided by 5, 21. Next. Next, see the 44th problem. See the 44th problem. The average score of girls in class 10 examination in a school is 73 and that of boys is 71. The average score in class 10 examination of the school is 71.8. The percentage of boys in class 10 of the school is. So, here there are 2 groups are there. Here there are 2 groups in the class, that is boys group and girls group. Boys group and girls group. The average score of girls in a class examination is 73. That means girls' average is 73 and boys' average is 71, and the average score in class 10 examination of the school, that means combined arithmetic mean, is given as 71.8. That means x bar 1 2 is given as 71.8. Now we need to find out the percentage of boys in the class. We need to find out the percentage of boys in the class 10 of the school. We can do this problem in two different ways. The first way is assuming that the total number of students in the class as 100. That means by assuming n1 plus n2 is equal to 100 and apply this relation n2 is equal to 100 minus n1 in the formula of combined arithmetic mean, and on simplification we can find out the number of boys n1 value. Similarly, another way of doing this problem is obtain the difference between these two values. Obtain the difference between these two values and place that difference value here. 71.8. The difference is 0.8. Similarly, obtain the difference between these two values and place here. So the difference between 73 and 71.8 is 1.2. And the total of these two values is 2. The total of these two values is 2. Now we need to find out the percentage of boys, so that the percentage of boys can be obtained by 1.2 divided by total of these two is 2 into 100, which is equal to 60%. Which is equal to 60%. Similarly, we can calculate the remaining problems in the combined mean. Next one, discrete series. How to compute arithmetic mean in case of discrete series? In case of discrete series, arithmetic mean can be computed by either direct method or assumed mean method or step deviation method. Among all these methods, better to follow the direct method. The formula for direct method is x bar is equal to summation fx divided by summation f. Summation fx divided by summation f. Now see this 50th problem. The mean of the values 1, 2, 3 and so on n with respective frequencies x, 2x, 3x and so on nx. So here the values of the variable x values are given as 1, 2, 3 and so on n, and corresponding frequencies are given as x, 2x, 3x and so on nx. Then calculate f into x values, that is 1 square into x, 1 into 1x is 1 square into x, 2 into 2x is 2 square into x, 3 into 3x is 3 square into x and so on. N into nx is n square into x. So x bar can be obtained by the formula summation fx by summation f. Summation fx means the total of all these observations, that is 1 square x plus 2 square x plus and so on plus n square x divided by sum of the frequencies is x plus 2x plus 3x plus and so on plus nx. By taking x as a common and cancelling in both numerator and denominator, we will get 1 square plus 2 square plus and so on plus n square divided by 1 plus 2 plus and so on plus 3 plus n. So the sum of squares of n natural numbers, the formula for sum of squares of n natural numbers is n into n plus 1 into 2n plus 1 by 6 divided by sum of first n natural numbers, is given by the formula n into n plus 1 by 2. On multiplication, we'll get the reverse of the fraction, that is 2 divided by n into n plus 1. So n into n plus 1 will get cancelled. 2, 3, 6. The remaining formula is 2n plus 1 by 3. So the answer is 2n plus 1 by 3. Similarly, you can calculate the remaining problems in the discrete series also. Next, coming to the weighted arithmetic mean. The arithmetic mean which we computed so far gives us that all the items have equal importance. All the items have equal importance. But in practicality or in reality, each and every item does not have equal importance. So whenever we need to consider the importance of relative importance of each item, and by using that relative importance to compute the arithmetic mean is known as weighted arithmetic mean. So for example, generally whenever the examination is over and the results came to the students, they'll get the marks in several subjects like English 78 and Sanskrit some 72 and mathematics some 95, statistics some 90, and computer science has some 75. Usually whenever the examination is over and the results came, a student will get the marks like this in several subjects. After observing these marks, the student immediately calculates the total mark. That is 150 plus 90, 240 plus 170, 410, and divided by the number of subjects divided by 5 gives us 82. So this is the average mark of the student. But here the student assumed that all the subjects have equal importance. The student assumed that all the subjects have equal importance. But in reality, all these subjects does not have equal importance. Generally, the language subjects will give the lesser importance than the group subjects. So whenever we consider the relative importance of each and every item, then by using that relative importance of each item, if we calculate the arithmetic mean, then that is called as weighted arithmetic mean. So the formula for calculating the weighted arithmetic mean is x bar w is equal to summation wx divided by summation w. This formula looks like the formula in the discrete series, that is summation fx divided by summation f. The weighted arithmetic mean formula looks like the formula of the arithmetic mean in case of discrete series. So that we can call the frequency are sometimes called as weights. The frequencies are sometimes called as weights. Next. Now, how to calculate this weighted arithmetic mean? I am taking this problem. A student obtained 66, 95, 85 marks respectively in 3 monthly examinations in mathematics and 90 marks in the final examination. Then marks in final examination. The 3 monthly examinations are of equal weightage, whereas the final examination is double than the monthly examination. The final examination is double than the monthly examination. There is a small typo mistake here. So for this problem, you have been given 3 monthly examinations, that is monthly examination 1, monthly examination 2, monthly examination 3, and final examination. So the marks in mathematics of 3 monthly examinations are 66, 95 and 85. 66, 95 and 85, whereas in final examination it is 90. These are the marks which is denoted by our variable of interest x. And the corresponding weightage. The weightage is given as like this. The 3 monthly examinations are of equal weightage. The 3 monthly examinations are of equal weightage. That means we can take the weightage as k, k, k. Whereas the final examination is double than the monthly examination, that is 2k. So to apply the formula, first we need to compute the w into x values. So that is 66k, 95k, 85k, 180k. 66k, 95k, 85k and 180k. On total, you will get 180 plus 180, 360 plus 66, 426k, and the summation of weights is 5k. Therefore, x bar w is equal to 426k divided by 5k. That is 85.2. 85.2. That's it. Now, next one. Coming to the continuous series. So in continuous series also, we can use the same formula as in discrete series. Now, how to compute this arithmetic mean in case of continuous series? So in the problem number 58, for this frequency distribution, the assumed mean can be any value which we like. But in case of continuous series, it is the best practice to choose the mid value against the highest frequency of the class. So here first we need to find out the mid values of each and every class interval. Because for continuous frequency distributions, the representation value of these class intervals is nothing but the corresponding mid values or class marks. So the mid values for these intervals are 15, 25, 35, 45, 55, 65. So median can be any value, any mid value or any value whichever we like. But the best practice is choose the mid value against to the highest frequency. So here the highest frequency is 31. The mid value against to the highest frequency is 35. So your assumed mean is 35. Just we need to find out the assumed mean itself only. Next one. Next, 59. So to compute the arithmetic mean for this data, here the intervals are nothing but the inclusive type of intervals. For the calculation of arithmetic mean for inclusive type of classification, inclusive type of intervals, we need not convert the inclusive type of intervals into exclusive type of intervals. Just obtain the mid values of these intervals, which is denoted by x, that is 44, 48. The mid value is 46. Next 51, 56, 61, 66, 71. And number of students are nothing but the frequency values. Multiply f into x values and obtain the totals of f into x values as well as the f values and substitute in the formula. You'll get the answer. Right. Next. With this, we completed the model of arithmetic mean. All the models of arithmetic mean. Next one. Next model 2 is median. Next model 2 is median. Median is a value which divides the given data into two equal parts. Median is a value which divides the given data into two equal parts. So median is also known as the positional average because it depends on the positions of the observations. It depends on the positions of the observations. And also median is also known as the middlemost value of the given data after arranging the data in either ascending order or descending order of their magnitude. So to compute median in either discrete series or continuous series, is in either individual series or discrete series, first we need to arrange the data. In either ascending order or descending order, and after that compute the total number of observations n. After that compute the total number of observations n. Then median can be obtained by the formula n plus 1 by 2th term, if n is odd, and arithmetic mean of n by 2th term and n by 2 plus 1th term if n is even. This is the formula for calculating the median in either individual series or discrete series. And also the rank of median. There is one more thing is called as rank of median. Rank of median is given by the formula n plus 1 by 2, which gives us the position number of the median value. It gives us the position number of median value. Rank of median gives us the position number where the median lies in the given data. Now, see these problems. So first one, the median of 27, 30, 26, 44, 42, 51, 37. First, we need to arrange the given observations in either ascending order or descending order. By arranging these observations in ascending order, we will get 26, 27, 30, 37, 42, 44, 51. Since there are 7 observations only, 7 observations means n value becomes a 7. 7 is an odd number. So median is a value. Median is n plus 1 by 2th term. That is 7 plus 1, 4, 8. 8 by 2, 4, 4th term. What is the 4th term in your data? Arranged data, not from the original data. So you need to consider the 4th term of the arranged data. So your value is 37. Similarly, you can do the rest of the problems also. And see the 54th problem. For 899, 999, 391, 384, for all these observations, rank of median is. To find out the rank of median, we need not arrange the data in either ascending order or descending order. Just count the number of observations we have. So here we have 3, 4, 5, 6, 7, 8, 9, 10. 10 observations are there. So the formula for rank of median is just n plus 1 by 2. That is 10 plus 1 by 2 gives us 5.5. That means my median value lies at the position of 5.5 of the given data. Next one. The median of x, x by 2, x by 3, x by 5 is 10. For the observations x, x by 2, x by 3, x by 5. For these 4 observations, median value is given as 10. Here, number of observations is equal to 4. That means even number of observations are there. So to apply the median formula, first we need to verify that whether the given observations are in ascending order or descending order. First we need to verify that whether they are in order or not. So here in all the observations, x is quite common. X is common in all the observations. So observe the coefficients of x. Observe the coefficients of x. In the first term, the coefficient of x is 1. In the second term, the coefficient of x is 1 by 2, that is 0.5. In the third term, the coefficient of x is 1 by 3, that is 0.33. In the fourth term, the coefficient of x is 1 by 5, which gives us 0.2. So all these coefficients are in descending order, so that the given observations are in descending order itself. So since we are having even number of observations, the median can be written as arithmetic mean of 4 by 2th term, that is second term. The second term in the given data is x by 2, and 4 by 2 plus 1th term, that is 2 plus 1/3. The arithmetic mean of second term and third term, that is x by 2 plus x by 3 by 2, which is equal to 10. That implies 5x by 6, by taking the LCM of the numerator, 5x by 6 is equal to, on cross multiplication, it is 20. That implies x is equal to 20 into 6 by 5 gives us 24. Next. So properties of median. There are no much properties of median since it is a positional average. It has only 2 properties. That is, one is median is affected due to change of origin and scale technique, as well as the sum of absolute deviations taken from median is always minimum value. So here, if a constant value 10 is added to each observation of a set, a constant value 10 is added to each observation of a set. Adding a constant value means it is a change of origin technique. Since median is affected due to change of origin, so the median is also increased by the same value, that is 10. Similarly, the remaining problems also. Next, see the equation model here. 2 variables x and y are given by y is equal to 2x minus 3, and median of x is 20. So median of x is denoted by mx. Median of x is denoted by mx. In the equation model, if y is equal to a plus bx, then median of y is always equals to a plus b into median of x. A plus b into median of x. So according to that equation model, here the median of y is nothing but 2 into median of x minus 3. That is 2 into median of x is given as 20 minus 3, that is equal to 37. That is equal to 37. Next, similarly, how to compute the median in case of discrete series? How to compute the median in case of discrete series? The median can be computed. The median can be computed in case of discrete series, right? See the 61st problem. 61st problem. First, here it is not y, it is f, frequency values. So to obtain the median in case of discrete series, first we need to arrange the data according to x values. First we need to arrange the data according to x values in either ascending order or descending order. So here all the observations of x, all the values of x are already in ascending order. So need not arrange the data. Now next, so x values are given as 5, 7, 9, 12, 14, 17, 19, 21. And f values are given as 6, 5, 3, 6, 5, 3, 2, 4. So to obtain the median in case of discrete series, first we have to calculate the cumulative frequencies, which are by default it is less than cumulative frequencies. So cumulative frequencies can be obtained like this: 6, 20, 11, 14, 20, 25, 28, 30, 34. And the last value in cumulative frequency gives us the total frequency capital N, that is the total number of observations. Here the total number of observations is even number of observations. Since it is the even number of observations, so hence m is equal to arithmetic mean of capital N by 2th term and capital N by 2 plus 1th term. So that is arithmetic mean of n by 2, that is 34 by 2, 17th term and 18th term. How to identify the 17th observation of x and 18th observation of x? We can obtain these values of x from the cumulative frequencies. Here the cumulative frequencies means for the first 6 terms, the value of x is 5. For the first 6 terms, the value of x is 5. From 7th term to 11th term, the value of x is 7. From 12th term to 14th term, the value of x is 9. For 15th term to 20th term, the value of x is 12. From 21st term to 25th term, the value of x is 14. From 26th term to 28th term, the value of x is 17. From 29th term to 30th term, the value of x is 19, and from 31st term to 34th term, the value of x is 21. So here we need the values of 17th and 18th term. So from 15th term to 20th term, the values of x is 12, so that the 17th term is 12 and 18th term is also 12. The arithmetic mean of these two 12s is 12 plus 12 by 2 gives us 12. Next, how to compute the median in case of continuous series. How to compute median in case of continuous series. The median in case of continuous series can be obtained by the formula L plus n by 2 minus m by f into C, where L is equal to lower class boundary of median class. Lower class boundary of median class. And M is equal to preceding frequency to median class, preceding cumulative frequency to median class. And F is frequency of median class. And F is frequency of median class. C is equal to length of median class. Length of median class. Now the question is, what do you mean by a median class? What do you mean by a median class? Median class is a class interval corresponding to the cumulative frequency which is immediately greater than n by 2 value. So to compute the median in case of continuous series, first we need to identify this median class. Then only we can get the values of L, M, F and C. Right. Now see one problem here. See one problem here. Find median from the following data. Find median from the following data. So first we need to compute the cumulative frequencies first. First we need to compute the cumulative frequencies for the given data. So that is 5, 20, 50, 58, 60. So the last value in cumulative frequencies gives us n value, capital N value. Now to compute the median, first we need to identify the median class. So to identify the median class, n by 2 value is 30. N by 2 value is 30. Now the cumulative frequency which is immediately greater than 30 is 50. So the class interval corresponding to this cumulative frequency is nothing but median class. That means the probable value of the median should lie in between 30 to 60. The probable value of the median should lie in between 30 to 60. So now we have to apply the formula for this. So according to the formula, our L value here in this problem is 30. And our M value in this problem is 15. And F value in this problem is 30 again. 30 again. And C, length of the median class. The length of the median class is upper boundary minus lower boundary, that is 30. And capital N by 2 value is 30. Now, by substituting all these values in the formula, you'll get 30 plus N by 2 value is 30 minus M value is 15 divided by F value is 30 into C value is 30. 30 will get cancelled. So 30 plus 15, which gives us 45. Similarly, in case of inclusive type of intervals, first we need to convert these inclusive type of intervals into exclusive type of intervals, and then we have to calculate as we discussed in the earlier problem. Hello my dear student friends, welcome back to the marathon classes in statistics conducting by Masterminds, which is a prestigious educational institution in providing CA and CMA coaching at various levels like foundation, inter and final over AP and Telangana. In the previous session, we were discussed about some of the topics in arithmetic mean as well as the median. In today's class, in this chapter, we are going to discuss about some other positional values or partition values. Partition values are the values which divide the given data into several equal parts. Partition values are the values which divide the given data into several equal parts. So there are totally 4 types of partition values in our syllabus. There are 4 types of partition values in our syllabus. The first one is quartiles. The first one is quartiles. The quartiles are the values which divide the given data into 4 equal parts. Quartiles are the values which divide the given data into 4 equal parts, and for any distribution we are having only 3 quartile values, that is capital Q1, capital Q2 and capital Q3. And the second type is octiles. Octiles. Octiles are the values which divide the given data into 8 equal parts. So these values are denoted by O1, O2 and so on up to O7. So there will be 7 octile values to divide the given data into 8 equal parts. Similarly, third one is the deciles. Deciles are the values which divide the given data into 10 equal parts. And these values, these decile values are denoted by D1, D2 and so on D9. So for any data, for any distribution, there will be 9 decile values to divide the given data into 10 equal parts. And the fourth one is percentiles. Percentiles are also known as centiles. Percentiles are also known as centiles. These are the values which divide the given data into 100 equal parts. So for any distribution, there will be 99 percentile values which are denoted by P1, P2 and so on up to P99. So how to find these partition values in case of individual series, discrete series and continuous series? The formula for calculating these partition values in case of individual series. First one is quartiles. The formula for calculating quartiles in case of individual series is given by Qk is equal to k into n plus 1 divided by 4th term. K into n plus 1 divided by 4th term. Similarly, in case of discrete series, quartiles can be, kth quartile can be calculated by using the formula Qk is equal to k into capital N plus 1 by 4th term. Since these are the values which divide the given data into 4 equal parts. And similarly for continuous series, the formula for calculating kth quartile is equal to L plus Nk by 4 minus M by F into C, where k values here can be taken as either 1 or 2 or 3, because there are only 3 quartile values for any distribution. And the second one, is octiles. Octiles can be computed in case of individual series by using the formula OK is equal to k into n plus 1 by 8th term. K into n plus 1 by 8th term. And similarly, in case of discrete series, OK is equal to k into capital N plus 1 by 8th term. And in case of continuous series, OK is given by the formula L plus Nk by 8 minus M by F into C. And similarly, the next one is, third one is deciles. To compute the deciles in case of a discrete series, the formula is dk is equal to k into n plus 1 by 10th term. And in case of discrete series, dk is equal to k into capital N plus 1 by 10th term. And in case of continuous series, dk is given by the formula L plus nk by 10 minus m by f into c. Similarly, the fourth one is percentiles or centiles. Percentiles or centiles. To compute the percentiles in case of individual series is pk is equal to k into n plus 1 divided by 100th term. 100th term. Similarly, in case of discrete series, pk is equal to k into capital N plus 1 by 100th term. And in case of continuous series, pk is given by the formula L plus nk by 100 minus m by f into c. Now, in case of octiles, your k values will be from 1, 2 and so on 7. Since there are 7 octile values for any kind of distribution. Similarly, in case of deciles, the k values are 1, 2 and so on 9. Because there will be 9 decile values for any kind of distribution. At the same time, in case of centiles, k values will be 1, 2 and so on 99. So for any kind of distribution, there will be 99 percentile values. And also remember, my friends, to calculate these partition values, our data should be arranged in ascending order only. We cannot arrange them into descending order. Only median can be calculated by arranging the data in either ascending order or descending order. But the partition values, for the calculation of partition values, the data must be arranged in ascending order only. Right. Now, see the next problem, quartiles, problems on quartiles. Given that following are the wages of laborers 82, 56, 90, 50, 120, 75, 75, 80, 130 and 65. For this problem, I would like to calculate Q3 value. All the values here given, first arrange these values in ascending order. By arranging them in ascending order, we will get the values 50, 56, 50, 56, 65, 65, 75, again 75, 80, 82, 90, 120 and 130. So first arrange these values in ascending order. By arranging the given values in the ascending order, we'll get the values like this, and then count the number of observations, the number of values. Here we are having totally 10 values are there. So to compute third quartile, the formula for kth quartile in case of individual series is k into n plus 1 by 4. The term k into n plus 1 by 4th term. So now we need to find out the value of Q3. That means we need to replace 3 in place of k. So that the formula becomes here is 3 into n plus 1 divided by 4th term. So since n value is 10, so that is 3 into 11, 33 divided by 4th term. 33 divided by 4 gives us 8.25. 8.25th term. So this can be written as this value 8.25 is in between 8th term and 9th term, so that this value can be written as 8th term plus 0.25 into 9th term minus 8th term. 9th term minus 8th term. So the 8th term in your given data is 90. The 8th term in your given data is 90 and 9th term in your given data is 120. So substituting these values over here, then you will get 90 plus 0.25 into 120 minus 90. 120 minus 90 is 30. 30 into 0.25 is 7.5 plus 90 gives us 97.5. Similarly, how to compute the rank of first quartile or rank of any partition value? The rank of any partition value. The rank of kth quartile. The rank of kth quartile. Rank of kth quartile Qk is just given by the formula k into n plus 1 by 4, where k values are from 1, 2 and 3. Similarly, the rank of OK, kth octile. The rank of kth octile is given by the formula k into n plus 1 divided by 8, where k is equal to 1, 2, 3 and so on 7. Similarly, the rank of kth decile is given by the formula k into n plus 1 by 10, where k is equal to 1, 2, 3 and so on 9, since there are only 9 deciles. Similarly, rank of kth percentile is equal to k into n plus 1 by 100, where k values are from 1, 2 and so on 99. So rank of the partition value gives us the position number of that particular partition value. Now in this problem, what is the rank of first quartile? The rank of first quartile. So to find out the rank, we need not arrange the data in order, either ascending order. So first count the number of observations here. You will be given 7 observations in the data. So your n value here is 7. Your n value here is 7. And the rank of first quartile is given by the formula just n plus 1 by 4. That is 7 plus 1 by 4, which is equal to 2. That is 7 plus 1 by 4, which is equal to 2. Next, in case of discrete series. In case of discrete series also, to find out the partition values, you have to arrange the data according to the values of x. According to the values of x. So here in the given data, all the values of x are already arranged in ascending order. So we need not arrange again. So for this particular problem, I would like to find out the first quartile value. For this particular problem, I would like to find out first quartile value. So to find out the first quartile value, first write down the data here. X values are given as 6, 7, 8, 9, 10 and 11. And F values, frequency values are given as 7, 13, 20, 30, 28. And now to compute the partition values, first calculate the cumulative frequencies for your given data. Then that is 7, 20, 40, 70, 90 and 98. So the last value in the cumulative frequencies gives the value of capital N, that is the total frequency. And to find out the first quartile value, the formula is just capital N plus 1 by fourth term. Capital N plus 1 by fourth term. So that is 99 by fourth term. Capital N value is 98. So 98 plus 1 divided by fourth term, which is equal to 99 divided by 4 gives us 24.75th term. 24.75th term. So to calculate 24.75 is in between 24th term and 25th term. So this can be written as 24th term plus 0.75 into 25th term minus 24th term. How to find out this 24th term and 25th term? From the cumulative frequencies, we can find out the 24th term and 25th term. So in the cumulative frequencies, the first 7 values, the value of x corresponding to the first 7 observations is 6. Similarly, the value of x corresponding to 8, the observations is 8th to 20th term. 8th to 20th term, the value of x is 7. From 21st term to 40th term, the value of x is 8. So since here we need 24th term and 25th term. So the value of x is 8 here. So 8 plus 0.75 into 8 minus 8, which is equal to 8. 8 minus 8 is 0, 0 plus into anything is 0 plus 8 is 8. So like that, we can calculate any partition value. Similarly, in case of continuous series, how to find out the quartile values? So here in this problem, your data has been given as open-ended classes as well as inclusive type of intervals. So since the given data contains inclusive type of intervals, to obtain any partition value or median value, first we need to convert these intervals into exclusive type. So by converting these intervals into exclusive type, we will get the intervals like this. We will get the intervals of profits like this: less than 9.5, 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5. Right. Now the corresponding frequencies are given as 5, 18, 38, 29 2. 5, 18, 38, 29 2. So to calculate either first quartile or third quartile in case of continuous series, first we need to identify the respective class like Q1 class or Q3 class. So now here I am finding Q1. I am finding Q1 for this particular problem. To find the Q1, first we need to calculate the Q1. We need to identify the Q1 class. To identify the Q1 class, first calculate cumulative frequencies. The cumulative frequencies are here as 5, 23, 61, 81, 90 and 92. And the capital N value is 92. Now, find out the value of capital N by 4. Find out the value of capital N by 4. Capital N by 4 gives us 23. 92 divided by 4 gives us 23. Now observe the cumulative frequency which is immediately greater than N by 4 value. So the cumulative frequency which is immediately greater than N by 4 value is 61. The class corresponding to this cumulative frequency is nothing but your Q1 class. Q1 class. And the formula for calculating Q1 is Q1 is equal to L plus N by 4 minus M divided by F into C, where L is the lower class boundary of Q1 class. Where L is the lower class boundary of Q1 class. And M is the preceding cumulative frequency to Q1 class. M is the preceding cumulative frequency to Q1 class. And F is the frequency of Q1 class. And C is the length of the Q1 class. So here for this problem, L is 19.5 and N by 4 value is 23, minus M value is 23 again, and F value is this 38 into C value is 10. Here 23 minus 23 is 0. 0 by anything is 0. So that the answer here is 19.5. Since all the profits are given in terms of thousands of rupees, since all the profits here given in terms of thousands of rupees, so that we have to multiply the answer with 1000 to get the correct value. That is 19,500 rupees. The first quartile value is 19,500 rupees. So in the same manner, we can compute all the other positional averages like deciles, percentiles, and so on. So in this chapter, till now, in this chapter, we were covered the arithmetic mean, AM, we covered median, and we covered partition values as well. So some important points or some important advantages or disadvantages of arithmetic mean is, let me show the theory. We are going to discuss about the most important points, the most important merits and demerits of arithmetic mean. So as already we know that every one of us we know that arithmetic mean is always easy to understand and easy to calculate. And moreover, its computations or its calculations are based on all the observations. Based on all the observations. It is rigidly defined by a mathematical formula. Rigidly defined means the definition should be understood by each and everyone in the same manner, or the definition should be written in the form of a formula, mathematical formula, then it is said to be rigidly defined. Now, the most important thing is mean is least affected by sampling fluctuations. What do you mean by a sampling fluctuations? Sampling fluctuations means the variations. Variations among the observations of a sample. Variations among the observations of a sample. So, the sample can be selected from population. The sample can be selected from population. We can select so many samples from a population. We can select any number of samples from a population. So, if the average or the arithmetic mean computed for these sample observations should be least affected by the variations among the observations of the sample. The variations among the observations of a sample is known as sampling fluctuations. Since arithmetic mean depends on all the observations, so that arithmetic mean is least affected by sampling fluctuations. Similarly, it can be subjected to further algebraic treatment. That means arithmetic mean has certain desired mathematical properties, as we discussed in the previous classes, previous sessions. So arithmetic mean has certain desirable mathematical properties, hence it is capable of further algebraic treatment or further mathematical treatment. And the disadvantages of this arithmetic mean is it cannot be located graphically. It cannot be located graphically, and extreme values have greater effect on mean. Extreme values have greater effect on mean. For example, if I am considering the salaries of 5 employees like this, the salaries of 5 employees like this, 5,500, 4,000, 2,500, 4,500 and 6,500. Now the arithmetic mean for these salaries of 5 employees is 5,500 plus 2,500 is 8,000, plus 4,000 is 12,000, plus 11,000. 12,000 plus 11,000, 23,000 divided by 5 gives us 4,600. Gives us 4,600. Now, suppose by mistakenly, if I consider one observation among these observations, like 65,000 instead of 6,500. If I am considering this observation 65,000 instead of 6,500. This observation, when compared to the remaining observations, it is little bit high value. Because of this high value, the average salary now becomes, that is 8,000, 12,000, 12,000 plus 65,000, 77,000, and plus 4,500 is 81,500. So 81,500 gives us the average of 16,300. 300. So because of this extreme high value only, my arithmetic average salary has been raised from 4,600 to 16,300. So arithmetic mean is highly affected due to the extreme high value, whether by the extreme, either extreme high values or by the extreme low values. Next, it cannot be determined for qualitative data such as love, beauty, honesty, etc. Arithmetic mean cannot be calculated for qualitative data. Similarly, for the median also, median is the best measure for qualitative data, best measure of central tendency for qualitative data, as well as median is also best measure in case of open-end series. Median is also a best measure of central tendency in case of open-end series. And it is not affected by extreme values. Mode is not affected by extreme values because mode does not depend on all the values. It depends on only the middle term. It depends on only the middle term. If any extreme values exist, extreme high values or extreme low values exist in the given data, after arranging them, after arranging the given data in either ascending order or descending order, all those extreme values comes to one end of the distribution. And the median depends on the middle term, so that median does not affected by extreme values. And it can be located graphically by using ogive curves. Median can be located graphically by using ogive curves. And the main disadvantages for this particular median is it is a positional average. It is a positional average and it is based on only middle term, middle item only. It does not take into account all the items in the series. And it is not capable of further algebraic treatment because it does not have certain desirable mathematical properties since it is a positional average. Similarly, median does not have sampling stability. That means median is highly affected. Median is highly affected due to sampling fluctuations. Median is highly affected due to sampling fluctuations. Whenever the sampling fluctuations are high, then there will be no stability in the samples. If the sampling fluctuations are low, then the sampling stability will be more. So with this, almost all the most important topics in this chapter are over. We are going to start the third chapter called Measures of Central Tendency Part 2. In this part, we are going to discuss about some more measures of central tendency other than arithmetic mean, median. We are going to discuss about mode, geometric mean and harmonic mean. So first, we'll see about the mode. Mode can be defined as the value which occurs maximum number of times in a given data. Mode is a value which occurs maximum number of times for a given data. So for any distribution, we may have one mode value, or we may have two mode values, or we may have more than two mode values also. In some situations, mode does not exist also. See in this problem, what is the model value for the numbers 5, 8, 6, 4, 10, 15, 18, 10? So in this data, 10 is occurred maximum number of times. 10 repeated maximum number of times for 2 times. So here there is only one mode value, that is 10. Similarly, in the next example, the mode of the numbers 7, 7, 7, 9, 10, 11, 11, 11, 12. Here, two values are repeated maximum number of times. That is 7 and 11. 7 and 11. Both the values are repeated maximum number of times. So, here we are having two mode values, that is 7 and 11. So if any distribution having only one mode value, that distribution is known as unimodal distribution. If any distribution is having only one mode value, then that distribution is known as unimodal distribution. If any distribution is having two mode values, then the distribution is known as bimodal distribution. Bimodal distribution. If any distribution is having more than two mode values, then the distribution is known as multimodal distribution. Now see the next example. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Here all the values are repeated equal number of times. In any distribution, if all the values are repeated equal number of times, then there does not exist mode value. Mode value does not exist. So here in this case, the mode value does not exist. If the same data can be given like this, if the same data can be given like this 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6. In addition to 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, if 6 is there in the data, then all these 5 values 1 to 5 are repeated maximum number of times. Only 6 is repeated only one time. So in that case, we are having 5 mode values. In that case, we are having 5 mode values. So remember, my dear friends, in any distribution, if all the values are repeated equal number of times, then mode does not exist. And now coming to the properties of mode. Mode is also not having much properties. The only property here is mode is affected due to change of origin and scale. That means if a given series of each item is increased by 8, increased by 8 means it is a change of origin technique. So mode is affected by change of origin technique and it is also increased by the same value. So here the mode of the new series of items is also increased by 8. Similarly, if each value of a series is multiplied by 5, 10 means it is a change of scale technique. So mode is also affected due to the change of scale. So the mode of the coded value is 10 times the original mode value. Next, similarly, the equation model. Equation model in case of mode is, if y is equal to a plus bx, then mode of y, mode is always denoted by the letter z. Mode is denoted by the letter z and mode of y is given as a plus b into mode of x. A plus b into mode of x. According to this equation model, here y is given as 3 plus 1.9 into x and mode of x is given as 15, that is zx is given as 15. Then we need to find out the zy value. We need to find out the zy value. Zy can be obtained by the equation 3 plus 1.9 into zx. 1.9 into zx. By substituting zx value in this, we will get 1.9 into 15 gives us 28.5 plus 3 is 31.5. And now, next one, how to find out the discrete series, how to find out the mode in case of discrete series. In case of discrete series, mode is the value of the variable, corresponding to the maximum frequency. Mode is the value of the variable corresponding to the maximum frequency. Here, number of men is nothing but frequencies. So the maximum frequency here is 13. The value of the variable corresponding to this maximum frequency is 5. So your mode value is 5. Now, next one, how to compute this mode value in case of continuous series. How to compute this mode value in case of continuous series. Mode value can be obtained in case of continuous series by using the formula Z is equal to L plus F minus F1 divided by 2F minus F1 minus F2 into C. 2F minus F1 minus F2 into C, where L is equal to lower class boundary of model class. Lower class boundary of model class. And F is equal to frequency of model class. Frequency of model class. F1 is equal to preceding frequency to model class. Preceding frequency to model class. And F2 is equal to succeeding frequency to model class. Succeeding frequency to model class. And C is equal to length of model class. Length of model class. Model class. What do you mean by a model class? Model class is a class interval corresponding to maximum frequency. Model class is a class interval corresponding to maximum frequency. Now, how to obtain mode for this problem, for this data? Here the class intervals are given as 3 to 6, 6 to 9, 9 to 12, 12 to 15, like that. First, to compute the mode value in case of continuous series, first observe that whether the given class intervals are in the form of exclusive type or not. If not, we have to convert them into exclusive type first. After that only we can compute the mode value. So here all the intervals, here all the intervals are in exclusive type. So first we need to identify the model class. Model class is a class interval corresponding to the maximum frequency. Here the maximum frequency is 23. So the class interval corresponding to this maximum frequency is known as model class. Model class. And now the value of L here is 12, lower class boundary of model class, and F value is the frequency of model class F, and F1 is the preceding frequency to the model class. Preceding frequency means the frequency of the previous class than model class. And F2 is the succeeding frequency to the model class. Succeeding frequency means the frequency of the next higher class to the model class. And C is the length of the model class, that is 3. By substituting all these values in the formula, we will get mode of this data. Like that, we can compute mode very easily, and mode can be obtained at a single glance also. Mode can be determined at a single glance also. Now, next model in this chapter is geometric mean. Before discussing about the geometric mean, here there is a relation between mean, median and mode. There is a relation between mean, median and mode. Remember, here for any distribution can be classified into two categories. Any distribution can be classified into two categories. One is symmetrical distribution. One is symmetrical distribution or normal distribution and the second one is asymmetrical distribution or skewed distribution So in case of symmetrical distribution, the relationship between mean, median and mode is nothing but mean equal to median equal to mode. Mean equal to median equal to mode. That means in any distribution, if all the values of mean, median and mode are equal, then the distribution is known as symmetrical distribution or normal distribution. Whereas in case of asymmetrical distribution, mean is not equal to median is not equal to mode. Mean is not equal to median is not equal to mode. That means there is some variation between all these three values, mean, median and mode. So the lack of symmetry is known as asymmetrical. The lack of symmetry is known as skewness. So again, this skewed distribution can be classified into two types again. One is called positively skewed distribution. And second one is called negatively skewed distribution. In positively skewed distribution, mean is always greater than mode. In positively skewed distribution, mean is always greater than mode. And for negatively skewed distribution, mean is always less than mode value. And median is always lies in between mean and mode in case of skewness. Median always lies in between mean and mode. So in case of asymmetrical distribution, if any of two values are given, any two values among mean, median and mode are given, to find the third value, we have some relationship known as empirical relationship. That empirical relationship is given as mode is equal to 3 median minus 2 mean. 3 median minus 2 mean. This is the empirical relationship. By using this empirical relationship, we can answer these questions. See here. 14th problem. See the 14th problem. For a moderately skewed distribution of marks in statistics for a group of 200 students, we don't bother about the number of observations or the number of students or number of observations here. The mean mark and median mark were found to be mean value x bar value is given as 55.60 and median value is given as 52.40. Now we need to find out the modal mark. That means we need to find out the mode value. So to obtain the mode value for this data, the formula, the empirical relation between these three is z is equal to 3 median minus 2 mean. That is 3 into 52.40 minus 2 into 55.60. On substituting these values and simplification, we will get the answer as 46. Like that, we can solve the problems in the relation between mean, median and mode. Now next, coming to the next model, geometric mean. Geometric mean is defined as the nth root of product of observations. Geometric mean is defined as the nth root of product of observations. Nth root of product of observations. So in case of individual series, the geometric mean can be obtained by the formula nth root of product of the observations x1 into x2 into and so on xn. x1 into x2 into and so on xn in case of individual series. In case of individual series. And similarly, in case of discrete series or continuous series, the geometric mean is given by the formula capital Nth root of x1 power f1 into x2 power f2 into and so on xn power fn. Xn power fn. So this is the formula in case of either discrete series or continuous series. But here the problem is to find out the roots. If we are having more than two observations, then to calculate this geometric mean, we need to find out the cube roots or fourth roots or fifth roots like that. So the computation of cube roots, fourth roots, fifth roots are quite difficult. So that the calculation part of geometric mean is quite difficult than arithmetic mean. And now, if any of these observations is a negative value, if any of these observations has a negative value, then the product of these observations is also negative and the root of the negative value is not real. In that case, we cannot determine the geometric mean value. Similarly, if any of these n values is 0, if any one of n values is 0, then the geometric mean is always equals to 0. So in case of so here to compute the geometric mean, all the observations should be strictly greater than 0. For the computation of geometric mean, all the observations should be greater than 0. That means all the observations should have positive sign and none is 0. None is 0. Now, here to compute the cube roots, fourth roots, it is quite difficult. Then what to do? Then how we can solve these problems? In that case, we can take the help of logarithms. In that case, we can take the help of logarithms. So by applying the logarithms on both sides, we'll get logarithm of geometric mean is equal to logarithm of x1 into x2 into and so on xn whole to the power of 1 by n. Nth root can be written as like this also, whole to the power of 1 by n. And this is in the form of log a to the power of m. So here this can be written as 1 by n into log of x1 into x2 into and so on xn, which is equal to 1 by n into, this is in the form of log AB. So according to that formula, you'll get log x1 plus log x2 plus and so on plus log xn. That is, simply we can write like this, 1 by n into summation log x. So log gm is equal to 1 by n into summation log x. That means logarithm of geometric mean is equal to the arithmetic mean of logarithms of the observations, because here this is in the form of sum of the observations divided by number of observations. Sum of observations divided by number of observations. So this is the arithmetic mean of logarithms of the observation. Logarithm of geometric mean is equal to the arithmetic mean of logarithm of the observations. From this formula, geometric mean can be obtained by anti-log of summation log x divided by n. Anti-log of summation log x divided by n. Even then, the calculation of geometric mean is quite difficult than arithmetic mean. Now, how to compute geometric mean? When to use this geometric mean particularly? When to use this geometric mean particularly? We can use this geometric mean if the data contains any rates, ratios, and percentages. If the data contains any rates, ratios, and percentages, then only we can use this geometric mean to calculate the average of those rates, ratios, and percentages. And also, geometric mean is the best average for the construction of index numbers. For the construction of index numbers, geometric mean is the best average for the construction of index numbers. Now, how to compute the geometric mean in case of individual series? See the problem number 20. See the problem number 20. Here, the data given is the rates of returns. The rates of returns, since the data contains the rates from three different shares, are 100%, 200%, and 400%. All these values in terms of percentages. Now, to compute the average rate of return, since the data contains the rates in terms of percentages, so here to compute the average rate of return, we need to compute the geometric mean between these three values. So the geometric mean between 100, 200, and 300 is, the geometric mean between 100, 200, and 300 is cube root of, because there are three values only, 100 into 200 into 400. So which is equal to 100 into 200 can be written as 2 into 100. 400 can be written as 4 into 100 whole to the power of 1 by 3. Since 100 into 100 into 100 3 times, that is 100 cube, into 2 into 4 is 8. 8 is nothing but 2 cube. So 100 cube into 2 cube whole to the power of 1 by 3, which gives us 200. So the average rate of return here is 200%. Similarly, The properties of geometric mean. If all the observations of a variable are equal, then the corresponding geometric mean is also the same constant value, that is 30. At the same time, the geometric mean of product of two series, the geometric mean of product of two series, that is geometric mean of xy, can be written as geometric mean of x into geometric mean of y, into geometric mean of y. Similarly, geometric mean of x by y, can also be written as geometric mean of x divided by geometric mean of y. Geometric mean of y. So here geometric mean of x is given as 10, geometric mean of y is 15, then geometric mean of xy is geometric mean of x into geometric mean of y gives us 150. And now, how to compute geometric mean in case of discrete series? The formula for calculating the geometric mean in case of discrete series is capital Nth root of x1 power f1 into x2 power f2 into xn power fn. So for this data, your capital N value is nothing but 10. Total frequency, capital N is nothing but total frequency is 10. So for this data, the geometric mean can be computed like this. Geometric mean is equal to 10th root of x1 power f1, that is 2 power 2 into x2 power f2, that is 4 power 3 into x3 power f3, that is 8 power 3 into x4 power f4, that is 16 power 2. So this is equal to 2 square into 4 can be written as 2 square. 2 square whole cube gives us 2 power 6 into 8 is nothing but 2 cube. 2 cube whole cube give us 2 power 9 into 16 is 2 power 4. 2 power 4 whole square gives us 2 power 8 whole to the power of 1 by 10, which is equal to 2 power 25 divided by 10. That is 2 power 5 by 2, which is equal to square root of 2 power 5. That is square root of 32. It gives us the value of 5.66. Like that, we can calculate the problems in geometric mean. In the next section, we are going to continue this chapter with harmonic mean. Hello, my dear student friends. Welcome back to the marathon classes in statistics conducting by Masterminds, which is a prestigious institution in providing coaching in CA and CMA courses at various levels like foundation, inter and final over AP and Telangana. In the previous class, we started the chapter measures of central tendency and part 2, and we were discussed about the mode relationship between mean, median and mode and geometric mean. In this session, we are going to discuss about the harmonic mean as well as the relationship between AM, GM and HM. So first, harmonic mean. What do you mean by harmonic mean first? What do you mean by harmonic mean? Harmonic mean is defined as the reciprocal of arithmetic mean of reciprocals of observations. So in case of individual series, harmonic mean can be computed by using the formula n divided by summation of 1 by x in case of individual series. In case of discrete or continuous series, the formula for harmonic mean is summation f divided by summation of f by x in case of either discrete series or continuous series. So which is the reciprocal of arithmetic mean of reciprocals of observations. So even though HM harmonic mean is based on all the observations of the given data, but it is quite difficult in the view of calculation point of view. So because this formula involves the reciprocals, because of those reciprocals it is quite difficult to compute. At the same time, if any of the observations is zero, then your harmonic mean is always equals to zero. So here all the observations assumed by a variable should be non-zero values. All the observations assumed by the variable should be non-zero values. And when to use this harmonic mean particularly? This harmonic mean can be used if the data contains rates and ratios, and the speed and distance related problems, and for time related problems, as well as price related problems. So in case of speed and distance problems and time related problems and price related problems, it is particularly useful. When the data contains rates and ratios, we may use the geometric mean also. So HM is particularly useful for the problems related to speed and distance, time, price, etc. Now, how to solve the problems? In harmonic mean. See here, for the first problem, the harmonic mean for the numbers 2, 3 and 5 is, since there are only three numbers, so that the harmonic mean can be obtained by the formula HM is equal to n divided by summation of 1 by x for case of individual series. So here number of observations n is nothing but 3, and all the three observations are 2, 3 and 5. Sum of the reciprocals is nothing but 1 by 2 plus 1 by 3 plus 1 by 5. And the LCM for the denominator part is, nothing but 30. So 2 15s 30 plus 3 10s 30 plus 5 6s 30. Now this can be written as 3 into 30 divided by 31. That is 90 divided by 31. It gives us approximately 2.90. Similarly, if all the observations assumed by a variable are constant like this, then the corresponding harmonic mean is also equals to the same constant value 20. Now, because of the properties of harmonic mean, according to the properties of harmonic mean, like arithmetic mean, we can compute we can compute combined harmonic mean. We can compute combined harmonic mean as well as we can compute weighted harmonic mean. We can compute weighted harmonic mean. The combined harmonic mean can be obtained by the formula HM12 is equal to N1 plus N2 divided by N1 by H1 plus N2 by H2. N2 by H2. So there are two particular cases. There are two particular cases for this combined harmonic mean. Those two particular cases are first case, if N1 equal to N2, then your combined harmonic mean is given by the formula HM12 is equal to 2 divided by 1 by H1 plus 1 by H2. Second case, if H1 equals to H2, then your combined harmonic mean is same as either H1 or H2. Here N1 represents the number of observations of the group 1 and N2 represents the number of observations of group 2. H1 represents the harmonic mean of group 1 and H2 is the harmonic mean of group 2. Now similarly, we can compute the weighted harmonic mean also. The formula for weighted harmonic mean is HMW is equal to summation W divided by summation W by X. HM is equal to summation W divided by summation W by X. Now the question is when to apply simple harmonic mean and when to apply weighted harmonic mean. When to apply simple harmonic mean, when to apply weighted harmonic mean. So simple harmonic mean and weighted harmonic mean can be applied in case of speed, distance related problems, time related problems and price related problems. So if distance is same, but speeds are varying, then to compute average speed, we have to apply simple harmonic mean. A second case, if both the distance and speeds are varying, if both the distance and speeds are varying, then to compute average speed, we have to apply weighted harmonic mean. Similarly, in the third case, if total time is fixed, but speeds are varying, then we need to calculate the average speed. We have to apply weighted harmonic mean. And next, for price related problems, if total worth of prices is same, total worth is same, but prices are varying, then to compute average price, we need to use simple harmonic mean. Similarly, if total quantity is same, but prices are varying, then to compute average price, we need to use simple harmonic mean. Remember these 5 points to solve the applications of simple harmonic mean and weighted harmonic mean. Sorry, a total quantity is same but prices are varying, then to compute the average price, we need to calculate the simple arithmetic mean. We need to consider simple arithmetic mean. Please remember these 5 points to solve the problems based on the applications of simple and weighted harmonic means. Now, the next problem based on combined harmonic mean is, see the 30th problem. HM of 15 quantities is 10, and in which the HM of 10 quantities is 12. These 10 quantities are among all the 15 quantities we have. So these 15 quantities are divided into 2 groups. In the first group we are having 10 quantities, and in the second group we are having 5 quantities. Now here we need to calculate what is the given information and what we need to calculate. Here totally there are 15 quantities are there. Those 15 quantities are divided into 2 groups. The first group contains 10 quantities and the second group contains 5 quantities. And the harmonic mean of the first 10 quantities has been given. The harmonic mean of the first 10 quantities is given as 12. And the combined harmonic mean is given as 10. All the 15 quantities, the harmonic mean of all the 15 quantities is given as 10. Then we need to find out the harmonic mean of the 5 quantities. That means we need to find out the H2 value. So according to the formula of combined harmonic mean, the formula for combined harmonic mean is nothing but N1 plus N2 divided by N1 by H1 plus N2 by H2. N2 by H2. On substitution of all these values, HM12 value is given as 10. N1 plus N2 value is nothing but 15 divided by N1 by H1, that is 10 by 12 plus 5 by H2. 10 by 12, 2 5s, 2 6s, that is 5 by 6. And the LCM for the denominator part is nothing but 6H2, that can be written as 5 into 6H2 divided by 5H2 plus 30. On cross multiplication, we will get 50H2 is equal to 50H2 plus 300 is equal to 30H2. (50H2 plus 300 is equal to 30H2. Then 20H2 is equal to 300. 20H2 is equal to 300. Sorry, 15 into 6H2, that is 90H2, 90H2, and 90H2 minus 50H2 is 40H2, 40H2 is equal to 300, so that H2 value is nothing but 300 by 40, which gives us 7.5. So in the same manner, we can compute the remaining problems of combined harmonic mean also. Now, next, how to compute this harmonic mean in case of discrete series or continuous series. I am going to discuss about the continuous series. I am going to discuss about the continuous series. To calculate the harmonic mean for continuous series, first we need to calculate the mid values which are denoted by x. Mid values of the class intervals which are denoted by x. So the mid value for the interval 10 to 19 is nothing but 14.5. The mid value for 20 to 29 is 24.5, 34.5, 44.5. After calculating these mid values, next we need to calculate the f by x values. We need to calculate f by x values. Here, f by x values, that is 6 divided by 14.5, 6 divided by 14.5 gives us 0.413. Similarly, 7 divided by 24.5 gives us 0.285. And 5 divided by 34.5 gives us 0.144. And finally, 2 divided by 44.5 gives us 0.044. So the total of these values gives us 0.886, and the total frequency is itself 20. The total frequency is itself 20. 6 plus 7 plus 5 plus 2 gives us 20. Now to compute the harmonic mean, we need to apply the formula summation f divided by summation of f by x. That is 20 divided by 0.886, which gives us the value 22.573. Which gives us the value 22.573. Now, how to solve the problems based on the applications of simple and weighted harmonic means? To solve the problems based on the applications of simple and weighted harmonic means, please do remember all these 5 points. Please do remember all these 5 points. That is, if the distance is same but speeds are varying, then to compute the average speed, we need to consider simple harmonic mean. If both the distance and speeds are varying, then to compute the average speed, we need to consider weighted harmonic mean. And if the total time is fixed but the speeds are varying, then to compute the average speed, we need to consider weighted harmonic mean. As well as if the total worth is same but prices are varying, then to compute the average price, we need to apply simple harmonic mean. And if the total quantity is same but prices are varying, then to compute the average price, we need to apply the simple arithmetic mean. If you remembered all these points, then we can easily solve these problems on applications of simple and weighted harmonic mean. Now, see the 34th problem. See the 34th problem. A lady traveled at a speed of 20 kilometers per hour and returned at a quicker speed. That lady traveled at a particular distance. That particular lady traveled a particular distance from source point to the destination point at a speed of 20 kilometers per hour and returned at a quicker speed. We don't know the return speed. So let us denote that is x kilometers per hour. And also given that the average speed, her average speed of the whole journey means to and fro, is 24 kilometers. Average speed of whole journey, that means to and fro, is 24 kilometers per hour. Now we need to calculate the speed of the return journey. The speed of the return journey. Here the lady traveled at a fixed distance. Here distance is fixed, but speeds are varying. If distance is fixed and speeds are varying, then to compute the average speed, we need to consider the simple harmonic mean. So according to the simple harmonic mean, the formula for average speed is, totally we are having two observations are there. One is 20 kilometers per hour and second one is x kilometers per hour. So the formula for average speed becomes 2 divided by 1 by 20 plus 1 by x, which is equal to 24 kilometers per hour. On simplification, it becomes 40x divided by x plus 20 is equal to 24. On cross multiplication, we can obtain 40x is equal to 24x plus 480. 40x minus 24x is nothing but 16x is equal to 480 and x is equal to 30 kilometers per hour. Then the speed of the return journey is 30 kilometers per hour. And similarly for the next problem, a person covers 12 kilometers at 3 kilometers per hour, 18 kilometers at 9 kilometers per hour, 24 kilometers at 4 kilometers per hour. Find the average speed in covering the whole distance. Here the speeds are given as well as the distances are also given. Speeds are given as well as distance is also given. A person covers 12 kilometers of distance at the speed of 3 kilometers per hour. So with the speed of 3 kilometers per hour, that person traveled 12 kilometers distance. At a speed of 9 kilometers per hour, the person traveled 18 kilometers per hour. 18 kilometers. At a speed of 4 kilometers per hour, that person traveled 24 kilometers. The speeds are in terms of kilometers per hour and the distance is in terms of kilometer. Here both the distance and speeds are varying. Both the distance is varying as well as speeds are varying. Then to compute the average speed, if both the distance and speeds are varying, then we need to apply the weighted harmonic mean. The weighted harmonic mean. So to apply the weighted harmonic mean, first we need to identify what is the variable here and what are the weights corresponding to those variable values. So here we need to compute the average speed. So the averages are always computed for the variables. So here the variable becomes the speed. So these speed values are nothing but denoted by x. And the corresponding distance values are the corresponding weights. With the 3 kilometers per hour speed, that person traveled 12 kilometers. So this is the weightage for this particular speed. So according to the weighted harmonic mean, we need to calculate the values of w by x. That is 12 divided by 3 gives us 4, 18 divided by 9 gives us 2, 24 divided by 4 gives us 6. And summation of the W by X values are 12. And summation of the distance values, that is W values, is nothing but 54. Now the formula for weighted harmonic mean is HMW is equal to summation W divided by summation of W by X. That is equal to summation of W is 54 divided by summation of W by X is 12. That gives us 54 divided by 12 gives us 4.5. Like that, we can compute the problems, we can solve the problems in both weighted harmonic mean and simple harmonic mean. Now, next, the relationship between AM, GM and HM. Next, relationship between AM, GM and HM. GM and HM. There are 4 cases of relationships are there. First case, if all observations assumed by a variable are same, then AM is always equals to GM is always equals to HM. AM is always equals to GM is always equals to HM. Next, if for any n positive numbers, the relation is AM is greater than or equal to GM is greater than or equal to HM. And the third case is for any n distinct positive numbers, the relationship between AM, GM and HM is AM is strictly greater than GM is strictly greater than HM. And the last case, for only two observations, the relationship between AM, GM and HM is GM square is equal to AM into HM. GM square is equal to AM into HM, or GM is equal to square root of AM into HM. This is the relationship between AM, GM and HM. Now, how to solve the problems based on these relationships? How to solve the problems based on these relationships? Now, see the 38th problem. If the arithmetic mean between two numbers, there are only two numbers are there, two observations are there. For those two observations, arithmetic mean is given as 64 and geometric mean is given as 16. So we have been given for only two numbers, arithmetic mean is given as 64 and geometric mean is given as 16. Then find out the harmonic mean. So for only two observations, the relationship between AM and HM is GM square is equal to AM into HM. According to that formula, HM can be written as nothing but GM square divided by AM. That is 16 into 16 divided by 64. It gives us 4. Similarly, see the problem 42. if the harmonic mean of two numbers is 4, here also given that the harmonic mean for only two observations, so that is given as 4. Harmonic mean is given as 4. This is also for two numbers. And also given that arithmetic mean and geometric mean satisfy the equation 2a plus g square is equal to 27. Arithmetic mean is denoted by a and the geometric mean is denoted by g, so that hm is denoted by h itself. hm is denoted by h. And am and gm are related by the equation 2a plus g square is equal to 27. 2a plus g square is equal to 27. Now, for the two numbers, the formula for the relation between arithmetic mean, geometric mean and harmonic mean is geometric mean square is equal to arithmetic mean into harmonic mean. According to that, this 2a plus g square can be written as 2a plus a into h is equal to 27. That implies h value is given as 4 here. H value is given as 4 here. On substituting this h value, we will get 2a plus 4a is equal to 27. That implies 6a is equal to 27. That implies a is equal to 4.5. 27 divided by 6 is 4.5. This is the a is the arithmetic mean of two numbers. Let us say those two numbers are a and b. Let us say those two numbers are a and b. Then arithmetic mean between two numbers a and b is nothing but a plus b by 2, which is given as 4.5. Which is given as 4.5. Then a plus b is nothing but 9. A plus b is nothing but 9. Similarly, geometric mean between two numbers a and b is always equals to square root of a and b. Square root of a into b. Then geometric mean square is equal to ab. Geometric mean square is equal to ab. Geometric mean square is nothing but a into h is equal to ab. A value we obtained is 4.5. We obtained the a value as 4.5 and h value is given as 4 is equal to ab. That means ab value is nothing but 18. AB value is nothing but 18. By applying option verification method, for these two equations, that is a plus b is equal to 9 and ab is equal to 18, by applying the option verification method, we may get the values a is equal to 3 and b is equal to 6, or a is equal to 6 or b is equal to 3. The two numbers are 3 and 6 or 6 and 3. So the option is 6, 3. Like this, we can solve the problems based on the harmonic mean also. Now, coming to some small important theory part, that is features of a good average. Features of a good average. That means till now, both the parts of measures of central tendency together, we learned about five measures of central tendency or 5 types of averages. That is arithmetic mean, median, mode, geometric mean and harmonic mean. So any average is said to be a good average. Any average is said to be a good average. That average should satisfy all these features. And that average should satisfy all these features. But unfortunately, no average is a good average. Unfortunately, no average is a good average because no average satisfying all these 9 features. Among all these 9 features, most of the features are satisfying by arithmetic mean. So that arithmetic mean is known as the most stable measure of central tendency, the most commonly used measure of central tendency. So what are those features we need to satisfy? An average should satisfy. The features are, first one, it should be properly and unambiguously defined. Properly and unambiguously defined. The definition of the average should be simple and does not have any difficulty in the definition. That is the meaning of properly and unambiguously defined. Next, second one, it should be rigidly defined. It should be rigidly defined. That means if the definition can be understood by every person in the same manner, then we can say that the definition is rigidly defined. Next, it should be easy to understand and easy to compute. An average should be easy to understand. First, we need to understand the concept, and then it should be very easy to compute also. And a good average should be based on all the observations of the data. And also, it should be least affected by the presence of extreme observations. That means the presence of extreme high values or the extreme low values. A good average should be least affected by the presence of such extreme high values or extreme low values. And a good average should have certain desirable mathematical properties. That means a good average should be capable of further mathematical treatment or further algebraic treatment. And a good average should have sampling stability. That means a good average should be least affected by sampling fluctuations. What do you mean by sampling fluctuations? If the average is computed for similar groups, such averages should also be similar. And a good average should be found by graphical method also. And it should be easy to comprehend. That means after calculating, then the result, the value obtained should be easy to conclude or should be easy to explain. Right? So among all these 5 measures of central tendency, first we'll discuss about the arithmetic mean. Which feature can be satisfied by the arithmetic mean and which cannot be satisfied. Arithmetic mean is always properly and unambiguously defined. Yes, absolutely. And it is rigidly defined. And it is easy to understand and easy to compute. Arithmetic mean is based on all the observations. But arithmetic mean is highly affected by the presence of extreme observations. So arithmetic mean does not satisfy this property. Arithmetic mean does not satisfy this feature. Similarly, arithmetic mean has certain desirable mathematical properties, and arithmetic mean is least affected by the sampling fluctuations, and arithmetic mean cannot be found by the graphical method. And arithmetic mean is easy to comprehend also. Now coming to the median. Median is properly and unambiguously defined, and median is rigidly defined. Median is rigidly defined. Median is easy to understand and easy to compute. And median does not depend on all the observations. Median does not depend on all the observations. And median is not affected by the extreme values. Median is not at all affected by the presence of extreme observations. And median does not have desirable mathematical properties. Median does not have certain desirable mathematical properties. And median is highly affected by the sampling fluctuations. So median does not have sampling stability. And median can be found by the graphical method using histogram. Median can be found by the graphical method by using ogive curve. And median also easy to comprehend. Next, coming to the mode. Mode is properly and unambiguously defined, but mode is not rigidly defined. Mode is not rigidly defined because in all the situations we cannot obtain the same mode value. In some situations mode value may not exist. In some situations mode may have one value. So in some situations mode may have more than one value also. So mode is not rigidly defined. And mode is easy to understand and easy to compute. Absolutely. And mode is also does not depend on all the observations. Mode is also does not depend on all the observations. And mode is not much affected by extreme values. Mode is least affected by extreme values. And mode does not have certain desirable mathematical properties. Mode does not have certain desirable mathematical properties. And mode is not much affected by, mode does not have sampling stability also. Mode does not have sampling stability also. And mode can be found by the graphical method using histogram. And mode should be easy to comprehend. Mode value is easy to comprehend. So almost geometric mean and harmonic mean is like arithmetic mean itself, because all those are mathematical averages. So among all these averages, the arithmetic mean is the only average which is satisfying so many features of a good average. So that arithmetic mean is a most stable average or most commonly used measure of central tendency. With this, I am going to conclude this topic based on measures of central tendency. That is measures of dispersion. What do you mean by a measure of dispersion exactly? What do you mean by a measure of dispersion exactly? Measures of dispersion. Dispersion or variation or fluctuation or deviation. All these terms meaning is same. All these terms meaning is same. So till now, till the previous chapter, we were discussed about the central value of the given distribution. We were discussed about the central value of the given distribution. We till now we did not discuss any kind of variation. Till now we did not discuss about any kind of variations among the observations or the variations among the observations and the corresponding average. So in this session, in this chapter, we are going to study about such kind of variations among the observations and the corresponding average. Why we need to study the variations? Let me explain a small example. Let me explain a small example. There are three firms are there, A, B and C. There are three firms A, B and C. At firm A, employees are receiving the salaries like this: 2,300, 2,300, 2,300, 2,300. So for these 5 employees, the average salary is nothing but 2,300. Is nothing but 2,300. And for the second firm B, in the firm B, 5 employees' salaries are like this: some 2,500, 2,400, 2,300, some 2,700, 4,900, 9,900, and 2,600. Sorry, 1,600. 1,600. So the average salary for the firm B is also 2,300. And now for the firm C, the salaries of the 5 employees are like this: 6,000, 1,500, 2,000, and 1,000 and 500. So for this firms C also, the average salary is 2,300. So for all these 3 firms, the average salary is same. The average salary is same. That means all the 3 firms are paying the same salary structures to the employees. No, absolutely not. In the first firm, there is no deviation, no difference between the salaries of the individual employees as well as the corresponding average salary. There is no variation. But when compared to the firms A, B and C, when we are going to compare the firms B and C, the average salary for both B and C is same. But the variations among the observations, that means the salaries of the individual employees and the corresponding average salary, is very low when compared to the firm C. So for that particular purpose, we need to study about the variations also. We need to study about the variations also. So we are going to discuss various kinds of techniques to study such kind of variations. Right? So in these measures of dispersion, all these techniques to discuss about the variation of the observations from the corresponding average, those techniques are divided into 2 categories. Those measures of dispersion are divided into 2 categories. One is called absolute measures of dispersion. One is called absolute measures of dispersion, and second one is called relative measures of dispersion. Second one is called relative measures of dispersion. Absolute measures of dispersion tells us about the amount of variation. The amount of variation from the individual observation from the corresponding average. And relative measure of dispersion gives us the degree of variation, that is the ratio or the percentage of variation of the absolute measure from the corresponding average, that is degree of variation. Right. So in absolute measures, we are having four techniques, four methods called as range. Second one is quartile deviation, and third one is mean deviation, and fourth one is standard deviation. And the corresponding relative measures are given as coefficient of range, coefficient of range, coefficient of quartile deviation, coefficient of quartile deviation. Third one, coefficient of mean deviation. And fourth one, coefficient of variation. Coefficient of variation or coefficient of standard deviation. So all the absolute measures of dispersion tells us about the amount of variation, whereas the relative measures tells us about the degree of variation. And there are some more important differences between these absolute measures and relative measures. The differences are, absolute measures are very easy to calculate. The absolute measures are very easy to calculate, whereas relative measures are not easy to calculate. Not easy to calculate. And with the help of absolute measures, it is not possible to compare two different distributions. So it is not possible to compare two different distributions. For the comparison of two different distributions, relative measures are more suitable. Relative measures are more suitable. And the third point, the third difference, absolute measures are depends on units of measurement. Depends on units of measurement, whereas relative measures are unit free. That means it does not have, relative measures does not have any kinds of units of measurements of the variables. These are the basic differences between absolute measures and relative measures. Now the next concept is what are the features of an ideal measure of dispersion? What are the features of an ideal measures of dispersion? Like the features of an ideal measure of central tendency. So if any measure of dispersion is said to be ideal measure of dispersion, it should satisfy these features. The first feature is it should be rigidly defined. A measure of dispersion should be rigidly defined. And second one, it should be based on all the observations. It should be based on all the observations. And third one, it should be easy to understand and easy to calculate. Easy to understand and easy to calculate. And fourth one, it should be least affected by presence of extreme observations. It should be least affected by the presence of extreme observations. Similarly, it should be least affected by sampling fluctuations. It should be least affected by sampling fluctuations. And finally, it should have certain desirable mathematical properties. It should have certain desirable mathematical properties. And finally, it should be easy to comprehend. And finally, it should be easy to comprehend. So a good measure of dispersion should satisfy all these features. Now, coming to the first part, first method of dispersion or first measure of dispersion, that is range. The range is defined as the difference between the largest observation of the given data set and the smallest observation of the given data set. Largest observation of a given data set and smallest observation of a given data set, where L is equal to largest value and S is equal to smallest value. And this range is nothing but absolute measure covered. It is absolute measure, so that this is also known as absolute range. And the corresponding relative measure is given by, that is coefficient of range, is given by the formula L minus S divided by L plus S into 100. Here the factor into 100 is optional. So if we want to explain about the true variation, then we need not consider about into 100 factor here. If we are going to discuss about the percentage of variation, then we need to consider into 100. So that is optional. So coefficient of range is also known as relative range. Which is equal to L minus S is nothing but absolute range. Divided by L plus S is nothing but sum of two extreme values. So the relative range is given by the formula absolute range divided by sum of two extreme values. In the notations, it is just L minus S divided by L plus S into 100. Now, according to these formulas, range does not depend on all the observations. Range is rigidly defined. And range is not based on all the observations. Range is very easy to understand and easy to calculate. And range is highly affected by the extreme observations, because this is based on only the extreme observations. Similarly, range is highly affected by the sampling fluctuations, and range does not have certain desirable mathematical properties, and it is easy to comprehend. Now, next, how to compute the problems based on range. Before discussing the problems, let us discuss about some properties of range. Let us discuss about some properties of range. The first property is if all the observations of a given data set are same, that is k, 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 then the corresponding range is always equals to 0. Then the corresponding range is always equals to 0. Second one, range is not affected due to change of origin. Range is not affected due to change of origin. That means if a variable values are like this, 45, 50, 62, 22, 40. If my observations are like this, for this particular observations, range is nothing but the difference between highest value minus and least value. That is, highest value is 62 and least value is 22. So the difference between highest value and least value is 40. Now, change of origin means adding or subtracting a constant value to the original data. So suppose if I am going to add a constant value 5 to each and every observation of a given data set, then the observations becomes 50, 55, 67, 27, 45. Again, in the new observations, the highest value is 67 and the least value is 27. The difference between these two is nothing but 40 again. So here the range of the original observations is same as the range of the new observations. So that here there is no effect of change of origin. Because of adding a constant value, there is no effect in the range. So range is not affected due to change of origin. In the same manner, the third property is range is affected due to change of scale. Range is affected due to change of scale. For the same data 45, 50, 62, 22, 40. For the same data, range is nothing but 40. And if I am multiplying this range with some constant value 2, if I am multiplying the range with some constant value 2, then the new observations becomes 90, 100, 124, 44 and 80. Now the difference between 124 and 44 is 80. That means the original range value into the same constant value 2. So the multiplying or dividing by a constant to each and every value of the given data set is the technique of change of scale. So this 2 is called as the scale factor. So range is affected by the scale factor. Range is affected by the scale factor. So range is affected due to change of origin and scale. By the properties 2 and 3, the properties 2 and 3 together can be treated in this equation model. Can write in the form of the equation model. That is, if y is equal to some a plus bx, y is equal to some a plus bx, then range of y is always equals to mod b into range of x. Mod b into range of x. The same property is applicable for all the absolute measures of dispersion, range, quartile deviation, mean deviation, and standard deviation. So all the absolute measures of dispersion are independent of change of origin but not of scale. So with these properties, let us solve the problems based on range. Now, see the model 1, problems on range. Following are the wages of 8 workers expressed in rupees: 82, 96, 52, 75, 70, 65, 50, 70. Find the range and also its coefficient. Find the range and also its coefficient. So first identify the largest value in the given data. The largest value in the given data is 96. L value is 96. And the smallest value in the given data is 50. This is S. So the range is nothing but L minus S, that is 96 minus 50, 46. And coefficient of range is L minus S, that is 46, divided by L plus S, that is 146 into 100. 46 divided by 146 into 100. This value gives us approximately 31.51. So the answer is 46 and 31.51. Since the range is the absolute measure does contain the units of measurement, whereas relative measure is unit free, so it does not contain units of measurement of the variable. Similarly, we can compute the remaining problems in the individual series. Now coming to the properties of range. The range of 10 observations is 20. If each observation is increased by 15 means it is the change of scale origin technique. And range is not at all affected due to the change of origin technique. So the range of the new series is also the same value, that is 20. Similarly, here the range of 10 observations is 20, and if each observation is divided by minus 2, division by a constant value is called as change of scale technique. And range is affected due to the change of scale technique. And here our scale factor is minus 2. Just ignore the sign of the scale factor. And the range of new series can be obtained by 20, and each observation is divided. So by ignoring the sign of the scale factor, 20 is divided by 2, that is 10. So the answer is 10. Now coming to the equation model also. See the 7th problem. See the seventh problem. Relationship between P series and Q series is given by 2P minus 3Q minus 10 is equal to 0. 2P minus 3Q minus 10 is equal to 0. And range of P series, and the range of P series is 18. That is, RP value is given as 18. Now we need to find out the RQ value, range of Q series. So from this equation, we can write 3Q is equal to 2P minus 10. That implies Q is equal to 2 by 3P minus 10 by 3. Now here the scale factor is 2 by 3. According to the equation model, range of Q can be written as modulus of the scale factor into range of P, which is equal to 2 by 3 into 18, that is equal to 12. If in any case, if for the same problem, instead of this equation, if the equation is given as 2P plus 3Q minus 10, 2P plus 3Q minus 10 is equal to 0. Then also range 3Q can be written as minus 2 by 2P plus 10, and Q is nothing but minus 2 by 3P plus 10 by 3. In that case also range of Q is equal to modulus of minus 2 by 3 into range of P. That is also 2 by 3 into 18, which is equal to 12. Suppose if the same equation is given as like this, if the coefficients of the variables are changed, that is 3P minus 2Q minus 10 is equal to 0. If the equation gives like this, then your 2Q can be written as 3P minus 10 and Q can be written as 3 by 2P minus 10 by 2. Now the scale factor is 3 by 2. So RQ is equal to modulus of 3 by 2, that is 3 by 2 into RP is 18. Then your answer is 27. So if we change the coefficients of the variables, then you may get another value as the answer. Please observe that carefully. Next, coming to the discrete series, how to compute the range for discrete series? Range for the discrete series is the maximum value of the variable. Ignore the frequencies. Don't bother about the frequencies for computing range. So just observe the maximum value of the variable, that is 12, and the minimum value of the variable, that is 3. So range is nothing but 12 minus 3, 9, and coefficient of range is nothing but 9 divided by 12 plus 3, 15 into 100. So since the answers in the options, we are having the values like 0.6, 1.67, 0.6 like that. So there is no need of considering this into 100 factor. So 9 by 15 gives us 0.6. So that is answer is C. For the continuous series also, to compute the range, first all the class intervals should be in the form of exclusive series only. All the class intervals should be in the form of exclusive series only. But here all the intervals are given in inclusive type of series. First convert this into exclusive type so that you'll get the intervals like this: 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5. Now the range is nothing but the upper class boundary of the last class minus the lower class boundary of the first class. That is 59.5 minus 9.5 gives us 50. Now we need to find out the coefficient of range here. So that is 50 divided by 59.5 plus 9.5 gives us 69 into 100. So the answer for 50 divided by 69 into 100 is nothing but 72.46. So for the calculation of range in case of discrete series or continuous series, don't bother about these frequencies. Just see the highest value of the variable and the least value of the variable. That's it. Now coming to the quartile deviation. Quartile deviation. Quartile deviation. Quartile deviation. So quartile deviation is also known as semi-interquartile range. Semi-interquartile range. So first, what do you mean by interquartile range? What do you mean by interquartile range? Interquartile range is IQR. Quartiles means quartiles are the values which divide the given data into 4 equal parts. For any distribution, there will be 3 quartiles, which we were discussed in the earlier chapters. So quartile range means the range between the quartiles. The range between the quartiles. That means the range between the difference between the upper quartile and the lower quartile. That is nothing but Q3 minus Q1. Q3 minus Q1. That is the interquartile range. Interquartile range means the range between the quartiles. That is the difference between the upper quartile and lower quartile. And semi-interquartile range means half of the interquartile range. That is Q3 minus Q1 divided by 2. Q3 minus Q1 divided by 2. And the corresponding relative measure is given by the formula coefficient of quartile deviation is equal to Q3 minus Q1 divided by Q3 plus Q1 into 100. Here also into 100 factor is optional. Now, is quartile deviation depends on all the observations of the given data? Suppose if all the observations of the given data are in this real line, quartiles are the values which divide the given data into 4 equal parts, Q1, Q2, Q3. Quartiles are the values which divide the given data into 4 equal parts. And in each part, we are having 25% of the observations. In each part, we are having 25% of the observations. And here, according to the formula of quartile deviation, this is Q3 minus Q1 means the difference between the upper quartile and the lower quartile. So in between upper quartile and lower quartile, there are 50% of the observations. So quartile deviation is based on the middle 50% of the observations, and it is ignoring the first 25% of the observations and the last 25% of the observations. Quartile deviation is based on the middle 50% of the observations. It is ignoring the first 25% of the observations and the last 25% of the observations, so that quartile deviation does not affected by extreme observations. Quartile deviation does not affected by extreme observations, whereas quartile deviation is affected by sampling fluctuations, since these are the positional averages. Right. We'll continue the remaining part in the next session. Thank you. Thank you, one and all. Hello, my dear student friends. Welcome back to the marathon classes in statistics conducting by Masterminds, which is a prestigious educational institution in providing coaching for CA and CMA courses at various levels like foundation, inter, and final over AP and Telangana. In the previous session, we were started the fourth chapter called Measures of Dispersion, and also we were discussed about one measure of dispersion known as range, and also we were discussed about the introduction and the definition of the quartile deviation also. In this session, we will continue the quartile deviation with the problems to solve. How to solve the problems in quartile deviation. Now, see the first problem, 12th one. Following are the marks of 10 students, 56, 45, 65, 35, like that. For this data, we need to find out the quartile deviation and also its coefficient. The quartile deviation and also its coefficient. To obtain the quartile deviation, first we need to arrange the given set of observations in ascending order only to compute the lower quartile Q1 and the upper quartile Q3. So first, the given data here in the problem is 56. The given data is 56, 48, 65, 48, 65, 35, 42, 75, 35, 42, 75, 82, 60, 55, 50, 82, 60, 55, 50. This is the given set of observations. First, we need to arrange this set of observations into ascending order. So by arranging these values in ascending order, the least value is 35, and then 42, and then 48, 50, 55, 56, 60, 65, 75, and 82. So here we are having 10 number of observations. Here we are having 10 number of observations. To compute the quartile deviation or the coefficient of quartile deviation, first we need to compute the first quartile value, and then we need to compute the third quartile value. The first quartile value can be obtained by the formula n plus 1 by fourth term. N plus 1 by fourth term. Here n is 10, so 10 plus 1, 11. 11 by fourth term gives us 2.75th term. 2.75th term. This can be written as second term plus 0.75 into third term minus second term. Third term minus second term. So in our ascending order of data, the second term is nothing but 42 plus 0.75 into third term is 48 minus 42. 48 minus 42 gives us 6. 6 into 0.75 gives us 4.5. 4.5 plus 42 gives us 46.5. Similarly, Q3 can be obtained by the formula 3 into capital N plus 1 3 into N plus 1 divided by fourth term. Since N is 10, 10 plus 1 11, 11 into 3 33, 33 by 4 gives us 8.25. So 8.25th term. This 8.25th term can be written as 8th term plus 0.25 into 9th term minus 8th term, which is equal to 8th term in your ascending order of data is 65. So 65 plus 0.25 into 75 minus 65. So 75 minus 65 is 10. 10 into 0.25 is 2.5. 2.5 plus 65 gives us 67.5. After obtaining the values of Q1 and Q3, now we are able to calculate the quartile deviation and the corresponding coefficient also. So the quartile deviation is given by the formula. The quartile deviation is given by the formula Q3 minus Q1 divided by 2. Q3 minus Q1 divided by 2. On substituting the values of Q3 and Q1, Q3 is 67.5 minus Q1 is 46.5 divided by 2. 67.5 minus 46.5 gives us 21 divided by 2, which is equal to 10.5. Similarly, the corresponding relative measure, that is coefficient of quartile deviation, can be obtained by the formula Q3 minus Q1 divided by Q3 plus Q1 into 100, which is equal to Q3 minus Q1 is nothing but 21 divided by Q3 plus Q1 is nothing but 144 into 100. This value gives us 21 divided by 144. It is approximately 14.58. 14.58. So the answer is, sorry, just a minute. This is not 144. 67.5 minus 46.5 is 21. 67.5 plus 46.5 is nothing but 114, not 144, sorry. 21 divided by 114 is equal to, that is approximately 18.42. 18.42. So your answer here is option A. Similarly, we can calculate the remaining problems in the individual series. Now, how to solve the problems in quartile deviation based on the properties? The one and only property we have is quartile deviation is independent of change of origin but not of scale. So here in this problem 15, if the quartile deviation of the observations 2, if the quartile deviation of the observations 2, 5, 8, 11, 15, 19, 20. 15, 19, 20. The quartile deviation for these observations is given as 7. The quartile deviation of these observations is given as 7. Then quartile deviation of the observations 27, 30, 33, 36, 40, 44 and 45 is, here these observations are obtained by adding 25 to each and every term of 2, 5, 8, 11, 15, 19, 20 and so on. Adding a constant value, adding or subtracting a constant value to the original observations comes under the technique of change of origin. Change of origin. But quartile deviation does not affect by change of origin. Quartile deviation does not affect by change of origin. So the quartile deviation for the new observations also remains 7. Similarly, so here the answer is 7. Similarly, in this problem, the quartile deviation of 45, 52 and 65. The quartile deviation of 45, 52 and 65 is given as 10. The quartile deviation of these three observations is given as 10. Now, what is the quartile deviation of 90, 104 and 130? 90, 104 and 130. These three observations 90, 104 and 133 are obtained by multiplying each and every observation of 45, 52 and 65 with 2. So multiplying by a constant, multiplying or dividing by a constant value to the original observations, it comes under the technique of change of scale. Change of scale. Now, quartile deviation is affected due to the change of scale. Here the scale factor is 2. So that the quartile deviation is also multiplied by the same scale factor 2. Therefore, the quartile deviation for the new observations becomes 10 into 2 is nothing but 20. Next, in the equation model, if x and y are related as 3x plus 4y is equal to 20 and the quartile deviation of x is 16, then the quartile deviation of y. As we discussed in the topic of range, the equation model for quartile deviation is also like this. If y is equal to a plus bx, then quartile deviation of y is equal to mod b into quartile deviation of x. So according to this equation model, here the equation is given as 3x plus 4y is equal to 20. 3x plus 4y is equal to 20 and quartile deviation of x is given as 16. Quartile deviation of x is given as 16. Now we convert this equation into like this. 4y is equal to minus 3x plus 20 and y is equal to minus 3 by 4x plus 20 by 4 is 5. Here the scale factor is minus 3 by 4. So quartile deviation of y is nothing but modulus of minus 3 by 4 into quartile deviation of x, which is equal to 3 by 4 into quartile deviation of x is 16. So 3 by 4 into 16 gives us 12. Like that we can solve the problems based on the equation model also. But please note, if the coefficients of the variables have been changed, then our answer may also affect. Please observe carefully. Next one, how to compute this quartile deviation in case of continuous series. How to compute the quartile deviation in case of continuous series. To obtain the quartile deviation in case of continuous series also, first we need to determine the values of Q1 and Q3, as we discussed in the previous chapters. So here, to obtain the values of Q1 and Q3, first we need to verify that whether the given intervals, class intervals, are in exclusive series or not. Since here the class intervals are given as open-ended classes as well as inclusive series. So for the open-ended classes series, the best measure of dispersion is quartile deviation. For open-end series, the best measure of dispersion is quartile deviation. So first we need to convert these intervals into exclusive series. After converting these intervals into exclusive series, we'll get the boundaries like this, class boundaries like this. Below 29.5, 29.5 to 39.5, 39.5 to 49.5, 49.5 to 59.5, 59.5 to 79.5, and 79.5 and above. Then the corresponding frequencies are given as 5, 7, 18, 5, 7, 18, 32, 28, 10, 32, 28, 10. So to determine the quartile values, first we need to compute the cumulative frequencies. The cumulative frequencies are 5, 12, 30, 30 plus 32, 62, 62 plus 28, 90, 90 plus 10, 100. The last value in the cumulative frequencies is nothing but the total frequency, capital N. Now first, to compute the Q1 value, first we need to identify the Q1 class. The Q1 class based on the value of n by 4. Here the value of n by 4 is 25. So observe the cumulative frequency which is immediately greater than n by 4 value, that is 30. The class interval corresponding to this 30 is nothing but Q1 class. Q1 class. Now the formula for calculating the Q1 is Q1 is equal to L plus n by 4 minus m divided by f into c, which is equal to L is the lower class boundary of the Q1 class, that is 39.5, plus n by 4 value is 25, minus m value is preceding cumulative frequency to the Q1 class, that is 12, divided by f is the frequency of Q1 class, that is 18, into c is the length of the Q1 class, that is 10, which is equal to 39.5 plus 25 minus 12 is 13 divided by 18 into 10. So by solving this, 13 divided by 18, this can be written as 39.5 plus 7.22, that is 46.72. Q1 value is 46.72. Similarly, we can determine the Q3 value also. So to obtain the Q3 value, first we need to identify the Q3 class in this data. To identify the Q3 class is based on the value of 3n by 4. The value of 3n by 4 here is 75. So observe the cumulative frequency which is immediately greater than 75. So the cumulative frequency which is immediately greater than 75 is 90. The class interval corresponding to this 90 is known as Q3 class. Q3 class. Now the formula for Q3 is Q3 is equal to L plus 3n by 4 minus m divided by f into C, where L is the lower class boundary of the Q3 class, that is 59.5, plus 3n by 4 is 75, minus m is preceding cumulative frequency to the Q3 class, that is 62, divided by f is frequency of the Q3 class, that is 28, into C is length of the Q3 class, that is 20, which is equal to 59.5 plus 13 divided by 28 into 20. That is equal to 59.5 plus 9.29. It gives us 68.79. Now after determining these two values, we need to find out. So in the problem also, it was not mentioned the exact method what you need to find out. The value of the appropriate measure of dispersion. We need to apply the suitable measure of dispersion for the given data. The given data contains the open-end classes. So the best suitable measure of dispersion for open-end classes is quartile deviation. So here, to find out the quartile deviation, the formula for quartile deviation is just Q3 minus Q1 divided by 2, which gives us 22.07 divided by 22.06 divided by 2, that is 11.03. That is 11.03. Right. Now here the quartile deviation is not based on all the observations of the given data. Even though it is rigidly defined, quartile deviation is rigidly defined, but it based on the middle 50% of the observations only. So that quartile deviation is not based on all the observations, and quartile deviation is not at all affected by the extreme observations. Whereas since the quartile deviation depends on the quartiles, which are the positional averages, hence quartile deviation is highly affected by sampling fluctuations. Right? And quartile deviation is also not capable of further algebraic treatment because it is depending on the positional averages. No positional average is not capable of further algebraic treatment. So quartile deviation is also not capable of further algebraic treatment. Right. Now the next measure of dispersion is mean deviation. Next measure of dispersion is mean deviation. Mean deviation. This mean deviation is also known as average deviation. average deviation. So it is defined as mean deviation, MD, is defined as the arithmetic mean of absolute deviations of given set of observations from the corresponding average. Average is denoted by A here. The corresponding average is denoted by A here. Now, what is the formula for calculating mean deviation? By using this definition. This is the definition of mean deviation, arithmetic mean of absolute deviations of given set of observations from the corresponding average. So, to compute the mean deviation, the formula is here MDA. This is called as mean deviation about an average A. This notation is treated as like this: mean deviation about an average A. According to the definition, we need to first consider the deviations of given set of observations from the corresponding average. Deviations means a difference of given set of observations, which is denoted by X, and the corresponding average is denoted by A. We need to calculate the deviations, that too absolute deviations. Absolute deviations means we have to consider the modulus for those deviations. Absolute deviations are the deviations which can be computed after ignoring the signs of those deviations. To ignore the signs of those deviations, we have to consider the modulus. For this kind of absolute deviations, we need to calculate the arithmetic mean. That means sum of observations divided by number of observations. So the formula becomes 1 by n into summation of modulus of x minus a, where a is either arithmetic mean x bar or median m or mode z. This formula is in case of individual series. If my average is x bar, mean, arithmetic mean, then this MDA can be written as MDX bar, that is mean deviation about arithmetic mean. The formula for this is 1 by n into summation modulus of x minus x bar. Similarly, if my average is median, then MDM, that is mean deviation about median. The formula for this is 1 by n into summation of modulus of x minus m. And if my average is mode, then MDZ, that is mean deviation about mode, which is equal to 1 by n into summation of modulus of x minus z. And the corresponding relative measures of this, mean deviation about an average A is nothing but coefficient of mean deviation about an average A can be given by the formula mean deviation about an average A divided by the average A into 100. Mean deviation about an average A divided by average A into 100. Now, in practical point of view, in most of the cases, we do not use the average as mode. We do not use the average as mode in the calculation of mean deviation, because mode is not a good representative of the series. So in most of the practical situations, we may compute the mean deviation about arithmetic mean or the mean deviation about the median only. Right. So the best advantage of mean deviation over the previous two measures like range and quartile deviation is mean deviation is based on all the observations. Whereas range and quartile deviation are not based on all the given set of observations. So mean deviation is based on all the observations, and mean deviation is rigidly defined. Because we are expressing the definition into the mathematical formula. So mean deviation is rigidly defined. And since we are using the arithmetic mean here, mean deviation is itself the arithmetic mean of the absolute deviations of given set of observations. So since we are using the arithmetic mean here, mean deviation is least affected by sampling fluctuations, whereas mean deviation is highly affected by extreme observations, and mean deviation is not at all capable of further algebraic treatment, because to ignore the negative deviations, considering the modulus sign is mathematically illogical. So mean deviation is not at all capable of further algebraic treatment. Right. Now, how to solve the problems on mean deviation here? See, the mean deviation, see the 21st problem. If a school has 14 teachers, their heights are like this, then average deviation of data is. Average deviation means mean deviation. But in the problem, it was not mentioned that which mean deviation you have to calculate. Whether it is a mean deviation about mean, or mean deviation about median, or mean deviation about mode. So since that point is not mentioned, hence by defaultly we have to compute the mean deviation about the mean only. So here for this data, we need to calculate the mean deviation about the mean. Right. Similarly, see the 20th problem also. Mean deviation of the numbers. What are the numbers here? The numbers of the observations are 3, 10, 6, 11, 14, 6, 11, 14, 17, 9, 8, 12. 17, 9, 8, 12. So for this data, we need to calculate the mean deviation about mean. So to obtain the mean deviation about mean, first we have to calculate the mean for these data. To obtain the mean for this data, first obtain the total of the x values. 13, 19, 30, 44, 61, 70 plus 20, 90. Now, x bar is nothing but summation x by n, which is equal to 90 divided by number of observations are 9. So, x bar here is 10. To obtain the mean deviation about mean, first we need to compute modulus of x minus x bar. We need to compute the modulus of x minus x bar. So 3 minus 10 gives us minus 7. Because of the modulus, negative sign is ignored, so the 7. So 10 minus 10 gives us 0. 6 minus 10, modulus of 6 minus 10 gives us 4. Modulus of 11 minus 10 gives us 1. Modulus of 14 minus 10 gives us 4. Modulus of 17 minus 10 gives us 7. Modulus of 9 minus 10 gives us 1. Modulus of 8 minus 10 gives us 2. Modulus of 12 minus 10 gives us 2. Now the total of these modulus of x minus x bar values is 7 plus 4, 11, 12, 12 plus 4, 16 plus 7, 23 plus 1, 24 plus 4, 28. So the mean deviation about mean, which is denoted by MDX bar, is given by the formula 1 by n into summation of modulus of x minus x bar, which is equal to 28 divided by number of observations 9, which gives us 28 divided by 9 gives us 3.11. So here in the problem, we need to correct to one decimal place. So the answer is 3.1 only. The answer is 3.1 only. In the same manner, if it is not mentioned to calculate the mean deviation about mean or mean deviation about median or mean deviation about mode in the given problem, by defaultly we have to calculate the mean deviation about mean in the same manner. Now, next one. See the properties of mean deviation. All the absolute measures of dispersion are not affected by the change of origin but affected by the change of scale. So mean deviation is also not affected by the change of origin but it is affected by the change of scale, right? So like that, here the mean deviation of 1, 2, 3, 4, 5 is 1.2. Then the mean deviation of 6, 7, 8, 9, 10. All these values 6, 7, 8, 9, 10 can be obtained by adding 5 to the each observation of 1, 2, 3, 4, 5. Adding 5 means it is a change of origin. So mean deviation is not affected due to change of origin. So the mean deviation of the new observations is also 1.2. Similarly, if the mean deviation of the observations 1, 2, 3, 4, 5 is 1.2 and the then the mean deviation of the observations 5, 10, 15, 20, 25. These observations 5, 10, 15, 20, 25 are obtained by multiplying with 5 to the each and every observation of 1, 2, 3, 4, 5. So multiplying by a constant is the technique of the change of scale, but mean deviation is affected due to the change of scale. So here the answer is 5 into the mean deviation 1.2, that is 6. In the same manner, we have to apply the equation model also. See the problem number 27. See the problem number 27 here. So if two variables x and y are related by 2x plus 3y 2x plus 3y minus 7 is equal to 0. Minus 7 is equal to 0. And also given that the mean and mean deviation about mean of x are 1 and 0.3 respectively. That means mean of x is denoted by x bar is given as 1 and mean deviation of x is denoted by md of x, which is equal to 0.3. Now we need to find out what we need to find out. We need to find out the coefficient of mean deviation of y about the mean. We need to find out the coefficient of mean deviation of y about mean. So the formula for coefficient of mean deviation is mean deviation of y about mean divided by the mean of y, that is denoted by y bar, into 100. So first we have to calculate the y bar as well as the mean deviation of y. So to calculate the y bar, this equation 2x plus 3y minus 7 can be written as 3y is equal to minus 2x plus 7 and y is equal to minus 2 by 3x plus 7 by 3. Minus 2 by 3x plus 7 by 3. Now to calculate the y bar from the equation model of the arithmetic mean, y bar is nothing but minus 2 by 3 x bar plus 7 by 3. But our x bar value here is 1. So on substituting 1 over here, then we will get minus 2 by 3 plus 7 by 3 gives us 5 by 3. And the equation model, according to the equation model of the mean deviation, from the equation of y is equal to minus 2 by 3x plus 7 by 3, mean deviation of y can be obtained by modulus of minus 2 by 3, because minus 2 by 3 is the scale factor here. Modulus of minus 2 by 3 into mean deviation of x, which is equal to 2 by 3 into mean deviation of x is given as 0.3. So 2 by 3 into 0.3 gives us 0.2. On substituting this mean deviation of y and y bar in the formula of coefficient of mean deviation of y, then we will get coefficient of mean deviation of y is equal to 0.2 divided by 5 by 3 into 100, which is equal to 0.6 by 5 into 100, which is nothing but 12. Like that, we can solve the problems very easily in equation model of mean deviation. Now there is a specific formula, a particular formula for mean deviation is that mean deviation if all the observations are in AP, arithmetic progression. How to compute the mean deviation if all the observations of a given data set are in arithmetic progression? The formula for calculating mean deviation if all the observations are in arithmetic progression is n square minus 1 divided by 4n into d if n is odd, and n by 4 into d if n is even, Now, see the problem number 28. We need to find out the coefficient of mean deviation about mean for first 9 natural numbers. The first 9 natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. For all these observations, we need to find out the coefficient of mean deviation about mean. That can be obtained by the formula mean deviation about mean divided by mean into 100. Now, in the given data, all these 9 observations are in arithmetic progression. Because the difference between the successive terms, any two successive terms, is equal. So, all the given observations are in arithmetic progression. If all the given observations are in arithmetic progression, then the formula for arithmetic mean is just a plus L by 2. That is, a is the first term and L is the last term. So 1 plus 9 by 2 gives us 5. Similarly, see here, number of observations are 9. That is odd. So if n is odd, the formula for calculating the mean deviation is, if all the observations are in arithmetic progression, is n square minus 1 divided by 4n into d, where d is 1 here. The common difference between any two successive terms is 1. On substituting all these values, 9 square minus 1 divided by 4 into 9 into 1. That is, 9 square is 81, 81 minus 1, 80 divided by 4 into 9 gives us 20 by 9. On substituting the values of mean deviation and x bar in the coefficient of mean deviation, we will get 20 by 9 by x bar is 5 into 100. That is equal to 5 20 is 100. That is 20 by 9 into 20 gives us 400 by 9. Like that, we can compute the mean deviation if all the observations are in arithmetic progression. Similarly, see the 30th problem. The mean deviation of the numbers 21, 22, 23 and so on 50. From 21 to 50, there are 30 numbers. Where 30 is the even number. For even number of observations, the formula for mean deviation is n by 4 into d. Here d is also equals to 1. The common difference between the successive terms is 1. So n by 4 is 30 by 4 gives us 7.5. Like that, we can compute the problems in mean deviation if all the observations are in arithmetic progression. In the same manner, we can compute the mean deviation for the discrete series or continuous series also. The formula for calculating the mean deviation in case of a discrete series or continuous series is mean deviation about an average A is equal to 1 by capital N into summation F into modulus of x minus A, where A is either mean or median or mode. This is the formula in case of both the discrete series or continuous series. So by using this formula, here we calculate the 31st problem. What is the mean deviation about the median for the following data? So to calculate the mean deviation about median, first we have to find out the median value. To find out the median value, we need to check whether the given observations or the given data are in order according to the values of x or not. Here all the values of x are in ascending order only. So we need not arrange the data again. So the given values are, the given data is x values are 3, 5, 7, 9, 11, 13, 15. 13, 15. And the corresponding frequencies are given as 289, 289, 16, 14, 7, 16, 14, 7, and 4. And 4. So to compute the median, first we have to calculate the cumulative frequencies like this. 2, 10, 19, 35, 49, 56, 60. And 60 is the capital N value. Median is nothing but capital N plus 1 by 2th term. That is 61 by 2th term, that is 30.5th term. This can be written as 30th term plus 0.5 into 31st term minus 30th term. For the given data, from the 20th term to 35th term, the value of x is 9. So 30th term is 9 plus 0.5 into 9 minus 9 gives us 9. So median value is 9. Then we need to compute the modulus of x minus m values as well as f into modulus of x minus m values. Modulus of x minus m values is 3 minus 9, 6, 5 minus 9, 4, 7 minus 9, 2, 9 minus 9, 0, 11 minus 9, 2, 13 minus 9, 4, 15 minus 9, 6. Now f into modulus of x minus m is 2 into 6, 12, 8 into 4, 32, 9 into 2, 18, 16 into 0, 0, 14 into 2, 28, 7 into 4, 28, 4 into 6, 24. And the total is 50, 62, 90, 90 plus 52, 142. And capital N is the total frequency. Total frequency is 60 here. So mean deviation about median is 1 by capital N into summation f into modulus of x minus m value. So which is equal to 142 divided by 60. 142 divided by 60 is nothing but 2.37. So the answer is 2.37. In the same manner, we can calculate the continuous series also. But the x values are nothing but the mid values of the class intervals. So with this, I'm going to stop this session. In the next session, we'd like to continue about the model standard deviation. The standard deviation is defined as the square root of the standard deviation is defined as the positive square root of squares of positive square root of arithmetic mean of squares of deviations of given set of observations from their arithmetic mean. That is the definition of standard deviation. The positive square root of arithmetic mean of squares of deviations of given set of observations from their arithmetic mean. In the notation wise, we have standard deviation is obtained by the formula SD is equal to, which is denoted by sigma, which is denoted by the Greek letter sigma, is given by the formula positive square root of arithmetic mean. Arithmetic mean means the sum of observations divided by number of observations. That is 1 by n into summation of squares of deviations of given set of observations. Deviations means the difference of given set of observations x from their arithmetic mean x bar and square deviations. So positive square root of arithmetic mean of squares of deviations of given set of observations from their arithmetic mean. This is the formula for individual series. In case of individual series, using deviations from arithmetic mean method. Deviations from arithmetic mean method. So here the standard deviation depends on all the observations of the given data, and this is the correct procedure. Squaring of the deviations is the correct procedure to ignore the negative deviations, right? And the square of the standard deviation is known as variance. The square of the standard deviation is denoted by sigma square, is nothing but variance. So that is square of standard deviation. Square of standard deviation, which is given by the formula 1 by n into summation of x minus x bar whole square. That means the arithmetic mean of squares of deviations of a given set of observations from their arithmetic mean is nothing but variance of the distribution. And here the standard deviation is also rigidly defined. Standard deviation is also rigidly defined, and standard deviation is based on the arithmetic mean. The standard deviation is based on the arithmetic mean. After obtaining the arithmetic mean of the given data, then only we can obtain the standard deviation. So standard deviation completely based on the concept of arithmetic mean. So standard deviation satisfies all the good features of the arithmetic mean also. Whatever the features satisfied the arithmetic mean is also satisfied by the standard deviation. Now, various formulae to calculate the standard deviation. Various formulae to calculate standard deviation. This formula for standard deviation can be also computed by the formula square root of summation x square by n minus summation x by n whole square. This is the formula in case of individual series using no deviations method. Using no deviations method. And the same formula, standard deviation, can also obtained by the formula that is square root of summation dx square by n minus summation dx by n whole square, where dx is equal to x minus a, where dx is equal to x minus a, and a is called assumed mean. A is called assumed mean. So this is the formula in case of individual series using deviations from assumed mean method. Using deviations from assumed mean method. All these formula can also obtain in case of either discrete series or continuous series. So the formula for standard deviation using deviations from arithmetic mean method in case of discrete series is square root of 1 by capital N into summation f into x minus x bar whole square. This is the formula in case of either discrete series or continuous series using deviations from arithmetic mean method. Using deviations from arithmetic mean method. And also, standard deviation can also be obtained by the formula square root of 1 by capital N into summation f into x square minus summation fx divided by capital N whole square. This is the formula in case of discrete series or continuous series using no deviations method. Using no deviations method. Similarly, standard deviation can also be obtained by the formula square root of 1 by capital N into summation f into dx square minus summation f into dx by capital N whole square in case of discrete series or continuous series using deviations from assumed mean method. Deviations from assumed mean method. Like this, we can obtain the standard deviation by using several methods of formulae. And also, one more important point here is the standard deviation can be obtained for any two numbers. For any two numbers, for any two numbers A and B, the standard deviation can be obtained by the formula half of range, that is the range divided by 2. This can be written as modulus of A minus B by 2, because range means maximum value minus minimum value. Among these two observations, sometimes A may be the maximum value and sometimes B may be the maximum value. So the range gives us modulus of A minus B, which is equal to divided by 2. At the same time, the standard deviation can be computed in if all the observations are in arithmetic progression. All the observations are in arithmetic progression by using the formula SD is equal to square root of n square minus 1 by 12 into D. Square root of n square minus 1 by 12 into D, where D is the common difference between the observations. where D is the common difference between observations. Similarly, the standard deviation for first n natural numbers, the standard deviation for first n natural numbers can be given by the formula square root of n square minus 1 by 12, because for the first 10 natural numbers the common difference between the observations is 1, so that the standard deviation formula is square root of n square minus 1 by 12. Similarly, the standard deviation for the first n even numbers, the first n even natural numbers is given by the formula square root of n square minus 1 by 3, which is same as the standard deviation of first n odd natural numbers also. First n odd natural numbers also. And coming to the properties of the standard deviation. The first property is if all the observations of a variable are same, that is k, then corresponding standard deviation is always equals to 0. The corresponding standard deviation is always equals to 0. Similarly, standard deviation is independent of change of origin but not of scale. That means standard deviation is not affected due to the change of origin, but it is affected due to the change of scale. And the third property is the same second property can also be written in the equation model. The equation model of the standard deviation is if y is equal to a plus bx, then standard deviation of y is equal to modulus of b into standard deviation of x. Similarly, like in arithmetic mean, we can also compute the combined standard deviation as well as the corrected standard deviation. We'll discuss about the combined standard deviation and corrected standard deviation later. First, we'll solve the problems based on the formula for individual series. Right. Now, here, first we need to find out in the first problem, we need to find out for the 33rd problem. We need to find out the variance of the data 3, 4, 5, 8. So here only the x values are given as 3, 4, 5, 8. So to obtain the variance or standard deviation for the data like this, here we are not having any information about the deviations from arithmetic mean. We are not having any information about the deviations from assumed mean. So the suitable formula for obtaining either standard deviation or variance is nothing but no deviations method. And this is the type of individual series. So we need to apply the no deviations method formula in case of individual series. According to that formula, the formula for variance is nothing but the square of the standard deviation. So the formula for variance using no deviations method is summation x square by n minus summation x by n whole square. According to this formula, first we need to calculate x square values. The values x square values are 9, 16, 25, 64. 9, 16, 25, 64. And obtain the totals for x as well as totals for x square. The total for x is 3 plus 4 7 plus 5 12 plus 8 20, and the total for x square is 9 plus 16 25 plus 25 50 plus 64 114. So here the summation x square value is 114 divided by n means the number of observations, that is 4, minus 20, summation x value is 20 divided by the number of observations 4 whole square, which is equal to 114 divided by 4. 114 divided by 4 gives us 28.5, minus 20 by 4 is 5, 5 square is 25, it gives us 3.5. Similarly, for the next problem, 34 problem, the standard deviation of 10, 16, 10, 16, 10, 16, 16, like. So in this data, we are having only the two observations, that is 10 and 16. These two observations are repeated. So we are having only two observations, two numbers here. So for any two numbers, the standard deviation can be obtained by the formula half of range. So the range of these two numbers is 6. So the formula is range divided by 2, that is 6 by 2, which gives us 3. But the same formula is not applicable for this data. In the next problem, we are having the data about 3 values, 5, 9 and 10. So we cannot apply the formula of standard deviation for any two numbers over here. Here we have to apply again no deviations method formula in case of individual series. Now see the 36th problem. The sum of squares of the values 3390, n is 30, standard deviation is 7, then find out the mean. Before proceeding to this problem, let me explain about a small derivation about this problem. Right. So the formula for standard deviation using no deviations method is equal to square root of 1 summation x square by n minus summation x by n whole square. On squaring on both sides, we'll get sigma square is equal to summation x square by n minus summation x by n is itself the formula for arithmetic mean in case of individual series. So we can write x bar square here. Now taking this minus x bar square to the left hand side, we'll get summation x square by n is equal to sigma square plus x bar square. And summation x square is equal to n into sigma square plus x bar square. Similarly, if we know the values of n, x bar and sigma, if we know the values of n, x bar and sigma, then we can obtain summation x value by the formula n into x bar, and also summation x square value from the formula n into sigma square plus x bar square. Now see the problem. The sum of squares of the values is 3390. That is, sum of squares of the values means summation x square value is given as 3390. And number of observations n value is given as 30. And standard deviation value is given as 7. Standard deviation value is given as 7. Then we need to find out the mean value, that is x bar value. So the formula related to all these four factors, that is summation x square, n, sigma and x bar, is this. Summation x square is equal to n into sigma square plus x bar square. So applying the formula summation x square is equal to n into sigma square plus x bar square, which implies summation x square value is 3390 is equal to n is given as 30 into sigma square is nothing but 49 plus x bar square. From this, 49 plus x bar square is equal to 3390 divided by 30 gives us 113. And that implies x bar square is equal to 113 minus 49. 113 minus 49 gives us 64. That implies x bar is equal to 8. X bar is equal to 8. Like that, we can solve the problems like this. In the same manner, we can solve the 37th problem also. 37 and 38 also. Now, see the 39th problem. Sum of 20 observations is 420 and sum of squares of deviations taken from mean is 180. Then find the coefficient of deviations. Given that the sum of observations, sum of 20 observations, that means number of observations is 20, and sum of these 20 observations is given as 420, and also sum of squares of deviations of the observations from their mean is given as 180. Then we need to find out the coefficient of deviation. The formula for coefficient of deviation is x bar divided by sigma. X bar divided by sigma. From the given data, x bar can be obtained by the formula 1 by n into summation x, which is equal to 420 divided by 20, which is equal to 21. And also the formula sigma can be obtained by the formula square root of 1 by n into summation of x minus x bar whole square, because we know the value of the summation of x minus x bar whole square here. So that is square root of 180 divided by 20, which is equal to square root of 9, that is 3. On substituting these two values, that is 21 divided by 3, that is equal to 7. So the coefficient of deviation is 7. Next, observe the properties of standard deviation. For the properties of standard deviation, The standard deviation for a set of numbers 1, 4, 5, 7, 8 is 2.45 nearly. If 10 is added to each number, the new standard deviation is. If 10 is added to each number means it is the change of origin property. But standard deviation does not affect due to the change of origin. So the new standard deviation also remains the same as 2.45. Now, see the 44th problem. Next, see the 44th problem. First, we need to compute. In this problem, first we need to compute the standard deviation of 95862. Let me calculate this standard deviation of 95862. So here x values are given as 95862. For this data, we need to apply the formula for using no deviations method in case of individual series. That is summation x square by n square root of summation x square by n minus summation x by n whole square. According to this formula, first calculate x square. That is 9 square is 81, 5 square 25, 64, 36, 4. And obtain the totals for both x and x square. The total of x is 14, 22, 28, 30. And the total of x square is 100, 29 plus 81, 110. 110 plus 100 is 210. Now, here this is square root of, on substituting these totals, you will get 210 divided by number of observations 5 minus 30 divided by number of observations 5 whole square. That is equal to square root of 42 minus 36. That is square root of 6. Approximately it is 2.45. Approximately 2.45. Now, the next question, the continued question is, and without any calculations, without any more computations, obtain the standard deviation of all these three samples. Without any more computations, obtain the standard deviation of all these three samples, sample 1, sample 2, sample 3. Let me see. Here the original observations given in the data is 95862. 95862. For this data, standard deviation was nothing but 2.45. Just now we calculated. And in sample 1, the observations are like this: minus 1, minus 5, minus 2, minus 4, and minus 8. In the first sample, the observations are minus 1, minus 5, minus 2, minus 4, and minus 8. And the relation between sample 1 and x values. The values of sample 1 can be obtained by subtracting 10 from each value of x. The values in sample 1 can be obtained by subtracting 10 from each value of x. Subtracting a constant value from each and every observation is the change of origin property. Standard deviation does not affect due to change of origin property. So the standard deviation for sample 1 remains the same as 2.45. Similarly, for the sample 2, sample 2 observations are 90, 50, 80, 60, 20. The sample 2 observations are 90, 50, 80, 60, 20. So here sample 2 observations are obtained by multiplying each value of x with the 10. Multiplying each value of x with the 10. So multiplying by a constant value is the technique of change of scale. So standard deviation is affected due to change of scale. So the standard deviation for sample 2 is also equals to 10 times of the original standard deviation, that is 2.45 into 10, which is equal to 24.5. Similarly, for sample 3, the observations are 23, 15, 21, 17 and 9. 23, 15, 21, 17 and 9. For this, sample 3 observations can be obtained by multiplying each value of x with the 2 and also added with 5. That is 2x plus 5. 2x plus 5. Here, this is the combination of both change of origin as well as scale. Multiplying with the 2 is the change of scale property and adding 5 is the change of origin property. But standard deviation is not affected due to origin. So the origin factor does not influence our standard deviation. But standard deviation is affected due to the change of scale. Here, the scale factor here is 2. The scale factor here is 2. So, the standard deviation is 2 times the original standard deviation, that is 2 into 2.45, which is nothing but 4.9. Like that, we can compute the standard deviation using properties. Next, similarly, in the standard equation model also, it is similar to the quartile deviation as well as mean deviation. I hope you can solve it very easily. So I am going to skip it. And the next one, standard deviation if all the observations are in AP. Standard deviation if all the observations are in AP. Standard deviation of first 10 natural numbers is the formula of square root of n square minus 1 by 12. In this problem number 50, the standard deviation of the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. So here there are 9 natural numbers. So substituting 9 in place of n in the formula, then we will get the answer. Similarly, here 1, 3, 5, 7, 19. These are the odd natural numbers below 20. So there are 10 odd natural numbers below 20. So n value becomes here 10. So the formula for standard deviation for n odd natural numbers is square root of n square minus 1 by 3. By substituting this n value as 10 in this formula, we will get the answer. That is square root of 33. In the same manner, we can obtain we can solve the problem 52 also. Now coming to this concept of corrected standard deviation. The formula for corrected standard deviation is sigma c. Corrected standard deviation formula sigma c is equal to square root of sigma square plus x bar square plus c square minus w square by n minus x bar c square. Square root of sigma square plus x bar square plus c square minus w square by n minus xc bar square, where sigma square is the variance of the wrong observations, x bar square is the mean of the wrong observations, c square is the c value is the correct observation, and w is the wrong observation, and x bar c is the corrected arithmetic mean. X bar c is corrected arithmetic mean. How to use this formula in case of a problem? We'll see that. A student computes the arithmetic mean and standard deviation for a set of 100 observations as 50 and 5 respectively. Here n value is given as 100. Here n value is given as 100 and arithmetic mean is given as 50. That is x bar is given as 50 and standard deviation is given as 5. Standard deviation is given as 5. Later, she discovers that she had made a mistake in taking one observation as 60 instead of 50. 60 instead of 50. So here the correct observation is 50 and the wrong observation is 60. Correct observation is 50 and the wrong observation is 60. Now we need to calculate the correct mean and correct standard deviation in two cases. In the first case, the wrong observation is left out. In the first case, the wrong observation is left out. So here, if we know the values of n, x bar and sigma, if we know the values of n, x bar and sigma, we can obtain the sum of the observations, summation x, by using the formula n into x bar, which is equal to 50 into 100, that is 5000. Similarly, we can obtain the sum of squares of the observations, that is summation x square, by using the formula n into sigma square plus x bar square, which is 100 into sigma square is 25 plus x bar square is 2500, which gives us 252500. Now, in the first case, the wrong observation should be left out. That means we have to delete the wrong observation. We need not replace the correct observation. We need not replace the correct observation. We should delete the wrong observation. So, by deleting the wrong observation, if the wrong observation is left out, if the wrong observation is left out, then correct summation x value can be obtained by subtracting the wrong observation from the summation x value we obtained earlier. That is 5000 minus 60. That is 4940. 4940. Similarly, we can obtain the correct summation x square also. We can obtain the correct summation x square also. That is by subtracting the square of the wrong observation from summation x square value which we obtained earlier. That is 252500 minus 3600. The square of the wrong observation is 3600, which gives us 248900. 248900. Now, after deleting the wrong observation, our number of observations remains 99. After deleting the wrong observation, the number of observations remains 99. Now, the correct mean in this case, correct x bar in this case is correct summation x, that is 4940, divided by number of observations 99. 4940 divided by 99, which gives us 49.89. 49.89. Similarly, correct sigma in this case is equal to square root of correct standard deviation. In this case is square root of correct summation x square, that is 248900, divided by 99 minus x bar is 49.89 whole square. So by simplifying this, we will get approximately 5.01. Approximately 5.01. Now the second case is the wrong observation is replaced by the correct observation. The wrong observation is replaced by correct observation. That means second case, if wrong observation is replaced by correct observation, then we can use the direct formulas over here. That is correct arithmetic mean. Correct mean is x bar c, which can be obtained by the formula x bar plus c minus w by n, which is equal to x bar is 50 plus c value is 50 minus w value is 60 divided by n is 100. That is 50 minus 0.01, 50 minus 0.1, which is equal to 49.9. And correct sigma is given by the formula square root of sigma square plus x bar square plus c square minus w square divided by n minus x bar c square. That is sigma square, square root of sigma square. Sigma is given as 5 in the problem. That is sigma square is 25 plus x bar is given as 50 in the problem. That is x bar square is 2500 plus c square is also 2500 minus w square is also 3600 divided by n is 100 minus x bar c is 49.9 whole square. By simplifying this calculation part, we will get approximately 4.89. Approximately 4.89. Like this, we can use the corrected standard deviation here. Now, like that, similarly, we can obtain the combined standard deviation also. The formula for combined standard deviation is in 4 cases. Because it is too lengthy to solve, so I am going to skip this problem. Now, the coefficient of variation and its applications. The corresponding relative measure. Till now, we were discussed about the absolute measure of standard deviation only. The corresponding relative measure of standard deviation is either coefficient of standard deviation or coefficient of variation. We can use any of these two, coefficient of standard deviation or coefficient of variation. Coefficient of standard deviation is given by the formula sigma by x bar, and coefficient of variation is given by the formula sigma by x bar into 100. Sigma by x bar into 100. So the coefficient of variation itself includes the coefficient of standard deviation. So it is better to consider coefficient of variation as the relative measure of standard deviation. So this coefficient of variation is particularly useful to compare the consistency between two or more distributions. A distribution which is having less coefficient of variation should have more consistency. A distribution which is having more coefficient of variation should have less consistency, right? So this coefficient of variation is particularly useful for comparing the consistency between two or more distributions. Now, coming to the problems, see the 58th problem. The sum of squares of deviations from mean of 10 observations is 250 and mean of the data is 10. Then find the coefficient of variation. The sum of squares of deviations from mean means summation of x minus x bar whole square. Summation of x minus x bar whole square is given as 250 and n is given as number of observations is given as 10 and mean of the data is given as 10, that is x bar is also 10. Then find coefficient of variation. The coefficient of variation can be obtained by the formula sigma by x bar into 100. So from the given data, x bar can be obtained by the formula square root of 1 by n into summation of x minus x bar whole square, summation of x minus x bar whole square, which is equal to square root of 250 divided by 10, that is square root of 25, that is 5. On substituting sigma value and x bar value over CV, then we'll get 5 divided by 10 into 100, which is nothing but 50%. Right? Now, similarly, see the 62nd problem. Here, xi bar, there are two series are there. That is series A and series B. Series A and series B. For series A, the mean is given as 15, and for series B the mean is given as 20. For series A, sigma A square is given as 25 and sigma B square is given as 16. Now the question is, which of the two series is more consistent? Here we need to verify, we need to compare the consistency between series A and series B. So for this particular problem, we need to compute the coefficient of variation for both the series A as well as series B. The coefficient of variation for series A is given by the formula sigma A divided by xA bar into 100. So sigma A here is 5 divided by xA bar is 15 into 100, which gives us approximately 33.33%. Similarly, for series B, coefficient of variation is sigma B divided by xB bar into 100, which is equal to 4 divided by 20 into 100, which gives us 20%. So since the coefficient of variation for series B is less than the coefficient of variation for series A, hence series B is more consistent. The distribution which is having less coefficient of variation is more consistent. Like that, we can apply the coefficient of variation. And finally, we have certain relationship between QD, MD and SD. The relationship between QD, MD and SD exists in case of symmetrical distribution only. In case of symmetrical distribution or moderately asymmetrical distribution. In case of symmetrical distribution or non-normal distribution, the relationship between QD, MD and SD is 6 QD is equal to 5 MD is equal to 4 SD. 6 QD is equal to 5 MD is equal to 4 SD. If the relation between the relation is in terms of ratios is QD is to MD is to SD is always equals to 10 is to 12 is to 15. So from this ratio, we can say that quartile deviation value is always less than mean deviation value, which is always less than standard deviation value. Right? By using this relation, I hope you can easily solve these problems based on relationship between QD, MD and SD. So with this, we conclude the chapter measures of dispersion. In the next session, we'll discuss about the next chapter called correlation. Thank you. Thank you one and all. So in this session, we are going to start about the correlation. So both the topics of correlation and regression analysis can be used in case of multiple variables. That means more than one variable. Multiple variables, so that more than one variable. So that these two are the techniques of multivariate analysis. Whenever we are having more than one variable at a time, then that series is known as multivariable series. Now, first, let us discuss about this correlation. So the definition of correlation is the relationship between two variables. The relationship between two or more variables. What do you mean by the relationship between the variables? Is that relationship is a brother and sister relationship, or a father and son relationship, or brother and brother relationship? Absolutely, the relationship between two variables or more variables is not a relationship like the blood relationship. So here, the relationship between the two variables means if the change in one variable, variable 1, if there are two variables like variable 1 and variable 2, if the change in one variable, change means either increase in the values of variable 1 or decrease in the values of the variables 1. If the change in one variable affects the change in another variable, either it may be an increased change or it may be a decreased change, then those two variables are said to be correlated or associated. For example, if we take the example of price and demand, if we take the examples of price and demand, as the price of the item increases, it affects the demand. Demand of the item will decrease. As the price of item increases, the demand of the item will decrease. As the price of the item decreases, the demand of the item increases. Similarly, if we consider the variables income and expenditure, as income increases, as there is income increases, expenditure also increases. As income decreases, expenditure also decreases. So the change in one variable affects the change in the another variable, then those two variables are said to be correlated. Otherwise, those two variables are said to be uncorrelated or zero correlated. So for example, if we have the variables age and price, if age of a person increases, it does not affect the price of the item. It does not affect the price of the item. So these two variables are the example of uncorrelated variables. These two variables are the examples of uncorrelated variables. And the next concept is types of correlation. And the next concept is types of correlation. Even though there are several types of correlation, majorly we are going to discuss about the most important types of correlation. The first one is positive correlation or direct correlation. Positive correlation or direct correlation. If the change in both the variables are in same direction, then those two variables are said to be positively correlated or directly correlated. For example, income and expenditure. Income and expenditure. As the income increases, expenditure also increases. So the increased change of one variable affects the increased change of the another variable. That means both the changes of the two variables are in the same direction. Such kind of variables are known as positively or directly correlated variables. Second one, negative correlation or indirect correlation or inverse correlation. Negative correlation or indirect correlation or inverse correlation. So if the change in both the variables are in opposite directions, then those two variables are said to be negatively correlated or indirectly correlated or inversely correlated. For example, price and demand of a particular item. If the price of the item increases, then the demand of the item will decrease. Here, the increased change in one variable affects the decreased change in the another variable. That means both the variables are showing the changes in opposite directions. So such kind of variables are known as negatively or indirectly or inversely correlated variables. And the third one is uncorrelation or zero correlation. Third one is uncorrelation or zero correlation. If there is no kind of relationship between those two variables, then those two variables are said to be uncorrelated. For example, age of a person and price of an item. Age of a person and price of an item. Or shoe size and intelligence. Shoe size and intelligence. So here there is no kind of relation between these two variables, age and price, or shoe size and intelligence, etc. Such kind of variables are said to be uncorrelated or zero correlated. And the next one is linear correlation. Next type is linearly correlation. Linear correlation means if the unit change in one variable, if the unit change in one variable affects the constant change in the another variable, then those two variables are said to be linearly correlated. Linearly correlated. So, if the unit change in one variable affects the constant change in the another variable, then that is, if there are two variables x and y, if there are two variables x and y, the unit change for the unit change in one variable, there is a constant change in the another variable. That means these two variables are related as y is equal to a plus bx, which is in the form of a straight line, which is the standard form of a straight line. The word linear contains the first four letters as line. So, such variables are known as linearly correlated. Such variables are known as linearly correlated. Next, fifth one, non-linear correlation. Fifth one is non-linear correlation. For a unit change in one variable, there is a different rates of change in the another variable, then those two variables are said to be non-linearly correlated. These are the most important types of correlation we have to know. Next one, the methods or measures of correlation. Methods or measures of correlation. So how to determine the relationship between two variables mathematically? How to determine the relationship between two variables or two more variables mathematically? So there are four methods to obtain the relationship between two or more variables. The first one is scatter diagram method. The first one is scatter diagram method. Second one is Carl Pearson's correlation coefficient. Carl Pearson's correlation coefficient. Third one is rank correlation coefficient. Rank correlation coefficient. And fourth one is coefficient of concurrent deviations. Coefficient of concurrent deviations. These are the four methods to determine the relationship between two variables mathematically. For the sake of convenience, first we will discuss about the coefficient of concurrent deviations, then rank correlation coefficient, then Carl Pearson's correlation coefficient, and finally scatter diagram method. Right. So first we'll discuss about coefficient of concurrent deviations method. Coefficient of concurrent deviations method, or simply we can call it as concurrent deviations method. According to this method, when to use this method? When to use this concurrent deviations method to obtain the relationship between two variables? So this method is the quickest method to compute the correlation coefficient. This is the quickest method to compute the correlation coefficient. And this method is used to study the relationship between two variables which are having short-term fluctuations. This method is used to study the relationship between two variables having short-term fluctuations or short-term oscillations. What do you mean by short-term fluctuations? Short-term fluctuations means the variations in the data. Short-term variations in the data is nothing but the variations which occurs at a time period of less than a year is known as short-term fluctuation. Like the sales at the departmental stores. The sales at the departmental stores will increase at the time of festivals rather than the normal times. The sales at the jewelry shops will increase at the season of the marriages rather than the normal seasons. So the sales of umbrellas or raincoats will increase at the time of rainy season rather than the other seasons. So all these incidents will happen at a time period of less than a year. So such kind of variations are known as short-term fluctuations. So this is the method to study the relationship between the two variables having short-term fluctuations. And also, when we are not serious about this method has to be considered when we are not serious about the magnitude of the variables. When we are not serious about the magnitude of the variables. Under these situations, we have to use this method to find the relationship between two variables. So the formula which is used to find the relationship between two variables under this method is R is equal to RC, concurrent deviations method, is equal to plus or minus square root of 2c minus n divided by, plus or minus square root of plus or minus of 2c minus n divided by n. 2c minus n divided by n. Here, where c is number of concurrent deviations. Number of concurrent deviations. And n is number of observations or the number of pairs of observations minus 1. N is the number of pairs of observations minus 1 or total number of deviations or total number of deviations. Now the question is, immediate question you have in your mind is, sir, when to use plus and when to use minus in the formula. So whether we need to use the plus or minus depends on the value of 2c minus n. The usage of plus or minus in the formula depends on the values of 2c minus n. If 2c minus n is greater than 0, when 2c minus n is greater than 0, then we have to use plus sign both inside and outside the radical sign. The square root symbol is known as the radical sign. So if 2c minus n is greater than 0, then we have to use plus sign both inside and outside the radical sign. If 2c minus n is less than 0, then we have to use minus sign. Then we have to use minus sign both inside and outside the radical sign. Inside and outside the radical sign. So the advantages of this method is it is the quickest method to find out the relationship between two variables, and it gives us the rough idea about the relationship between two variables. It does not give the exact idea because it is not based on the magnitudes of the original variables. It is based on just the deviations among the variables, the signs of the deviations among the variable values. Right. So now how to solve the problems under this method. We'll see how to solve the problems under this method. See here, the first one, compute RC, sorry, see the second problem. See the second problem. What is the coefficient of concurrent deviations? What is the coefficient of concurrent deviations for the following data? So let us denote the supply with X and demand with Y. Let us denote supply with X and demand with Y. So first let me note these values in my OneNote. So X values here are given as 68, 43, 38, 68, 43, 38, 78, 66, 83, 78, 66, 83, 38, 23, 83, 38, 23, 83, 63, 53, 63, 53. Similarly, Y values are given as 65, 60, 55, 65, 60, 55, 61, 35, 75, 61, 35, 75, 45, 40, 85, 45, 40, 85, 80 and 85, 80 and 85. Now, how to compute correlation coefficient under concurrent deviations method for this problem? Here, first we have to compute the deviations among the X values. The deviations among the X values which are denoted by Cx. Which are denoted by Cx. Just we have to note the sign of the deviations only. Sign of the deviations only. To obtain the deviations, first leave the first value. Leave the first value, and from the second value onwards, if the second value is greater than the first value, previous value, if the second value is greater than the previous value, then we have to put positive sign. If the second value is less than the previous value, we have to put negative sign. If the second value is same as the previous value, then we have to put equal to sign. So here the second value is less than the previous value, so we have to put negative sign here. Similarly, third value is less than the previous value, so negative sign again. Next value is more than the previous value, so we have to put positive. Similarly, negative, positive, negative, negative, positive, negative, negative. Similarly for y values also. Similarly for y values also. Leave the first value. Second value is less than the previous value, so put negative sign. Third value is less than the previous value, so put negative sign. Next positive sign. Next negative sign. Positive sign. Negative sign. Negative sign. Positive sign. Negative sign. And positive sign. Now, from this, we need to determine the number of concurrent deviations. The deviations of X series and Y series are said to be concurrent if both the deviations shows the same sign. Both the deviation shows same sign. So here all these values are showing the same sign. All these deviations are showing the same sign. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 deviations of both X series and Y series are showing the same sign. So the number of concurrent deviations here is 9. And N is number of pairs of observations minus 1. So totally we are having 10 observations. So totally we are having 11 observations. 3, 3, 6, 3, 9, 11 observations. So N is number of pairs of observations minus 1, which is equal to 10, which is same as total number of deviations we have. Except the first observation, we are having the deviations for all the remaining observations. So the total number of deviations is also equals to 10. Now obtain the value of 2c minus n. Now obtain the value of 2c minus n, which is equal to 2 into 9 minus 10, that is 8. 2 into 9 minus 10, which is equal to 8, that is a positive sign. If 2c minus n value is greater than 0, then our formula becomes RC is equal to plus square root of plus of 2c minus n by n. So here plus square root of 2c minus n is 8 divided by n is 10. So square root of 8 by 10. That is square root of 8 by 10 gives us square root of 8 by 10 gives us approximately 0.89. Approximately 0.89. Like that, we can solve the problems based on concurrent deviations method. So your answer is option C, 0.89. Like that, we can solve the problems in concurrent deviations method very easily. Next, the second method is Spearman's rank correlation method. The second method is Spearman's rank correlation coefficient. Correlation coefficient. So when to use the Spearman's rank correlation coefficient? As the name of the method suggests, it is the rank correlation coefficient. Ranking can be given to the observations in order of merit or excellency. So here we need to determine the relationship between two or more variables in order of merit or excellency. Right. So this method is used to find out the relationship between two or more variables in order of merit or excellency. Merit or excellency. And this method is particularly useful. This method is particularly useful to obtain the relationship between the qualitative phenomenon or the qualitative characteristics, qualitative data. And also, this method is used to determine the level of agreement between two judges for assessing a qualitative characteristic. So whenever there is some competition of performing about the qualitative characteristics like singing, dancing, etc. So this is the method to obtain the level of understanding between the two judges for assessing that particular characteristic, qualitative characteristic. So under this method, the formula for calculating rank correlation coefficient is R is equal to 1 minus 6 into summation d square divided by n into n square minus 1. This formula have to be applied when the ranks are not repeated. When the ranks are not repeated. Right? And R is equal to 1 minus 6 into summation d square plus summation m into m square minus 1 divided by 12 by n into n square minus 1. This formula has to be applied when the ranks are repeated. That means the tied ranks case. When the ranks are repeated. In both the formulae, the D is nothing but the difference between the ranks of two variables. That means the difference between the ranks of X series as well as the ranks of Y series. That is Rx minus Ry. And also note that in this method, the sum of all these deviation values should always be equal to 0. The sum of all these deviations between the ranks of X and Y values is always equals to 0. And M is number of times that particular rank repeated. Number of times rank repeat is denoted by M. And N is number of observations. And N is the number of observations. My dear friends, do not confuse the notation of N with rank correlation coefficient and concurrent deviations method. In concurrent deviations method, only n is the number of observations minus 1. So for all the remaining methods or techniques, n is the number of observations. Please don't confuse, my dear friends. Now, here, if the rank correlation coefficient value should always lies in between -1 to +1. the rank correlation coefficient value should always lies in between -1 to +1. Not only the rank correlation coefficient, any kind of correlation coefficient value is always less than or equal to -1, is always in between -1 to +1. If R value is equal to +1, if R value is equal to +1, there is a perfect relation, perfect positive relation between those two variables. Here, if R is equal to +1, that means there is a perfect level of agreement between two judges. Perfect level of agreement between two judges. So, R is equal to +1 will occur. R is equal to +1 will occur when the rank of X is same as rank of Y only. When rank of X is same as rank of Y only. And R is equal to -1 means there is a perfect level of disagreement between the two judges. This will happen when Rx plus Ry should be equal to n plus 1. Rx plus Ry should be equal to n plus 1. Now, how to solve the problems based on the Spearman's rank correlation coefficient? See the fourth problem. See the fourth problem. If the sum of squares of differences of ranks by two judges A and B of 8 students is 21, then what is the value of rank correlation coefficient? If the sum of squares of differences of ranks given by two judges A and B of 8 students is 21, that means here the number of students is given as 8. The number of students is given as 8, and the sum of squares of differences in ranks, that is summation d square value, is given as 21. Then we have to calculate the rank correlation coefficient R. That is R is equal to 1 minus 6 into summation d square by n into n square minus 1. That is equal to 1 minus 6 into 21 divided by 8 into 63, because 8 square is 64, 64 minus 1 is 63. So 21 3 is 63, 3 2 is 6, 2 4 is 8, that is equal to 1 minus 1 by 4, which is 3 by 4, that is 0.75. It is 0.75. So the answer is 0.75 here. So in this session, we'll continue with the Spearman's rank correlation coefficient and try to complete the next rest of the chapter in this class. So in the previous session, we were stopped at problem number 4 in Spearman's rank correlation coefficient. Now, next, we will see about problem number 7. We'll see about the problem number 7. Compute coefficient of rank correlation between economic marks and statistics marks as given below. Let us denote this economics marks with X and statistics marks with Y. We need to compute the correlation coefficient, rank correlation coefficient for this data. So first let me write this data. Here X values are given as, that means X values means economics marks are given as 80, 56, 50, 80, 56, 50 and 48, 50, 62, 60. 48, 50, 62 60. Similarly, y values are given as, that is, statistics marks are given as 90, 75, 75, 90, 75, 75, 65, 65, and then 50 and 65. 50 and 65. So to compute the rank correlation coefficient, first we need to determine the ranks of X series as well as the ranks of Y series. The ranks of X series are denoted by Rx and the ranks of Y series are denoted by Ry. Now, how to determine the ranks for the given data? Usually, first highest mark or highest value will be treated as the first rank. So, in X series, the highest value is, highest mark in economics is 80. So, that mark will be awarded with first rank. Next highest is 62. And there is no repetition of 62 in the X series. So, we have to award second rank to 62. And the next highest is 60. So, there is no repetition of 60 in X series. So, we have to award the third rank to 60. In the same manner, the next highest is 56. There is no repetition of 56 over here. So, the rank is 4. Next highest is 50, but 50 is repeated for 2 times. 50 is repeated for 2 times. So, if any rank, any value is repeated for more than 1 time, then it is called a tied ranks case. In that case, we have to award the rank like, so after fourth rank, value is repeated 2 times. So, take the 2 consecutive ranks after 4. The 2 consecutive ranks after 4 are 5 and 6. Then award the arithmetic mean of this 5 and 6 to both the values. Award the arithmetic mean of 5 and 6 to both the values. Then the rank will be 5.5 to both 50s. And the next highest is 48. So, 5th and 6th ranks are over. Then we have to assign 7th rank to 48. In the same manner, Ry also. Highest rank, highest mark in Y series is 90. There is no repetition of 90 in Y series. So, assign first rank to 90. And the next highest is 70, but 70 is repeated for 2 times. 70 is repeated for 2 times. 75 is repeated for 2 times. So, assign the arithmetic mean of 2 consecutive ranks after the first rank. After the first rank, the 2 consecutive ranks are 2 and 3. Assign the arithmetic mean of 2 and 3 over here. Then the rank is 2.5 and 2.5. Next highest is 65. 65 is also repeated for 2 times. 65 is repeated for 3 times. 65 is repeated for 3 times. So, take the ranks, 3 consecutive ranks, because 65 is repeated 3 times. So, take the 3 consecutive ranks after the third rank. So, after the third rank, 3 consecutive ranks are 4, 5 and 6. Assign the arithmetic mean of these 3 ranks to 65. So, the arithmetic mean of 4, 5 and 6 gives us 5 only. So, assign 5 to all these 65s, that is 555. And the last value is 50, which will be awarded 7th rank. After determining the ranks, now we need to calculate the deviations between ranks of X and ranks of Y. Deviations between ranks of X and ranks of Y. So 1 minus 1 gives us 0, 4 minus 2.5 gives us 1.5, 5.5 minus 2.5 gives us 3, 7 minus 5, 2, 5.5 minus 5, 0.5, 2 minus 7 minus 5, 3 minus 5 minus 2. Then d square, obtain the d square values also. 0, 1.5 whole square is 2.25, 3 square 9, 2 square 4, 0.5 whole square is 0.25, 25 and 4. And obtain the total of d square values. That gives us summation d square value. Summation d square value. So 2.25 plus 0.25 is 2.5, 11.5, 15.5, 40.5, 44.5. Summation d square value is 44.5. Now the formula for rank correlation coefficient in case of repeated ranks is given by R is equal to 1 minus 6 into summation d square plus summation m into m square minus 1 divided by 12 by n into n square minus 1. N into n square minus 1. Then which is equal to 1 minus 6 into summation d square is 44.5 plus m is number of times that particular rank repeated. M is number of times that particular rank repeated. So here in X series, 5.5 is repeated for 2 times. 5.5 is repeated for 2 times. So m value for 5.5 X series will be 2 into 2 square minus 1 by 12, because m is the number of times that particular value repeated. Plus there are no other repetitions in X series. Then check in Y series. In Y series, 2.5 is repeated for 2 times. So again 2 into 2 square minus 1 by 12 plus, and in Y series 5 is also repeated for 3 times. 5 is also repeated for 3 times. So 3 into 3 square minus 1 by 12 divided by n. N means the number of observations. That is, totally we are having 7 observations here. So n is 7 into 7 square minus 1, which is equal to 1 minus 6 into 44.5 plus 2 square minus 1 is 3. 3 into 2, 6. 6 by 12, 1 by 2 plus 1 by 2 plus 3 square is 9. 9 minus 1, 8. 8 into 3, 24. 24 by 12 is 2 by 7 into 49 minus 1, 48. That is 6 8s are 48. Now which is equal to 1 minus 44.5 plus 1, 45.5 plus 2, 47.5 divided by 7 8s are 56. This value gives us This value gives us 1 minus 0.848, which is equal to 0.152. 0.152, which is option A. Like that, we have to assign the ranks for in case of tied ranks. Right? Next, in the same manner, we can solve the remaining problems in the rank correlation coefficient method. Now, there is one more different model in rank correlation coefficient is, say this problem number 10. Problem number 10. While computing rank correlation coefficient between profit and investment, here the two variables are profit and investment for the last 6 years of a company. Last 6 years of a company. The difference in rank for a year was taken 3 instead of 4. Then what is the rectified rank correlation coefficient if it is known that the original value of the rank correlation coefficient was 0.4. So in this data, in this problem, we have been given n value, number of observations value as 6, because there are last 6 years of a company. So n value is 6, and the two variables are x and y are given as profit and investment. Profit and investment. For these two variables, the rank correlation coefficient was given as 0.4. That is, R value is given as 0.4, and also given that the difference in rank per a year was taken 3 instead of 4. Difference in rank is denoted by D. The difference in ranks are denoted by D. So D value, one of the D value was taken as 3 instead of 4. Then the correct value of D is 4 and the wrong value of D is 3. In this case, we need to calculate the corrected correlation coefficient, correct rank correlation coefficient. Now, from the given data, the formula for rank correlation coefficient is R is equal to 1 minus 6 into summation D square by n into n square minus 1, which is equal to 1 minus 6 into summation D square divided by number of observations are given as R value is given as 0.4, 1 minus 6 into summation D square, and n value is given as 6. So 6 into 6 square minus 1 is 35. So 6 will get cancelled here. That implies summation D square by 35 gives us 1 minus 0.4, which is equal to 0.6. And summation D square gives us 0.6 into 35, which is equal to 21. 0.6 into 35 gives us 21. Now, there is one value of D was taken wrongly as 3 instead of 4. So, for that, first we need to calculate the correct summation D square. So this summation D square was obtained with the help of the wrong observation of D. So first we need to correct it. To correct the summation D square value, we need to subtract the square of the wrong observation and we need to add the square of the correct observation to the total we obtained here. That is 21 minus the square of the wrong observation means 3 square plus the square of the correct observation is 4 square. That is 21 minus 9, 12, 12 plus 16, 28. Now obtain the correct rank correlation coefficient by using this corrected value of summation d square. That is 1 minus 6 into summation d square by n into n square minus 1, which is equal to 1 minus 6 into the corrected summation d square value over here is 28 divided by 6 into 35. So 6 will get cancelled, 7 fours and 7 fives. So 1 minus 4 by 5 gives us 1 by 5, which is equal to 0.2. So the answer is 0.2 over here. Like that, we can solve the problems under the method of corrected rank correlation coefficient. Right. Next, the third method is Carl Pearson's correlation coefficient. Before discussing about the Carl Pearson's correlation coefficient, we need to have an idea about covariance. We need to have an idea about covariance. Till the previous chapter, that is measures of dispersion, we studied about only one variable at a time. So we studied about the characteristics of one variable at a time, like the arithmetic mean, median, mode, geometric mean, harmonic mean, as well as in measures of dispersion, range, quartile deviation, mean deviation, standard deviation. All these characteristics were studied for a one variable at a time. But the concept of correlation as well as regression are used in case of multiple variables. In case of multiple variables, that is two or more variables. So for that, to study about the variation, between two variables at a time, we need to consider the covariance. So the covariance is defined as the joint variance between two variables. Joint variance between two variables. So it is denoted by COV of x comma y. It is denoted by COV of x comma y, which is given by the formula 1 by n into summation of x minus x bar into y minus y bar, which is given by the formula 1 by n into summation x minus x bar into y minus y bar. So this formula is known as deviations from arithmetic mean method. This is the formula of covariance using deviations from arithmetic mean method. An alternative formula for this is covariance COV of x comma y is also obtained by the formula 1 by n into summation xy minus x bar into y bar, or 1 by n into summation xy minus of summation x by n into summation y by n. This is known as x bar is nothing but summation x by n, y bar is nothing but summation y by n. This formula is nothing but the covariance formula using no deviations method. no deviations method. So covariance is the characteristic of two variables at a time. It is used to study about the joint variation, the common variation between two variables at a time. Right? Next. Now, the third method of finding correlation is Carl Pearson's correlation coefficient. Carl Pearson's correlation coefficient. It is also known as product moment correlation coefficient. It is also known as product moment correlation coefficient. Right? This method is the only method. This method is the only method which uses the original magnitudes of the variables to find the degree of relationship between two variables. Right? So, and this method is particularly useful to study or to determine the degree of relation between two variables which are linearly related only. So this is the method to determine the degree of relationship between the linearly related variables only. If the two variables are non-linearly related, then this Carl Pearson's correlation coefficient is not at all suitable to determine the degree of relationship between them. So this is the method to determine the degree of relationship between two linearly related variables only. And this is the only method which uses the original magnitudes of the variables. So this is an ideal measure of correlation. And it is given by the formula. It is defined as the ratio between covariance of x comma y, to the product of their standard deviations. Covariance of x comma y divided by sigma x into sigma y, where covariance of x comma y is the joint variance between x and y. Sigma x is the standard deviation of x and sigma y is the standard deviation of y. Now, there are certain mathematical properties. For this Carl Pearson's correlation coefficient. Those properties are, first and foremost property is R value should always lies in between -1 to +1. The Carl Pearson's correlation coefficient value, not only the Carl Pearson's correlation coefficient value, any correlation coefficient value like Spearman's rank correlation coefficient or the concurrent deviations method correlation coefficient should always lies in between -1 and +1. And second one, R uses the value of R. The value of R tells us about both direction of relationship and strength of the relationship. Strength of the relationship between two variables. The value of R tells us about both the direction and strength of the relationship. Suppose, for example, if R value is equal to some plus 0.95, if R value is equal to plus 0.95, in this value we are having two parts. One is called sine part, and second one is called magnitude part. The sine part indicates the direction of the relationship. Sine part indicates the direction of the relationship. If the sign is plus, then it is a positive direction or direct direction. If the sign is minus, then there will be a negative relation between those two variables. That means inverse relation or indirect relation. So sine part tells us about the direction of the relationship, and magnitude part tells us about the strength of the relationship. Since this strength magnitude is 0.95, which is very close to plus 1, so there will be a very strong relationship, a very strong positive relationship between the two variables. So sine part tells us about direction, and magnitude part tells us about strength. Next one, third property. If R value is equal to plus 1 exactly, if R value equal to plus 1 exactly, then there will be perfect positive correlation. There will be perfect positive correlation between those two variables. If R is equal to minus 1 exactly, then there will be a perfect negative correlation between those two variables. Fifth one, if R is equal to 0, then we can say that there is no relation between those two variables, and also those two variables are said to be linearly independent. And one more important property is the correlation coefficient. Carl Pearson's correlation coefficient is independent of change of origin, and scale with respect to the magnitude, but the sign depends on scale factors. The sign depends on scale factors. The correlation coefficient is independent of change of origin and scale with respect to the magnitude, but the sign depends on scale factors. Sign of the scale factors. For example, if there are two variables x and y, and the correlation coefficient between these two variables are like some plus 0.85, then we after applying the change of origin and scale technique to these two variables, that means x is multiplied with minus 5 and y is multiplied with the 6. So multiplying the original variables with some constant value comes under the change of scale technique. And I'm adding some constant value 3 to minus 5x and adding some subtracting some constant value 5 from 6y. Then adding or subtracting a constant value comes under the change of origin technique. So let us denote these new variables with the u and v. So in u, the origin factor is plus 3. And minus 5 is the scale factor. Similarly, in v, minus 5 is the origin factor. 6 is the scale factor. Now, the correlation coefficient between u and v. So the correlation coefficient is independent of change of origin and scale with respect to the magnitude. So magnitude of the original variables is 0.85. That doesn't change because of these origin and scale factors. The magnitude doesn't change because of the origin and scale factors. But the sign factor only depends upon the sign of the scale factors here. Here the sign of the scale factors are having opposite signs. So the resulting correlation coefficient is also opposite sign to the given original correlation coefficient, that is minus 0.85. So these are some important properties of Karl Pearson's correlation coefficient. Next, how to determine this Karl Pearson's correlation coefficient if x and y are related in the form of y is equal to a plus bx. How to determine the correlation coefficient, Karl Pearson's correlation coefficient, if x and y are related in the form of y is equal to a plus bx. In case of y is equal to a plus bx, the Karl Pearson's correlation coefficient r is equal to plus 1 if the slope of this equation, which is b, is positive. If the slope of the equation is positive, then r value is equal to plus 1 exactly. If the slope is negative, then r value is exactly equal to minus 1. So with this, let us try to solve some problems under this method, Karl Pearson's correlation coefficient. Now first see the problems on one more important point over here is the limits for correlation coefficient are always in between -1 to +1. But the formula for correlation coefficient is -1 less than or equal to the formula for R in case of Karl Pearson's correlation coefficient is covariance of x comma y divided by sigma x into sigma y, which is less than or equal to +1. Now, by multiplying the entire inequality with sigma x into sigma y, we will get minus sigma x into sigma y less than or equal to covariance of x comma y less than or equal to plus sigma x into sigma y. These are the limits for covariance. So the covariance of x comma y should always lies in between minus sigma x into sigma y to plus sigma x into sigma y. Now, similarly, under Karl Pearson's correlation coefficient, we can compute this Karl Pearson's correlation coefficient using different kinds of formulae. So, those formulae are, the first one is using covariance method. Under the covariance method, the formula for Karl Pearson's correlation coefficient is R is equal to COV of x comma y divided by sigma x into sigma y. Second one, using deviations from arithmetic mean method. So R is equal to, under this method, the formula for R is equal to summation of x minus x bar into y minus y bar divided by square root of summation x minus x bar whole square into square root of summation y minus y bar whole square. And the third method is using no deviations method. Under this method, the formula for calculating Karl Pearson's correlation coefficient is R is equal to n into summation xy minus of summation x into summation y divided by square root of n into summation x square minus summation x whole square into square root of n into summation y square minus summation y whole square. And the fourth method is using deviations from assumed mean method. Under this method, the formula for calculating Karl Pearson's correlation coefficient is R is equal to n into summation dx dy minus of summation dx into summation dy divided by square root of n into summation dx square minus summation dx whole square into square root of n into summation dy square minus of summation dy whole square, where dx is equal to x minus a and dy is equal to y minus b. where A is the assumed mean of X series and B is the assumed mean of Y series. So by using these different kinds of formulae, we can calculate Karl Pearson's correlation coefficient in several situations. Right? Let us see the problems. Now let us see the problems. First see the 14th problem. First see the 14th problem based on covariance. If the covariance between two variables is 20, if the covariance between two variables is 20 and variance of one of the variables is 16, then what would be the variance of the other variable? So variance of one of the variables means it may be either X or it may be either Y also. But in the given options we have been given Y in terms of Y. So we have to assume the variance of X is given as 16. Right? So in this problem, covariance is given as 20. Covariance between X and Y is given as 20. And variance of X is given as 16. Then what will be the variance of Y? Then the question is, what would be the variance of the other variable, that is Y? So if sigma x square is 16, then sigma x is also equals to 4. Now the only relation which is related with sigma x, sigma y and covariance. The only relation which is related with covariance sigma x and sigma y is covariance of x comma y. Covariance of x comma y should always less than or equal to plus sigma x into sigma y. Covariance of x comma y is always less than or equal to sigma x into sigma y. That implies 20 is less than or equal to 4 into sigma y. That implies sigma y is greater than or equal to 20 divided by 4, that is 5. That means sigma y square, we have to find out we have to obtain the variance of y. So sigma y square is greater than or equal to 25. So sigma y square is also denoted by sy square. So the answer is sy square is greater than or equal to 25. Right. Now, based on this Karl Pearson's correlation coefficient, see the problem number 18 first. See the problem number 18. For two variables x and y, it is known that covariance of x comma y is equal to 8, r is equal to 0.4, variance of x is 16, and the sum of squares of deviations of y from its mean is 250. Then find the number of observations for bivariate data. Find the number of observations for this bivariate data. So for this problem, first what is the given information? Covariance of x comma y is given as 8. R value is given as 0.4. And variance of x, that is sigma x square value, is given as 16. And the sum of squares of deviations of y from its mean, that is nothing but sum of squares of deviations of y from its mean is equal to 250. Then we need to find out the number of observations n. We need to find out the number of observations n. But the correlation coefficient, Carl Pearson's correlation coefficient using covariance method does not contain any n. Does not contain any n. Because the Carl Pearson's correlation coefficient using covariance method is given by the formula covariance of x comma y divided by sigma x into sigma y. But in the given data, we have the value of covariance of x comma y. We have the value of sigma x, but we don't have the value of sigma y. So first we need to find out the value of sigma y. Sigma y is the standard deviation of y. So the formula for finding the standard deviation of y, is using the summation of y minus y bar whole square is sigma y is equal to square root of 1 by n into summation of y minus y bar whole square, which is equal to summation of y minus y bar whole square is given as 250. So square root of 250 by n. Now on substituting these values in this formula, R value is given as 0.4, covariance value is given as 8, divided by sigma x value is nothing but 4, into sigma y value is the square root of 250 by n. Right. So here 4 2's 8, that implies on cross multiplication we'll get square root of 250 by n is equal to 2 divided by 0.4, which gives us 5. So by squaring on both sides, we'll get 250 by n is equal to 25, implies n is equal to 10. So the answer of n over here is 10. Next is 19th problem. See the 19th problem. Find the coefficient of correlation between x and y series from the following data. Here, number of observations in both x series and y series are given as 15. So if the number of observations in both x and y series are same, then only we have to calculate the Carl Pearson's correlation coefficient. If the number of observations of x and y series are not same, then we are not able to calculate the Carl Pearson's correlation coefficient. Now, and also arithmetic mean of x series and arithmetic mean of y series are given. Standard deviation of x series and standard deviation of y series are given. And also sum of squares of deviations from mean of x series and y series are given. And sum of the product of deviations of x and y series from their respective means is also given here. So for this data, it is given that n is equal to 15. Number of observations in both x series and y series is 15. And arithmetic mean of x series as 25. And arithmetic mean of y series as 18. And standard deviation of x series is 3.01. And standard deviation of y series is 3.03. And sum of squares of deviations of x series from mean is 136. And summation of squares of deviations of y series from its mean is given as 138. And also given that sum of product of deviations of x and y series from their respective means is given as 122. This is the given information. So by using this information, we need to calculate the Karl Pearson's correlation coefficient. So to apply the covariance method, we do have the values of covariance of x comma y, sigma x and sigma y. But in the given data, we are having only sigma x and sigma y only. We don't have any covariance value. So that we have to apply the deviations from arithmetic mean method, because in the given data we have been given the deviations about the arithmetic mean values. So we have to apply here the deviations from arithmetic mean method. According to that method, the formula is summation of x minus x bar into y minus y bar divided by square root of summation of x minus x bar whole square into square root of summation of y minus y bar whole square, which is equal to 122 divided by square root of 136 into square root of 138, which is equal to approximately 0.89. Approximately 0.89. So the answer is option A. Next, see problem number 20. See problem number 20. Compute the correlation coefficient between x and y from the following data. Compute the correlation coefficient between x and y from the following data. Here it is given that in the given information, n value is given as 10. N value is given as 10. Summation xy is 220. Summation x square is 200. Summation y square is 262. Summation x is 40 and summation y is equal to 50. So here n value is given as 10. Summation xy is given as 220. Summation x square is given as 200. Summation y square is given as 262. Summation x is given as 40. And summation y is given as 50. So in this given data, we don't have any values like covariance of x comma y, sigma x, sigma y. And also we don't have any kind of values of deviations. So in this case, we have to apply the no deviations method formula to calculate Karl Pearson's correlation coefficient easily. So that is R is equal to n into summation xy minus of summation x into summation y divided by square root of n into summation x square minus summation x whole square into square root of n into summation y square minus summation y whole square. Next, so n is 10, 10 into 220 minus 40 into 50 divided by square root of 10 into 200 minus 40 square into square root of 10 into 262 minus 50 square, which is equal to 200 divided by square root of 2000 minus 1600, 400, that is 20 into square root of 120, right? That is equal to 10 divided by square root of 120 is 10.9. So 10 divided by 10.95 gives us 0.91 approximately. So the answer is 0.91, right? So for all these problems, we have to apply whenever we have been given the values of x and y only, then definitely we have to apply no deviations formula to calculate Carl Pearson's correlation coefficient. Next one. Next, see this model 4.5, perfect linear correlation. Perfect linear correlation. So in this, whenever we have been given the relationship like this, y is equal to a plus bx format, then the value of r is. So first obtain the slope of this equation. The slope of this equation is the coefficient of x, that is plus 7. If the slope of this equation is positive, so here the value of b is plus 7, which is positive. So if the slope of equation is positive, then r value is exactly equal to plus 1. If the slope is negative, then r value is exactly equal to minus 1. Now coming to this change of origin and scale technique. Coming to this change of origin and scale technique. So if r between x and y is given as 0.58 and correlation coefficient of u and v, u is minus 5x plus 3 and v is equal to y plus 2. So here the scale factor in u is minus 5 and the scale factor in v is plus 1. So the scale factors in both u and v are having opposite signs. So here it is given that r is equal to 0.48. R is 0.58 means r of x comma y. This is the rank correlation coefficient between x and y. Now u is given as minus 5x plus 3 and v is given as y plus 2. So the scale factor in v is plus 1. So here the scale of x factor u is minus 5 and the scale factor of v is plus 1. The signs of the scale factors in both u and v are having opposite signs. So that r of u comma v is equal to minus r of x comma y. If the sign of the scale factors are having the same sign, then r of u is equal to plus r of x comma y. So here the answer is minus 0.58. Like that, we can solve the problems under change of origin and scale technique. All these problems of can be solved like that only. Now, and there are some small concepts here in correlation coefficient, in correlation chapter. The next smallest concept is about coefficient of determination and coefficient of non-determination. Coefficient of determination and coefficient of non-determination. Before discussing about this coefficient of determination and coefficient of non-determination, first, what this value of correlation coefficient represents exactly? what is the description or what is the conclusion of that value, right? So that value tells us about the proportion of observations of one variable are changing according to the changes of the other variable. This gives us the proportion of changes of one variable according to the changes of the other variable only. So to explain about the proportion of changes of one variable according to the changes of the other variable, there is a better measure than this correlation coefficient. That better measure is nothing but coefficient of determination. This coefficient of determination is denoted by R square. The coefficient of determination is denoted by R square. And R square value should always lies in between 0 to 1. R square value should always lies in between 0 to plus 1. So, and R square value does not discuss about the direction of the relationship. It describes about the proportion of changes of one variable according to the changes of the other variable only. How one variable is explaining the other variable. So, if in any case, if R between any two variables is 0.6, if R between any two variables is 0.6, then the coefficient of determination is 0.36. 0.36 or 36%. If we convert this into percentages, this is 36%. That means 36% of the observations of one variable are changing according to the changes of the other variable only. The remaining 64% of the observations are changing according to some other factors than the variable along with this particular variable, right? So coefficient of non-determination is about the remaining 64%, that is 1 minus R square. Coefficient of non-determination is denoted by 1 minus R square. So coefficient of determination is also known as coefficient of accountable variation. Coefficient of accountable variation. Similarly, coefficient of non-determination is also known as coefficient of unaccountable variation. Right. Now, and next important concept over here is about the probable error. About probable error. Usually, this Karl Pearson's correlation coefficient or any Karl Pearson's correlation coefficient can be computed for sample data. Usually, Karl Pearson's correlation coefficient can be computed for sample data. This sample data has been taken from the population. The sample data has been taken from the population. So while selecting a sample from the population, there may be the chance of getting some kind of errors due to several factors. Maybe the data may not be available, or the methodology you are applying to select the sample from the population is different. So like that, there may be several reasons to get some kind of errors in the sample data while selecting from the population. So those errors are classified into two types. One is called standard error and second one is called probable error. So this probable error gives us, standard error is nothing but the standard deviation of correlation coefficient R. And this probable error tells us about the reliability of the value of R. Reliability and dependability of R. If the probable error value is very low, then we can depend more on the correlation coefficient. If the probable error value is high, then we can't depend on the correlation coefficient we computed from the sample data. So here the standard error of R is given by the formula 1 minus R square divided by root n. 1 minus R square divided by root n. And the probable error of R is given by the formula 0.6745 into 1 minus R square divided by root n, or 0.6745 into standard error of R. An approximate ratio of 0.6745 is 2 by 3 into standard error of R. Right. Now, after finding this probable error, we can verify the significance of R, the importance of R. So to verify the significance of R, we have some conditions. That is, if modulus of R value is less than 6 into probable error, then R is insignificant. That means the computed value of R from the samples is not reliable. That does not have any importance or any significance. If modulus of R value is greater than or equal to 6 into probable error, then R is significant. That means there is a significant importance in the value of R computed from the sample data. Right. These are some important concepts in correlation. See here. If the coefficient of correlation between two variables is minus 0.9, then the coefficient of determination is R square, that is 0.81. In the same manner, we can calculate the probable error also. Find the probable error if R is equal to 2 by root 10 and n is equal to 36. By applying the formula, we can calculate the probable error easily. So like that, we can solve the problems in correlation very easily. I hope I covered all the important aspects of the correlation chapter. So with this, I'm concluding this correlation chapter, and in the next session, we are going to discuss about the next topic called regression. Thank you and one and all.